Hello everyone and welcome to this data science full course by Intellipaat. Did you know that during the last FIFA World Cup, teams were using data science not just to analyze the player performance but also to predict the real match outcomes and fine-tune strategies, which helped the teams to increase their winning chances and play with more confidence by calculating optimal approaches, minimizing risk areas, and reducing mistakes. So, just by looking at the data from every match, every pass, and every shot, they could make smarter data driven decisions on the field. And that's the power of data science. It turns raw information into actionable insights that drive real world decisions. And no, it's not just limited to sports, but the same skills are applicable and shaping the future of businesses, healthcare providers, tech companies, and governments to make smarter decisions, solve complex problems, and predict the trends. Thus, learning data science can be a smart move in 2026. With this, you can be the one driving impactful decisions, leading the growth with the roles like data scientist, ML engineers, and data analyst. And the best part about this, these skills are in high demand, with the salaries ranging from 7 LPA to 20 LPA in India. And that's why Intellipaat has designed this course for you to take you from basics to advanced, where we will start with the fundamentals, then move to the statistics, data visualization, and machine learning. You will also get hands-on experience with the real data sets, build productive models, and create insights you can showcase in your portfolio. So, by the end of this journey, you won't just understand data science, you will be ready to apply it, solve real-world problems, and make impact. So, without any further ado, let's get started.
Are you someone who dreams of becoming a data scientist? Keep watching because today we are going to show you how data science works in the real world. Meet Alex. He's a data scientist. Let's take a quick look at what his day looks like as he works on a supply chain optimization project. The first step in solving any problem is understanding the problem itself. And for this, Alex gets in a meeting with the operation team. He asks questions, digs deeper, and figure out what exactly need to be solved. He creates actionable questions such as, is the goal to reduce cost, improve delivery time, or manage inventory better? He also checks if there are any current issue with the system. Once the business goal is clear, Alex moves to the next step, which is data acquisition. This means collecting the right data for machine to learn from and make smart suggestions. Think of it like cooking. Just as you need the right ingredient for cooking, similarly, you need the right data for a data science project. And this, the process of gathering useful information from different sources is called data acquisition. Alex collects data from inventory system, order management platform, warehouse logs, and third-party suppliers, APIs. And yes, finding the right data takes time, patience, and attention to detail. So once the data is collected, Alex moves to the next step, which is data preparation. Raw data in its natural form is very messy and unstructured. You can't jump into analysis or modeling until the data is structured. And once it is structured, the job is still not done. We still need to clean it, transform it, and organize it. Alex here needs to check the empty row, duplicate entries, missing delivery timestamps, and ensure that there are no inconsistency in the data set. This step is often the most time-consuming part of the entire process. Why? Because here you are making sure that you have the right information needed to solve the actual business problem. So once the data is clean and structured, Alex moves on to Exploratory Data Analysis or EDA, a very critical step where he identifies the feature that really matter. But why is this important? So let's say you're trying to predict delivery time. Would features like product cost, payment mode, or ID help? Those are basically the order details. They have no influence on the delivery time. So keeping them in our data science process doesn't make any sense. If we include them, we might weaken the model or introduce unnecessary noise. Think of it like cooking for one person. You don't grab everything from the fridge, just the exact ingredients you need. That way you don't overcook or waste time. EDA helps you do the same in a data science project. Focus only on relevant features so that your model is efficient, accurate, and purpose-built. Next comes the step 5, where a data science model will be prepared. Alex already have a clean data at hand. Now he trains this acquired data with machine learning algorithm that fit best to the business problem. He can apply model like random forest, k-means clustering, and linear regression. He trained these models and evaluate their performance. To do that, he used metrics like accuracy score or confusion metrics. These metrics help Alex understand how well models are able to perform on test data after they are trained. Alex usually prefers Python for this, though he also uses R or SQL depending on the requirement. Now you might think that we have accurate model, that means the job is done. Well, not true. Alex now needs to present his finding to business stakeholders again. Alex meets with the business team again to communicate his finding in a clear, straightforward way. He uses tools like Tableau, Power BI, and Excel to create visual reports and dashboards, which are self-explanatory and easy to understand for business leader. Once Alex gets the approval, he then moves to the next step, which is deploying the model. Once it is deployed, Alex monitors real-time metrics using dashboard and continues fine-tuning the model's performance. And this is how Alex completes a data science project. Every data science project generally starts from business problem, data acquisition, and then come stages such as data preparation, EDA, modeling, reporting, and end with deployment. With Alex's journey, now we have a clear picture of entire data science project lifecycle. So let's move forward and look at how data science is transforming industry today. In retail, it helps forecast demand and prevent stockouts during peak sale periods. In logistics, it finds the most efficient delivery routes and reduces fuel uses. In HR, it helps predict employee turnover and improve team retention. In healthcare, it accelerates diagnosis and powers personalized treatment. A data scientist can take on many roles. You can become a business analyst, machine learning engineer, data engineer, or a specialized supply chain data scientist. In 2025, the average salary ranges from $100,000 to $170,000 depending on your skills and industry. Whereas in India, they earn between 7 lakh rupees to 18 lakh rupees as per Glassdoor. So are you ready to begin your journey as a data scientist? If yes, start today because the world of data is only getting bigger and it needs people like you. Should you become a data scientist, data analyst, or a data engineer? If you're just entering the world of data, you have probably come across these three roles: data scientist, analyst, and data engineer. And yeah, I get it, they sound similar, and honestly, I was confused too when I first started. But here's the truth: each one is totally different and plays a unique role in the world of data. A data scientist works on prediction, machine learning, and advanced algorithm. A data analyst focuses on interpreting data, turning raw numbers into clear insight that help team make better decisions. And a data engineer builds the pipeline and system that move and process data. They make sure everything runs smoothly behind the scene. Now, if you love working with numbers, solving puzzle, or finding hidden pattern, great. But where should you actually start? Maybe you're excited by AI and ML. Data science might be your thing. If you're more into coding, building system, or enjoy backend development, that data engineer could be a better match. And if you enjoy visualizing data, making reports, and helping businesses make smart decisions, the analyst role might be perfect for you. Whenever you are in this decision-making journey, just know this: you're not alone. Many beginners ask the same question, and the answer lies in understanding what each role it really involves and where your interest aligns. Choosing the wrong direction can slow you down or even make you feel lost later. That's why it's super important to understand what each of these roles looks like, what they do, what tools they use, and how do they help companies, especially in areas like marketing or business growth. Also, let's be real, tech is changing fast. With AI, cloud computing, and automation on the rise, some roles will be in high demands than others. So if you're planning your career for 2025 and beyond, you need to know which role will actually help you stay relevant and ahead of the curve. That's exactly what we will cover in this video in the simplest way possible. By the end of this video, you will understand what each role means, which one fits for your interest, and which path can lead you to the strong future-proof career in data. Let's start with data science hierarchy, which is often visualized as pyramid. At the foundation of this pyramid, we have data engineer. Then comes data analyst, and sitting at the top are the data scientist. Let's start with the data engineer. So imagine a company running digital campaign across platforms like Facebook, Google, Ads, Instagram, and email newsletter. Each of these channels on which the ad is run generate tons of raw data: impression, clicks, conversion, bounce rate, and user behavior metrics. Now, all of this data comes in different format like JSON, CSV, or even unstructured log files, and from various sources like APIs, internal databases, third-party tools, and web analytics platform. Now, here comes the work of a data engineer who is responsible for gathering all this scattered, messy information and converting it into something structured and usable. Their job is to collect, clean, organize, and move raw data into a centralized location, which we call as databases like Google, BigQuery, Amazon Redshift, or Snowflake, making it easy for analysts and scientists to access and work with it. On a day-to-day basis, data engineers build and manage complex data pipeline using tools like Apache Airflow. They work with real-time live data streaming platforms like Apache Kafka to ensure that data flows in continuity. The programming language they use here is Python, SQL, or Scala. Perform robust data transformation to make raw input clean and structured. For large-scale operation, they rely on distributed computing system like Apache Spark or Hadoop. To become a strong data engineer, you will need to master several tools and technologies. You will need to know Python, SQL, Scala for coding. You will work with data warehouses like BigQuery, Redshift, and Snowflow, and use Apache Airflow or DBT to build ETL pipeline. For real-time or big data tasks, tools like Kafka, Spark, and Hadoop are essential. And since most of work happens in cloud, get comfortable with AWS, GCP, or Azure for storage and computing. Now the data has been collected, cleaned, and stored by data engineer. From here, data analysts will take over the second layer of pyramid. Their core job is to interpret the data, spot trends, uncover pattern, and deliver actionable insight. Continuing with our marketing example, once all the campaign data is centralized, the analyst steps in to answer important questions like which ad performed the best, which audience segment had the highest conversion rate, or what time of day got the most engagement. To do this, data analysts use tools like SQL for querying databases, Excel for organizing data, and visualization tools like Tableau or Power BI to create interactive dashboards and reports. They may also use Python libraries like Pandas for data manipulation and Matplotlib or Seaborn for plotting graph and visual trends. Their insights are crucial for marketing team, product manager, and executive to make data-driven decisions like where to increase ad spend, what type of content is resonating with user, or how to optimize landing pages. So we can say on a daily basis, data analysts write SQL queries to pull relevant data, clean and process data sets in Excel or Python, perform exploratory data analysis EDA, and build dashboard to track KPIs. They often meet with stakeholders to understand business questions and translate them into data queries. To succeed as a data analyst, the essential toolkit includes Excel, SQL, Tableau, Power BI, Google Analytics, and basic Python scripting. Equally vital are the communication skill, as analysts act bridge between raw data and business team, helping transform numbers into decision. Once the data engineer has prepared the data and data analyst has uncovered key insights from it, the baton is passed to the data scientist. So at the very top of the data workflow sits the data scientist, often seen as the most advanced and specialized role in the data ecosystem. Unlike data analysts who explain what happened or data engineer who ensure the data is usable, data scientist focuses on predicting what will happen next. Their job is to apply machine learning models, statistical algorithm, and even AI techniques to forecast future trends, automate decision, and uncover complex relationship. So let's see a marketing campaign example once again. While the analyst identify which ad works best, the engineer made the data accessible, the data scientist might build a predictive model that estimates which user segments are likely to click on the next campaign, how likely a customer is to make a purchase within the next 7 days, or which customer or risk of unsubscribing. These insights allow companies to proactively target the right audience, reduce churn, and increase ROI. To achieve this, data scientists work extensively with tools like Python and R for data manipulation and modeling, and use powerful libraries like scikit-learn, TensorFlow, or PyTorch for building machine learning models. Their work requires a strong grasp of mathematics, especially probability, statistics, and linear algebra. On a day-to-day basis, a data scientist will gather training data, pre-process it, select features, experiment with different machine learning models, evaluate model performance using metrics like accuracy or precision recall, and tune hyperparameters to improve results. Once a model is working, they may also help deploy it into production or collaborate with engineers to integrate it into business system. So in short, data scientists are like the brain of the operation, pushing boundaries to bring predictive intelligence and automation into decision making. So if we look all the three roles together, we can see how they complement one another in smooth flow. In marketing and many other business functions, this workflow is what powers smarter campaign, better customer targeting, and ultimately stronger results. Now let's talk money, because being honest, it matters a lot. The pay scale for each role can vary based on the location, experience, company size, and your exact skill set. On an average, data analysts start with packages between 6 to 10 LPA. Data engineer often earn between between 8 to 15 LPA, and data scientists can make anywhere between 10 to 25 plus LPA, especially if they have worked in top tech firms or have advanced degrees like a master's or PhD. Generally, the more specialized your skill set, the higher your potential salary. But that also means more learning and experience is required. So the big question is, which one you should choose in 2025? In 2025, all three, data engineer, data analyst and data scientists, will continue to be in high demand. But recent trends show employers are now favoring hybrid professionals, those who can both analyze data and build infrastructures or model. This means someone who knows SQL and Python and understand machine learning concept is becoming a rare and valuable asset. So what's the best entry point in 2025? If you're just starting out and want a strong foundation, data analyst is often the smart choice. You can learn how to ask right question, explore real world data and distill into stories without diving immediately into heavy engineering or deep math. From there, you can pivot based on what your real passion lies. If you discover that you love building the system that deliver data, transition toward data engineering. If you are drawn to algorithm, modeling and AI, then push towards data science. So in conclusion, don't rush to call yourself a data scientist right away. Take time to explore all three roles, understand what excites you the most and then build your skills in that direction. The data world isn't just one path. It's a ladder and every steps count. Thank you and see you in the next video. So before we move ahead, let's quickly go through what the entire roadmap looks like, just to give you a clear picture of the journey. We will start with statistics, the heart of data science. Spend 1.5 to 2 months learning core concepts like mean, median, standard deviation, probability, Bayes theorem, hypothesis testing and p-value. Next, we will move to Python, a simple yet powerful language used everywhere in data science. In 1 month, you will cover the basic like loops, function and important libraries like Pandas, NumPy, Matplotlib and Seaborn. Then we will cover SQL, the language for working with databases. In about 1 month, you will learn how to write queries, filter data and perform join to fetch only the data you need. After that, we will take a quick stop at Git and GitHub. Just 1 week is enough to learn version control, collaborate with others and showcase your projects publicly. Next, we will focus on data collection and visualization. Over 1 month, you will learn how to clean messy data and turn it into visual insight using tools like Matplotlib and Seaborn. Then we will move into machine learning, the most exciting part. In 1.5 months, you will explore key algorithms like linear regression, decision tree and clustering and learn how to build predictive models. After that, we will go deeper with deep learning. Spend around 1 to 1.5 months understanding neural network and working with framework like TensorFlow and PyTorch. Finally, if you want to take it even further, we will explore big data tools like Spark, Hadoop and MongoDB. So in total, you're looking at around 8 to 9.5 months to become a solid data scientist and 1 extra month if you want to specialize in big data. Take it step by step and you will get there before you even know it. Let's discuss in detail. So ideally, the very first thing you need to do is go through the concepts of statistics. See, the term data itself suggests that you will be dealing with a lot of numbers. And if you lack the fundamental math knowledge, doing so will become very difficult. Even if you were to carry out a simple analysis, let's say you want to know if YouTube changes the color of subscribe button to green, what will happen? In that case, statistics will be important for you to understand the noise in data, to understand what parameter is critical in the captured data, etc. Even the basic concepts or fundamental ideology behind machine learning like neural network is born out of mathematics. That's why we want you to dedicate a month and a half to revising critical mathematical concepts for data science. See, if you have done engineering and 10+2, you will already be acquainted by ideas like probability, normal distribution, chart, graph, etc. All you need is to revise those concepts and learn a few more critical concepts like mean, variance, bias, Bayes theorem, sampling, hypothesis testing, standard, normal distribution, t-test, etc. To help you do that, we have created a free statistics for data science course. You can just search for free Intellipaat statistics for data science course over Google search to come across this video page. I will also be dropping it in the description below. See, you don't have to become a mathematician here. You just need to understand enough math to learn and understand the data science concept. Once you have done that, it's the time we get started with the next dependency, that is learning the programming language. For data science, primarily there are only 2 languages, Python or R. I would prefer learning Python since it is a large-scale programming language and it doesn't stop at data science. Again, you don't have to become a Python developer. You just need to learn enough of Python programming to be able to do data science course. So here's a list of concepts you'll have to master: operators, list, dictionaries, variable, and control statements. Getting familiar with programming language is not going to be as difficult as it might seem to you right now. Once you get started, you will realize that you have got it. Next up, you need to go through libraries such as NumPy, Pandas, Seaborn, and Matplotlib. Basically, you will be doing the exploratory data analysis as the first task in any data science process. Hence, exploring these very basic libraries is a must. Learn to create the data frames and NumPy arrays, how to carry out the mathematical operations on them, and learn about different Pandas and NumPy functions. Also explore the different charts available in Seaborn and Matplotlib. Understand what each chart basically resembles, basically comprehend the language of charts and graph. You can spend 15 days doing this particular activity. Next comes SQL, structured query language, the language that lets you talk to databases. Since almost all businesses store their data in relational databases, knowing how to write query is very essential. For example, if you're working at a bank and need to identify high-risk customer based on credit score and transaction pattern, you would use SQL to extract only the relevant data rather than downloading massive data set and filtering them manually. SQL helps you query only what's needed, saving time and system resource. I would recommend you guys to go over Kaggle, explore many notebook and figure out how people understand the data. Then try to analyze different sorts of data sets on your own. Doing this activity will give you a boost and confidence as well as help you understand why you did what you did till this point of time. Once you're working with data and code, collaboration becomes the key. That's why Git and GitHub are indispensable, which you can easily do in 1 week. These tools help you track changes in your code, revert to previous versions, and collaborate with team members seamlessly. Imagine you're working with a team on a machine learning project. One member tunes the model, another prepares the data, and another writes the test. In that case, collaboration becomes very easy. Moreover, GitHub acts your public portfolio where recruiters can see your code, collaborations, and problem-solving style. As you move forward, you will realize that data really comes clean. That's where data cleaning, collection, and visualization comes in. Real-world data is very messy. It can have missing values, typos, or inconsistency. Once cleaned, visualizing the data using libraries like Matplotlib, Seaborn can reveal trends like seasonal sales drop or product preferences, helping the business make informed decisions. Before you dive into building machine learning model, it's really important to understand some basic math because that's where everything is built. Take linear algebra, for example, in ML. Data is often stored as vector and matrices. So if you have ever wondered how Netflix recommends movie, it's because it stores user preferences and movie details in giant table or matrices and uses math like multiplication to find pattern. Then comes calculus, especially when training a model. Let's say you are teaching your model to predict house prices. It doesn't get it right the first time. Calculus helps the model learn from its mistake by slowly adjusting itself using a method called gradient descent. It's like trial and error, but with math behind the scene making those adjustments smarter. Then comes the heart of data science, machine learning. ML allows system to learn from data and make prediction or decisions. Algorithms like linear regression, decision tree, and k-nearest neighbor are used widely in an industry. For example, at a telecom company, you might build a model to predict which customer are likely to leave. Using past customer data, machine learning can classify new customer at a risk, allowing the businesses to take action in advance. This is how business convert data into strategy. Let's say you understand a certain ML algorithm after watching a video on YouTube. Then you need to go onto the Kaggle and go through the sample exploratory notebooks based on the very same algorithm. Take pen and paper and note down what you understood about the exploration. Learn about features, selection techniques, and fine-tuning can be achieved. Keep on doing the Kaggle notebook exploration until you gain a knack for picking pattern in datasets. When machine learning alone isn't enough, especially with complex data like images or voice, deep learning becomes essential. It uses artificial neural network with multiple layers to detect intricate patterns. Think about building a voice assistant like Alexa. You would need recurrent neural networks, RNN, or transformer to understand speech and respond accurately. Similarly, deep learning powers facial recognition system in phones, automated driving in cars, and even disease diagnosis in healthcare. Finally, when data grows beyond what normal tool can handle, you will need to master big data tools like Hadoop, Spark, and Hive, which help process massive data sets distributed across many machines. Imagine analyzing all Uber rides in Bangalore city for an entire year, including location, data, wait time, driver feedback, and payment. Processing this in Excel or Panda would be impossible. Spark allows you to process such large-scale data in parallel, in minutes instead of hours, making it vital for enterprise-level network. By fulfilling the above step, you will acquire all the beginner level data science skill that can get you a job. Next, you need to work on building your portfolio as a data scientist. You need to have some good projects under your belt. You can get them by participating in Kaggle competition and showing off your skills to the world. Not only this will help you build some awesome projects, but it will also provide you with awards and employment opportunities. Mention the projects and competition you have participated in over to your LinkedIn profile. You can definitely master data science if you stay consistent. We know tracking progress can be tough, so we have prepared a slow-paced, year-long study plan. The link is in the description. Remember, learning takes time. There is no shortcut, and if someone promises instant result, don't fall for it. The complete roadmap is also given in the description below.
If you're just getting started in data science, here's something important you need to know. You don't have to be a hardcore programmer. That might come as a surprise, but it's true. Data science is not about building complex apps or writing thousands of lines of code. It's about making sense of data, understanding patterns, finding insights, and solving real-world problems using numbers. And to do all that, the tool you'll use the most is Python. When you first start learning Python, you might feel the urge to dive into data structures and algorithms. And while it's useful to know the basics, you don't have to spend months solving binary trees or linked lists. Yes, you do need some programming, just enough to be able to work with data, read it, clean it, transform it, and get results out of it. Before we dive into the main concepts, let me quickly give you an overview of some basic Python that you'll need along the way. Now, if you've worked with languages like C or Java before, you'll find Python a lot easier to pick up. Let's start with creating a variable. In Python, you don't need to mention whether a variable is an integer, a string, or a float. You just need to assign a value and Python figures it out for you. For example, writing height equal to 175 is enough. Python knows it's a number, and if you write name equal to John, it understands that it's a string. Now let's say you have two variables representing the heights of two people. You can use a simple if condition to check who is taller. After that, one of the most important things in programming language is functions, and in Python, creating a function is as simple as using def keyword, giving it a name, and writing the block of code you want it to run. Then there's something you'll use a lot in data science, that is lists and dictionaries. In Python, a list is just a collection of items. It can hold numbers, names, or even a mix of different data types. You can add, remove, or change items easily, and Python gives you a lot of built-in tools to work with them. Next is the dictionary, a set of key value pairs. A dictionary lets you look up a word, the key, and get its meaning, the value. So if you want to know the person's age, you just use person and in the bracket you use the age and it'll give you the value. Now let's talk about NumPy, which stands for numerical Python. You might be wondering why use NumPy when we already have lists. Well, NumPy arrays are faster, take up less memory, and come with tons of built-in mathematical functions. Most importantly, NumPy allows you to create multi-dimensional arrays like tables or matrices, which are extremely common in data science, especially in machine learning. So instead of just a one-dimensional list, you can create something like this. This represents 2 rows and 3 columns in a matrix. You can also perform operations on entire rows and columns at once without any loops. NumPy is built for high-performance computing, which makes it perfect for scientific computing.
So before we move ahead with pandas, I want you guys to understand the basic difference or the basic requirement why we need pandas. Alright, so basically we saw in NumPy how we were able to perform various numerical as well as arithmetic operations on our arrays. That was basically a data given to us in the form of arrays, right? So why exactly do we need pandas, or what is pandas? Alright, so in order to understand that, I am going to go ahead and show you guys an Excel sheet. So as you can see over here, I have some data. So once you guys get familiar with data analysis, you guys will be able to tell me that this is something known as house price prediction data set. But we need not get into the details of that right now. So for now, all you have to understand is that there are different features or different columns representing the features of a house, right? So we have the square feet, that is the area of the house. We have the city, we have the state, we have the condition, we have the waterfront, which basically is telling us whether there is a waterfront. So basically 0 and 1 is how our data is being represented. Okay, so the number of floors, the price. All right, so we have all these features in our data. All right, now if I were to represent the same thing in a NumPy array, I would have my array something like this. Okay, so say I'm just representing 2 houses, and these 2 houses have 2 bedrooms, 2 bathrooms. Okay, and the other house has just one bedroom and one bathroom. Okay, this is what my NumPy array would look like. Okay, this is basically my house 1, my house 2, and this is my bedrooms and this is my bathrooms. Okay, so do you guys agree with me or not? Would our NumPy array look something like this or not? Except we wouldn't have this information with us. We would just have an array that would look like this. So this is the major issue that comes in NumPy when we are dealing with data. Okay, so since we only have 2 columns over here, maybe we can try and remember that the first one is bedrooms, the second one is bathrooms. But in case we have 12 or say 50 columns, how are we going to remember what each and every column is representing? So this is where Pandas steps in. Pandas is nothing but a tabular format of data, just how we saw in Excel. It gives us a similar representation of data in our notebook. Alright, so before we go ahead and see the demonstration with Pandas, first we'll understand why Pandas. So here are some of the important features that Pandas provides us. So it gets very easy to import our data sets. It could be a CSV file, it could be an Excel sheet, okay? It could even be your SQL database. So you can import any sort of data set in your Pandas environment. I'll be using Google Colab in this video, but you can use Anaconda or even your VS Code. Alright. Then comes your data cleaning. So this is a very important step. Now what exactly does data cleaning mean? So when we say data cleaning, we are talking about missing values and majorly the invalid values. Okay. So when we talk about missing values, okay, let me go back to my Excel sheet. Okay, so this is the data that I have, right? So say in case of this particular value over here, 10500, what if I had a blank cell over here? That would represent my missing value. Okay, so that is basically what missing value means. So if we have a particular data set and some of the values in our data set are missing, so whenever we're dealing with that kind of scenario, we will be dealing with those missing values. Okay, we will be seeing how we can do that with Pandas. And the other case is invalid values. So say I have an age column. Okay, now we know our age can normally range from 0 to 100. Taking the worst case scenario over here, we have 100 or say 120. Okay, it cannot go above that and it cannot go below 0. Alright, so this is basically a standard age range. But what if I have a value say 200 in my age column? Now this is basically an invalid value, right? I cannot have an age that is 200 if it's for humans especially. Okay, so I would understand that there is some typing error or there is some mathematical error, and the common way of dealing with this invalid value would be dividing by 10, right? So 20 is a valid age, but 200 is not. Okay, so that is basically what invalid value means. Size mutability. So we can easily add and delete columns or rows. Okay, then we can reshape our data set, we can pivot our data set, we can efficiently manipulate and extract from our data set. And most important step is statistical analysis. Okay, so we can easily have all the statistical analysis of our data with just a few lines of code. Okay. Now moving on to the prerequisites to learn Pandas. So you need to know any programming language, preferably Python. But if you know any other programming language as well, it's not an issue. Okay. And the next one is maths. That is basically you need to know some stats or inferential statistics. You need to have a basic idea like what is standard deviation, what is variance, what is mean, median, mode. So basically you need to have a basic idea of all those terms. So moving on to Pandas, we have two primary data structures in Pandas. First is series, second is data frame. Okay, now what is data structure? Data structure is basically a collection of data types that provide the best way of organizing the items or the values in terms of memory usage. Okay, so series is going to be our one-dimensional data structure, whereas data frame is a two-dimensional data structure. Okay, now series basically represents only a single column from the entire data set, whereas a data frame is able to represent the entire data set. Okay, that's the basic difference. So let's go ahead. Okay, so series we already discussed is one-dimensional. Why it's one-dimensional? Because a series would look something like this. So say I have a price column and these values would be represented by an index value by default. Okay, and remember our index is always and always going to start from 0. So this is our series. Okay, So over here, you cannot say this is a two-dimensional or it has two columns. This is the index and this is our one and only column. Okay. So this is why series is a one-dimensional data structure, because it can accommodate only one column and you can extend it to as many rows as you want. Okay. So it is a one-dimensional labeled homogeneous array. Homogeneous array means it can accommodate only either integers or string values. Now, it's not that if I were to add, say, a string ABC, I would get an error. Rather, if I were to add a value like this, all of my integers would be converted to string. Okay, so this is why series is called a homogeneous array, because if I add a single string value into my series, all of my integers are going to be converted into string, and my data type of this series would be object. Okay. If I were to have only integers, my data type would be integers. Okay. So this is basically what it means. And very important property is it is size immutable. Now what this means is I cannot delete a particular row from here. I can only remove it, and when I perform the remove operation, basically I am going to be returned a new string. That is, my string originally is not going to get manipulated, rather I'm going to be returned a new string where my values would look something like this. Okay. So this is basically what size immutability means. And even if we try to append a new element, we would be again returning a new series rather than manipulating or rather than changing the original series itself. Okay. Now moving on to data frames. It is a two-dimensional data frame because we can have multiple columns. So we can have a price column, we can have number of bedrooms, number of bathrooms, and so on. Okay, we can have unlimited, or you can say n number of columns and n number of rows. So basically it can be extended in this direction as well as this direction, whereas series was able to extend itself only in this direction. Okay, and this is going to be a size mutable tabular structure, and it can be heterogeneous type. Heterogeneous means we can have, say, integers in this column and a string, all the string values in this column. Okay, so we can have multiple data types supported in data frames, and it is size mutable, means you're easily able to add and delete the rows and columns. Okay, so I hope the difference between series and data frame is clear. So let's go ahead and look at the implementation in our notebook. But before we do that, I hope you guys remember you are supposed to install Pandas using pip install command. Let me just show you guys quickly. So you can go to your terminal or any command prompt, and all you have to do is type pip install Pandas. When you run it, you're going to have a few lines of code run for you, and then finally you're going to get your requirement is satisfied, and then after that you can proceed with importing Pandas as PD. Okay. So again, this is an alias. Just like we used an alias for NumPy, we are going to use one for Pandas, which is PD. Okay, so I'm going to run it. And if you guys remember, I told you guys in the NumPy video that NumPy is going to be used throughout your data analysis process. So right now we are going to focus only on the Pandas features, but when we come to real data sets, which I'll be showing you, I'll be importing a real data set also using a CSV or an Excel file, and then I'm going to show you how NumPy and Pandas both are going to be used to perform various operations on that data set. Alright, but right now we are going to be only focusing on Pandas, understand the features and the implementation. Okay, so as you can see, I have successfully imported my Pandas, and the green tick over here basically represents that the operation was successful. Okay, so now what I'm going to do is I'm going to create a basic series using pd.series, and I'm going to do so using a list. Okay, now if I go ahead and print it, so you can see my data type is int64 because all of these are integers, and by default I got an index value of 0, 1, 2, 3 and 4. Okay, so as I told you, my index is always going to start from 0. And now if I were to add another element, say a string value ABC, you can see now my data type is object, and all of these that were integers earlier have been converted into a string form. Okay, so I am going to remove this for now because I want to show you guys some operations that we can perform in series. So I can go ahead and check the data type of my series. It's int64. Then I can go ahead and check the values of my series. Okay, so you do not need any parenthesis. So these are the values of my series data structure. So you can use s.index to check the index of your series. You can see over here my starting value is 0 and my stop value is 5 and my step value is 1. Alright, so basically I have my index from 0 to 4. So here you can get an idea about your index as well. Okay, and lastly you have s.name. So it's not printing anything because it's none. So if I print s.name, you can see it's none because we have not given any sort of name or any sort of value to a column. Okay, in order to assign a value to our column, we can just say s.name and we can assign a value to our column, say those are just numbers. So I'm going to write numbers, and if I print my series, you can see this is what my series is going to look like. Alright. So that was it about the random functions. Now we're going to look at an important topic called indexing. Okay. So you can do indexing using square brackets like we normally do for lists, and we have also done for NumPy arrays. So similarly, you can do it for your series in Pandas. So if I want the first element, I'm going to say S0 and I get the first element, that is 10. Okay. So if I want multiple elements, all I'm going to do is S0 to 2, and you can see my ending index or my ending value is not included in my output. So let me just comment it over here, and then we have the step value. So we have done this indexing in list as well, and you guys are well aware that your starting value is always included, whereas your ending value is never included. Alright, so whichever value you want at the end, you give your stop value plus 1 to your desired value you want in the end. Alright, so say I want values at index 2 and 3. My syntax for that would be S2 to 4. Okay, so as you can see over here, I got my values at index 2 and 3. Alright. Now another way to perform indexing is by using a function called ilog, which basically does location based indexing. So what this means is it is going to use the indexes, that is the 0, 1, 2, 3, 4 that you have as indexes, and it is going to fetch the values at those particular indexes for you. So all you have to do is say s.ilog and value at 3, and I print it, and you can see I got 40. So at index 3, I have value 40 and it's giving me the correct value. Okay. Now if I want multiple values, all I have to do is s.ilog and use double brackets and pass all the indexes that I want my values at. Okay. So I want value at index 1, 3 and 4. So as you can see, I got my output just as I intended. So this was all about location-based indexing. Now another important feature in series is that you can change the index according to you. Okay. So instead of 0, 1, 2, 3, 4, these numbers actually represent the calories. Okay. These are the different calories. So you can see I have changed the column name to calories. And now I want these calories to represent the fruit. Okay. So I'm going to create a list of all the fruits that are present in my carries. So you can see I've created a random list of fruits and I've stored it in the variable index. Now what I'm going to do is I'm going to say s.index and I'm going to pass my index variable, and then I'm going to print my series. So you can see over here, I am basically trying to say my apple has 10 calories, banana has 20 calories, grapes has 30 calories and so on. Okay. So this is how you can change your indexes according to the information you are trying to represent. Now do not comment that I have put wrong calories for the wrong fruits. This is just a random data that I have created just to show you guys how indexing works. Okay. So now if I try to access any value using my indexes, so if I want to find the calorie of grapes, I can just say S grapes. Okay. In square brackets. Now can I use ilog function over here? Let's try it. Okay, so I get an error because this is not a location anymore, right? So when I had my numerical indexes, ilog was working absolutely fine. So I can still use ilog, but for my numerical indexes, right? The original indexes, that is, we have indexes in lists, we have indexes in NumPy, we similarly have indexes in series as well, okay? So we can do that by ilog, but again, how will we remember what is index 3, right? So that is why we have another function called log. This is label based indexing. Okay. So using log, we can go ahead and say, and you can see I get my value. Okay. Now another important thing you need to remember is in label based indexing, your start as well as stop value both are included in the output. Okay. Now, this is a very important thing that you need to remember, because unlike normal indexing or the indexing that we do in list, numpys and all, whenever we are using a normal list, our stop value is never included. Alright. Now, say I want my calories of banana, grapes and orange. Okay. So, what I'm going to do over here? So, you can see between both of them is clear. Difference between lock and iLock is clear. Okay. So, let me give you guys a quick recap. We learned how to create a series using a list. Okay. We saw the default indexes. We saw the default name, which is none of the column. Then we saw how to check the data type of the series. We saw how to check the values and the indexes of the series. Then we saw how to rename our column or the series. Okay. And then we went ahead and looked at indexing. We saw normal indexing. We saw indexing using iLock. Okay. Then we went ahead and changed the index of our series. We gave a different set of indexes to our series using s.index equal to the new index. And then we went ahead and performed indexing on our labels. That is, we used the new indexes to index the values. And then we also looked at the label based indexing, that is using lock. Okay. Now, if I want to access multiple elements over here, multiple values, again, I have to give double brackets and I can say grapes and then I want apple and I can print it. So you can see I got my desired output. Okay. So that is all about indexing. Now, let's also see how we can create a series using a dictionary. Okay. So I have already created a dictionary for you guys, which is basically fruit protein. So our keys are the fruits and our values are the proteins or the grams of protein stored in that particular fruit. Okay, so this is our dictionary. Now, if I want to create a series out of this dictionary, all I have to do is say, I'm going to name it S2 because this is my second series, and I'm going to say pd.series fruit protein and I'm going to print it. Okay, so you can see, and by default, the name of our column over here that is representing the protein is 0. So I can go ahead and say name equal to protein. Let's run it. Now my series is giving us a complete information of what our data is representing. Okay. And you can see the data type over here is float. Okay. Again, you can go ahead and perform the similar kind of operations on this particular series. I will be sharing this notebook with you guys in the description below so you can download it and do the necessary operations that we saw in our earlier series, that is our series S. So all those operations can be performed on this particular series as well. So I want you guys to pause the video, download the notebook and perform these operations. And if you guys face any doubt, comment it in the chat box below. I will respond to you guys at the earliest possible. Okay. Alright, so I'm assuming now you guys are done with the earlier operations. Now we'll be looking at something important and something new, which is called conditional selection. Okay. Now what conditional selection basically means is, now I want to fetch all the fruits over here that have protein greater than 1. Okay. I want to find out all the proteins that are greater than 1. So what I'm going to do is, I'm going to say S2 greater than 1. Now you can see over here I've got boolean values that are representing true and false. So wherever I have protein greater than 1, I got a true. And wherever it is less than 1, I got a false. Okay. But what if I want only those rows in my output that have the value greater than 1? So what I'm going to do is I'm going to put this conditional selection statement inside my series. So I'm going to pass it inside my original series and you can see I got the result. Okay, so all these fruits have protein greater than 1. Okay, so this is basically how conditional selection works. It is first going to provide you with a mask series, which is basically a series of boolean values true and false. And if you pass that masked series into your original series using square brackets as we just did, you get your desired output. So our next topic is logical operators. Okay. Logical operators, we have and, or, and not. So I hope you guys are clear with what is and, or, not. Okay. If you guys are not, let me just give you guys a quick example. Okay. So say I have two values. One is true. The other is also true. Now, if I do a and between these, If I perform an AND operator between these, my result is also going to be true. Okay. Now, if I have a true and a false, and I perform an AND operation between these two values, my result is going to be false. Okay. Similarly, if I have a false first and a true later on, and I do an AND operation, my result is going to be false. And if both my values are false, my result is again going to be false. Okay. So, we need both our values to be true in order to have a result true. Okay. But in case of OR, any one of our value has to be true. This is going to be true. But if I have true or false, it is again going to be true. Okay. If I have false or false, then it is going to be false. Okay. So this is basically and or. Okay. Now let's see how it is used in a series. So say I want to give a range. Okay. I want to have all my fruits, or I want to see all those fruits which are greater than 0.5 but less than 2. Okay. So all I'm going to do is S greater than 0.5 and S is less than 2. So this is the syntax that you have to follow. Okay. So you can see I got the true and false values. Now if I want to find only those rows which satisfy this condition, so you can see all these values are going to be between 0.5 and 2. Okay. I can say I can say less than or equal to 2. And now I have my fruits which have the protein value equal to 2 as well. Okay. So this is how AND is performed. So basically what happened there is wherever we had 0.5 and greater but less than 2, this range was passed to us when we use the AND operator. Okay. Now if I were to use the OR operator in this particular scenario where I'm trying to find this range, would I get this desired output? No. For the OR operator, my first condition would be greater than 0.5. So I would get all my values that are greater than 0.5. And then my second condition would be less than 2. So I would get all the values which are less than 2. That means below 0.5 as well. Alright, so as you can see over here, I have 0.3 and I have 2.6 as well in my output. So this is basically telling me that I have used an OR operation over here. Okay. So similarly, you can use AND and OR and you can also use your NOT operation. So I can say I want all my values which are not greater than 1. Okay. So you can see all these values are smaller than 1. Okay. So this is how the logical operators like AND, OR and NOT are performed. And then finally we have a topic of modifying the series. Okay. So say instead of my calorie of mango to be 0.8, I want it to be 2.8. So what I'm going to do is, just like a normal list, I'm going to go ahead and say S mango and I'm going to say 2.8. Okay, so it's run successfully. Now if I print my series, you can see my mango protein has been changed to 2.8. Okay, so this is how you can modify your series. Okay, at any particular index. You can change the value. You can also change the index, but you will have to pass your entire index again. Okay. So this was all about series. Now we are going to move ahead with data frames. So I hope series was clear. If you guys have any doubt, comment your doubts in the chat box below. I will respond to you guys as quickly as possible. And do make sure that you guys have this particular notebook downloaded in your systems and you guys are working with me side by side. So that's going to make the entire process more fun. Okay. So far you guys have gotten a basic understanding of series and we have already covered NumPy. So I have a question for you guys. So basically I have a series and I want you to find the answer of this particular query. Okay, so if I say s dot not null and I say I want a sum of all the values that are not null, I want you guys to quickly comment the answer in the chat box and tell me what's going to be the answer if we run this particular query. Okay. So moving on, let's look at our very next topic, that is data frame. So it is important and very interesting if you guys understand it carefully. So basically I have some data in the form of dictionary, as you can see over here. So I have some names, I have some ages, and I have some departments and salaries. Okay, and now I want to convert this particular, so if I print this data, it's going to look like this. Okay, it's not very neat and it's not very easy to understand. So what we're going to do is we're going to go ahead and convert it into our data frame, and let me just print the data frame for you. Okay, all right, so I have this particular data set with me. So if I want to see just the starting values, I can just say df.head and say I want to see the first two rows. Okay, so I can do it using .head function. And if I want to see the last values, I can just say df.tail. Okay, so by default, the parameter over here is 5. But if we want, we can tailor it to our own needs. So I want to see the last three rows. So you can see 5, 4 and 3. Okay. So moving on, we can again use our log and ilog functions just like we did with our series. So say I want to fetch the first and second row of my data set. So what I'm going to do is I'm going to say df.ilog and I'm going to say 1 to 3. Okay. So you can see I have my first and second row and all the columns. Okay. So now in case of all these columns, what if I want only department and salary in my output? So what I'm going to do is I'm going to say df.log. So instead of ilog, I'm going to use log and I'm going to say rows 1, 2, 3 and I'm going to say I want columns age and department. So I'm going to have a comma over here to separate the columns. So you can see over here I have age and department and my 3 rows. Okay. So we discussed earlier, whenever we use the log function, our starting as well as ending indexes are going to be included. So I have 1, 2 and 3 rows instead of just 1 and 2. So if I want just the 2 rows, I have to say 1 and 2. Alright, so I hope this is clear. Okay, so we can use ilog and log in this manner. But if I wanted to include my first and second column in my ilog column itself, so you can see I have my first 2 columns in my output. Okay, so basically when we're using ilog for data frames, we have to pass our rows and our columns, and the range for these are going to be separated by a column. Okay, so we can do that using ilog and log. So we'll be using this a lot. Okay, direct indexing in a data frame gets a little complicated, so that's why we'll be only using ilog and log functions. Okay, so you can go ahead and play around a little with ilog and log and try to access different rows and different columns. So now we'll be moving to accessing only an individual column. Okay, now if I want to access just one particular column, all I can do is say df_age. So this is how I get only the age column. Okay, now if I want multiple columns, I have to add another bracket and I can simply separate my columns and say I want age and department. So you can see this is how I get my output. Okay, now what if I want to drop this age column? Okay, so you can see I have a null value also over here. Now I want to drop this age column because I feel it's not very relevant to my data set. So how I can drop it is I will just say df.drop and I will say age. Okay, and I will pass axis equal to 1 because I want this entire column to be gone. Okay, if I want a particular row to be gone, my axis would be 0. Okay, so it is a particular row wise operation. But if I want a column gone, I want my axis to be 1. Okay, so if I run it, now you can see my age has been disappeared from this particular output. But if I print my data frame, you can see the age is still there. Okay, so until and unless we use the parameter in place equal to true, by default in place is equal to false. Okay, so in place is basically telling us to perform the operation in the original data frame. Okay, so if we want the changes to be displayed in our original data frame, we are going to use in place equal to true. Otherwise, by default, it is going to be false and it is only going to return a new data frame and our original data frame is going to remain unchanged. Okay, so as you can see, it has been unchanged. Now this is a missing value over here, this and this. So we'll be dealing with these missing values later on. But first, let's understand a few more functions. So we can go ahead and check the shape of our data set using df.shape. So this is telling us that we have 6 rows and 4 columns. Okay, 1, 2, 3 and 4. Okay, so again the indexes are not counted as a part of a column just like we did in series.
Okay, so these are by default values over here. And we have 6 rows. Okay, so we basically have 6 samples. Okay, these are known as samples. This is the sample sets. Okay, so we can also go ahead and check the data type of our data frame. So we can also go ahead and check other information about our data set. So using info. Okay, so this is telling us that we have these particular columns: name, age, department, and salary. Okay, and these are the data types in our column. So we have 2 columns having float data type and 2 columns having object data type. Okay, so name has object data type, age has float data type, department has again object data type, and salary has float data type. Okay. Now over here we have a non-null count. Non-null count basically means that we have 6 non-null values. That is, we have total 6 samples and all of these 6 samples are non-null. Okay. So basically in the name column we have 0 null values. Okay. And we move to the age column, and over here we have 5 non-null values. That means we have 1 null value over here, and over here also we have 1 null value, whereas over here we have 0 null values. Okay, it is also displaying the memory usage to store this particular data set. Okay, and another operation that you can perform on your data set is describe your data set. So over here you get statistical information on your data. So over here we only have 2 data sets that are of type float or integer. Okay, so we can perform these particular operations, that is the count, mean, standard deviation, minimum value, and these 25%, 50%, 75% are basically the outliers in our data set. Okay, and the maximum value. Okay, so using the describe function, you get a basic information about your data, like you have 5 values in your age column and 5 values in your salary column that are present. Then the mean value of your age column is 28, whereas mean value of your salary column is 58400. Standard deviation is this. The minimum value of age is 25 and minimum salary is 50,000. Then you have other information about your data set. Okay. So in NumPy, we saw an important concept called broadcasting. Okay, we also looked at the rules for broadcasting. Now we'll see how broadcasting is performed in Pandas. Okay, so I have a salary feature over here. So our columns are also known as features. Okay, so these are our columns or our features. Okay, so if I want to say increase the salary of all the people over here, okay, of all these people, I want to increase the salary by say 5,000. All I have to do is say df salary, and I will say df salary plus 5,000. Okay. Now you guys must be wondering, this is a scalar digit or an integer, whereas this is a one-dimensional array, right? If I just print df.salary, let me go ahead and print df salary. If I print this, you can see this is a one-dimensional array, right? This is basically an array having 5 rows and 1 column, right? And this over here is just a scalar value. Now I want to increase all these values by 5,000. So do you think if I perform this particular operation, I will get an error or will it successfully perform? So if you guys said it will successfully perform, you guys have understood broadcasting really well. So if I go ahead and print my salary now, so you can see it has been increased by 5,000. Okay. So what's happening over here is, instead of treating this as a scalar value, it has been broadcasted to match the shape and size of this particular column. Okay. And then the operation has been performed over here. Cool. So moving on to the next concept, we have renaming columns. That is, we can rename the columns in our data. Okay. So if I want to rename a column, all I have to do is call df.rename and pass my columns. Okay. So I want my department column to be displayed as DEPT. Okay, and I'm going to say in place equal to true because I want this operation to be performed in my original data set itself. Okay, so if I go ahead and print my data, so you can see my department has been changed to DEPT. Okay, so this is how you can go ahead and rename your columns using .rename function. So you can also go ahead and check the unique values in your data for a particular column. So I want to see all the unique salaries in my data set. So you can see over here, these are the unique salaries in my data set. Okay. I can check it for another column. So I can check the unique departments.
So again, these are case sensitive. So if I check the unique departments in my data set, so I have 3 unique departments, that is HR, IT and finance. Okay. Now, if I want to see how many employees are in which department, I can go ahead and do the value count of these departments. So I will say dpt dot value counts. Now, as you can see over here, HR department has 3 counts, IT has 2 counts and finance has 1 count. Okay, so basically it's telling us that there are 3 people in HR team, 2 people in IT team and 1 in finance team. Okay. So this is how you can check the distribution of one particular column across your data set using value counts. Now, what if I want to create a new column called promoted salary? That is, I want to check the salary of all the employees after the promotion. Okay. So say some of my employees have been promoted and I want to create a promoted salary column in my data set itself. So if I want to do that, all I have to do is say df original salary, and after the promotion their salary is going to be say multiplied by 10. Okay, so if I run this particular query and then print my data frame, so you can see the salaries have been increased in my promoted salary column. Okay, so they have been multiplied by 10. Again, this is a broadcasting rule again. Okay, so this is how you can go ahead and create a new column in your data set or your data frame. Alright, so now that we have learned how to create a new column, I think it's time to dive into data cleaning. So as you can see, we have a few null values in our data set. So I want to get rid of them because till I have those, I will not be able to perform some operations, plus it doesn't look very good. Okay. So first I'm going to check how many null values exactly I have. So all I did was I checked for my null values inside the entire data set and then I did a sum of all those values. So as you can see over here, my name column has 0 null values, my age column has 1 null value and my salary column also has 1 null value. And so does my promoted salary column. Okay. So I have a few options over here. I can either just get rid of all the rows that have these null values. Okay. So I can do that by using df.drop na. Na stands for null values. So I'm basically dropping all the null values, and if I just run this prompt, if I just run this without any sort of argument or without any sort of parameter, as you can see, I'm just left with 4 rows. Okay, so basically any row that had null value has been removed. And again, I have not used in place equal to true, so my original data set is still untouched. Okay. So this is basically just a new sort of data set that has been altered and returned so that I can see how it's going to look. Alright, so by default over here, you can see my argument of how I want my null values to be deleted or dropped is any. So basically any row that has any sort of null value has been dropped. Okay. So if I run this using how equal to any, so again my result is the same. So we saw one sort of parameter in drop NA, that is how equal to any. Now the other parameter in drop NA is all. Okay. Now the other argument that drop NA takes is all. Now what this is representing over here is particular row. Okay. When we said how equal to any, we were just saying any row that had any null value. Okay. So whichever row had any null value was dropped. Now over here we are saying if all the values in a row are null, we are going to drop that row, otherwise we are not going to touch it. Okay, so we do not have any row that has all the null values, we just have this row that has 2 null values, but again we have 3 non-null values as well in this particular row. So again, none of my rows were altered and the data remains as it is. Okay. So this is one option when we are dealing with missing values. We can just get rid of those null values. Okay. The other way is to fill those missing values. Now how I can do that? So let me just find, okay, here is my null value, right? So I can either fill this null value with the most repeated value in this particular column. Okay, that is one option. Let me just write it down for you guys. Okay, so dealing with missing values is one of the most important aspects when it comes to a data set, because you will be dealing with a lot of unclean and messy data sets, and missing values is going to be one of them. Okay, so let me just write missing values. So one way of dealing with missing values is getting rid of them, which we just saw by using drop NA. Okay, and the next one is by filling them up. And for filling those missing values, we use the function fill NA. Okay, so this is the second method. Let us see how it works. Okay, so all I have to do is say df.fill_NA. Okay, and let me just run it. So I must specify a fill value or method. Now I want to fill all the null values with say 0. So you can see this is what my data set is going to look like finally. Okay, but this is again a very noob method to perform on a data set, because I do not want my age to be 0 or my salary to be 0 just because it's missing, right? So instead what I can do is, for my age column, I am going to fill all my missing values with the mean. Okay, and I'm going to say, okay, let's not keep it in place equal to true, because I do not want to modify my original data. But if you guys want to, you guys are free to do it. Okay, so I'm just going to replace all my missing values in the age column with the mean of the age. Okay, so initially my third row had a missing value, and now it has been replaced with the mean. Alright. Similarly, for the salary column, what I'm going to do is, if I replace it with the mean, it's not going to be very technically or mathematically correct. So instead, what I can do is, I can replace it with the median, right? I can go ahead and replace my salary in my df column, and I'm going to say I want it to be filled with the median of my salary. So you can see over here, my fourth row was missing in my salary column, and now it has been filled with the median value. Okay, so this is another way that you can fill your missing value. Okay, now this is something that we can do mathematically, right? But what if I want to just randomly fill my value? So this was the missing value, right? So there is another method in fill NA. Instead of providing a default value, what we can do is something known as forward fill. So basically, when we use fill NA, we have two methods, forward fill and backward fill. So in forward fill, what happens is we move from top to bottom, okay, and say this was our missing value. So when we use forward fill, 35 is going to be replaced in our missing value. Okay, and similarly, when we do backward fill, 29 is going to be replaced for our missing value. Okay, so this is basically what forward fill and backward fill means. So let us quickly go and perform forward fill first. Dot fill NA, and in our method, we're just going to pass forward fill. Let's run it. So you can see 35 has been replaced in our missing value column. Okay, so it has been done using forward fill. Similarly, I can perform a backward fill. So you can see 29 has been replaced in my missing column. Okay, now using these methods, backward fill and forward fill, can be a little tricky, and they can also give you errors in cases where your first or last value is null. Okay, so in case your first value is null and you try to do a forward fill, your first value will still remain null. Alright, and same goes for backward fill. If your last value is null and you do a backward fill, your last value will still remain null, because there won't be any value before that to replace it with. Alright, so in cases like that, we go for statistical operations like mean, median, mode, alright, according to what's more technically sound. Okay, so these are some of the methods to deal with your missing values. Okay, so now we saw how we can deal with missing values. Now we'll look at another operation where we can say replace a particular value randomly. Okay, so say instead of Charlie over here, I want to replace this name with another name. So now, just because we did not use in place equal to true throughout our queries when we were dealing with our missing data, does not mean we have not already dealt with them. We have already dealt with our missing data, and currently we shouldn't have any sort of missing values in our data set. Okay, so moving on, I want to just randomly replace this particular name, say with Rose. Okay, so I want instead of Charlie, I want Rose in my name column. I just have to say df dot replace, okay, df in the name column. Okay, I have to specify the name, sorry, I have to specify the column, and I have to say replace Charlie with Rose. Okay, so as you can see, my operation has been performed successfully. Okay, and again, if I wanted this change to be reflected in my original data set, I would have to say df name, and I would basically be storing the change in my original data set. And now I can go ahead and run it. So as you can see, I have changed the name from Charlie to Rose in my original data set as well. Okay, so this is how you can make your changes permanent. Okay, all right, so let's look at the next concept when we're cleaning our data, that is dealing with duplicate data. Okay, so we already saw how we deal with missing values. Now we will see how we deal with duplicate values. Okay, so as you can see in this particular data set that we have over here, we have the entry Alice twice. Okay, and as you can see, the age, department salary, and the promoted salary, they match for both these records. Correct? So how do we deal with duplicate values? So we already have an inbuilt duplicated function. So in order to check for all the duplicate values, all you have to do is say df got duplicated and pass it in the data frame variable. And when you run it, and your output will be your second repeated record in your data set. Right? So we are not going to consider this as duplicate. Rather, we're going to consider this as duplicate. So let's see how duplicated works. Okay, so say I have a record over here of different countries. Okay, so I have Italy, France, Greece, and then Italy again. Okay, so if I go for duplicated method, what happens is we work our way from the top itself to the bottom. Okay, so first I'm going to check for Italy. So Italy is not present, no problem. I'm going to simply add it to my list, or a list where basically I'm keeping a track whether an element is duplicate or not. Right? Then comes France, so it's not there, no problem. I add it to my list. Then we come across Greece, no problem. I add it to my list. Then I come across Italy, which is already present in my list. So therefore, this element is going to be marked as duplicate. Alright. So this is basically how the duplicated method works by default. Alright. So basically we can pass a parameter called keep, and we are going to say keep first. Okay. So let's see what happens now. So you can see our first element is not going to be marked as duplicate. So this is basically by default the parameter that duplicated takes. Okay, if I say last instead of first, you can see my first element is marked as duplicate. Okay, so when we say keep last, basically we are going to work our way from bottom to up. Okay, so that's why this element is going to be marked as duplicate. Alright, so I hope this is clear. So if we want to drop this duplicate value, all I have to do is, okay, so I'm not going to pass anything because I would prefer my second record to be deleted. So I'm just going to run it. So if I print my data set, you can see my duplicated record, that was the second record, has been removed or deleted from my data set. Alright. Okay. So I hope the data cleaning process is clear. We have learned how to deal with missing values as well as duplicate values. Okay. Alright. So let's see how we can deal with invalid values. Okay. So since I want to make the changes in my promoted salary column, I have simply written df and promoted salary in the brackets. And now in order to do these changes in the column of a particular data set, I will be introducing you guys to a very important topic or an important function called lambda. So you guys must have studied this in Python as well, right? So all we have to do is promoted salary, and I will say apply lambda x, and I'm going to say divide that x. X is nothing but the records of my column promoted salary. So this is my input variable x and this is my output variable x divided by 10. But I have a condition. If x is greater than 6,50,000, right? Else, if it is not greater than 6,50,000, I'm simply going to return x. Alright. So let me run it. Okay, so it has run successfully. I'm getting some sort of documentation, but I'm going to ignore it for now. Okay. So as you can see, the two records that I had that were greater than 6,50,000 have been divided by 10. Alright. So this is how you can deal with your invalid values using the lambda and apply function. Alright. So this is the syntax for that. So moving on, we'll also look at some string functions. So in this particular sample data set that I have taken, we do not have any sort of explicit need to do these string functions. Okay, so maximum times whenever you have a string input, okay, so say the names. Over here, I just have the first name, but in case I had a name like Alice underscore, say, Fernandez, okay. So in order to deal with inputs like this, all I would have to do was df, and I would create two separate columns saying first name and last name, okay. And then all I would do was df, and I would split my name column. So basically right now I'm using name as this name instead of my column name because I do not have any sort of input like this which I want to demonstrate to you guys. Okay. So even though this is not a column per se, this is just a variable that I've created, and I'm pretty sure I'm going to get an error. Okay. So I am going to split it using string dot split method. Okay. And I want to split it based on underscore. Okay, so wherever I have an underscore, I want to split my string. Okay, so in case instead of underscore all I had was a space, I could use an empty string over here. Okay, but since I have an underscore between my first string and my second string, I'm going to split it based on my underscore. Okay, and let me see if I run it, what's going to happen. Okay, so I do not have any column name, but again, this is how you would split your data set. So obviously this code is not going to run for me because I do not have any column called name, and wherever I have name, I do not have any sort of connectors between two strings. These are just single names. Alright, so I will not be able to split these particular strings over here that I have. So this is just a demo for you guys, that in case you have a column like this is how you're supposed to deal with it using string.split method. Alright. So now that we are clear with data cleaning, I want to show you guys a few more examples of apply and lambda. Okay, so because there will be instances where these methods are going to be very useful because they let you change the single entries of a column or a row, right, based on particular conditions. All right, so let me create another scenario where I want to multiply the age. Okay, I want to multiply all the ages by 2. Okay, so all I'm going to do is age, and then I'm going to call my age function, age column over here, and then I'm going to say I want to apply. Now instead of passing lambda, what I can do is I can go ahead and create a function where I am multiplying my age. Okay, I'm going to have my input as x, and then I'm going to simply return x into 2. Okay, so instead of calling lambda over here, what I can do is I can say multiplying age and pass x. Okay, so it will not take any input. I'm sorry about that. So let me run it. Okay, so now if I print my data frame, you can see my values of age have been multiplied by 2. Okay, so let me bring back my ages to the original value. Now this time I will use lambda instead of creating a function by default. Okay, and I'm going to say apply, and I'm going to pass lambda, and I will say x, and I will say x divide by 2. Okay, now there are no conditions, there are no if else conditions. I want all of these entries in the age column to be divided by 2, so I'm not going to pass any if else like we did previously, right? So I'm going to run it, and if I print my data frame, my ages are back to the original values. Okay, so this is how lambda and apply functions are used, and you will be using them quite a lot. Okay,
So moving on, I want to tell you guys about another very important concept, that is joins and merges. Okay. Now, in order to understand joins, let us go through a quick overview of what are joins. Okay. So consider this scenario where I have two data sets, A and B. Okay. Now, when you're dealing with large data sets, it's not necessarily that you're going to have all the columns in one particular data set. Okay. So if you guys remember, I showed you guys an Excel sheet of various columns or various features of a house, right? Number of balconies, number of bedrooms, the location, the state, and so on, right? Now I had all those columns in one particular sheet. But what if I had two sheets, A and B, where in one sheet I only had, say, the features of the house, that is, the number of bedrooms, the number of bathrooms, the balconies, and in another sheet I had the different features, say when the house was built, where it's located, what's there nearby, and stuff like that. Okay, so I had two separate sheets. Now I want to combine these sheets. All right, so there are different methods. So if we talk about joins, there is left join, right join, outer join, and inner join. Okay, these are the joins that exist. And another method is to merge. Okay, merge is similar to inner join. All right. So let's quickly see what left join would look like. So if we were to combine these two data sets on, say, a particular property, and we perform a left join, our left side of the data set, okay, whatever there is common between the two data sets is going to be ignored. Whatever exists in only data set B is going to be ignored. Rather, we are going to have something that is solely available with data set A, and this happens in left join. Okay, similarly in right join it happens the opposite way. We're going to have only the properties of B in our data set. Okay, and when we perform a full outer join, we're going to have everything of A and B. Okay, so each and everything that we have in A and B is going to be included in our outer data set, sorry, outer join. And when we perform an inner join, it basically happens over here. Okay, only the common properties between A and B. And when we merge two data sets, we merge them based on this particular common column, and whatever properties A and B have, both are visible in our merged data set. Okay, so let me say this is another data set. So let me just convert it into a data frame. So I'm going to call it df2, and I will say pd.data frame, and I will pass my department. Okay, so let me just print my other data frame. So as you can see, this is my second data set. So now if I want to combine the information from this data set and the data set that I had earlier, I have something known as concat. Okay, so concat is going to let me merge the information from both these data sets. So if I use pd.concat and pass the two data sets that I have, this is the output that I'm going to get. Okay, so since in our second data set we have a location and manager, but we do not know which employees have this location and this manager, we have a null over here. Okay, so by default both my data sets are being combined in a horizontal manner, that is, they are being stacked horizontally, right? So wherever I don't have the names, I am getting null, and wherever I don't have the location and manager information, I'm getting a null. Okay, but if I were to do the same operation column wise, that is, if I were to combine these two data sets in this particular direction, I would have to say pd.concat, pass my two data sets df and df2, and I would say I want it to be joined on axis 1. So as you can see over here, wherever I have department HR, my location and manager is for the department HR, right? So this is how you can combine or merge two data sets using pd.concat. Okay, there is another function called pd.merge. Okay, so you can pass your data sets df, df2, and I want it to be merged on my column department because that is the common column. So as you can see over here, my department is being repeated twice. But if I do not want that to happen, I can use merge, and as you can see over here, my department column appears only once and my data is managed accordingly. So wherever I have HR department, I'm going to have my location as New York and manager is going to be Laura. Okay, it is, you can see it over here as well, New York and Laura. All right, so this is also how you can merge or combine your two data sets into one. Okay, so these were basically all the operations that were there to know on data sets. The basic operations, obviously, as you go down the line, you deal with bigger data sets, your operations get more complex, but this is the standard basic base that you require to get started with Pandas. Alright, so now we're going to look at how we can import a complete dataset file, that is an Excel or a CSV file, in our notebook. So since I'm using a Google Colab notebook, I cannot directly pass the entire path of my file or my CSV or Excel sheet. If you're using Anaconda or VS Code, you can do that. So if you're using those platforms, all you have to do is right click on your dataset and click on copy as path and create a variable and just say pd.read underscore CSV, because this is a CSV file, and all you have to do is pass the path inside the parenthesis as an argument. Alright, but since this is a virtual environment and it is not going to be able to access my local environment, what I have to do is I have to upload my data on Google Colab. Okay, so I'm simply going to select it. So as you can see, it's uploaded over here. Okay, so now all I have to do is, in quotes, I have to say data.csv. So you can see it's run successfully, and now I can do data.head. That is, I'm trying to get the first 5 rows of my data set. So you can see this is the date, price, bedrooms, bathrooms. So I can easily access all the columns, and I can go ahead and perform the basic operations, like I can check the shape of my data set using data.shape. So I have 4600 rows and 18 columns. Alright. So accessing such information in an Excel sheet would have been a much more difficult task. So this is why we use Pandas, which helps us gather information like this in a much more efficient and easy manner. Alright. So I can also go ahead and check the information of my data using data.info. So you can see I have 4600 non-null values. That means I have 0 null values in my entire data set. I have 0 null values. Okay. So you can also check the data type of each and every column. Now you can see over here, this is an object data type, but date is supposed to be in a time format, right? You're supposed to be able to access the day, time, and year of a particular date in an efficient manner, but this is stored in an object manner. All right. So I'm just going to quickly show you guys how you can convert this date time from an object to a time. Okay, so this is the syntax that you have to follow. So I'm going to pass my date, and then I'm going to use pt.datetime to convert my date from object to, okay, so it is data. Okay, so as you can see, it has been executed successfully. Now if I go ahead and check my information of the data, you can see it is converted to date time format. Alright, so this is how you can convert your date time features into the valid format using Pandas. Alright, so this is again only a one-line code, but you should be aware that it can be done, and this is how you bring your data to the correct format. Alright, so this was it for this video. I think we have covered almost everything there is to know about Pandas, and I'm sure you guys got a basic understanding of how you guys can implement Pandas on even a large data set. And I am going to give you guys this notebook link in the description, so you can go ahead and download it and practice on this data set, or you can download data sets from Kaggle. Let me show you guys the website. So you can go ahead and type Kaggle and click on the first link that you get. Register on this website and you get hundreds and thousands of data sets for absolutely free. You can download them, and you can also go ahead and check out the discussions if you face any issues or doubt, right? In this video, I'm going to walk you through the basics of visualizing data using one of the most popular Python libraries out there, Matplotlib.
And something important that I'll be discussing, which is often neglected while learning Matplotlib, is how to choose the right type of graph based on the kind of data you have. Not just that, we will also see how to read these plots and make sense out of them. But before we jump into it, let's take a moment to understand what data visualization actually means and why it matters. Data visualization is all about turning raw data into visuals using things like charts, graphs, or maps. These visuals help us quickly see patterns, spot anything unusual, and just get a better sense of what the data is telling us. Here's a quick example. Let's say you have a list of sales numbers for each month of the year. Sure, you could look at those numbers one by one, but if you plot them on a line chart, you'll instantly see how sales went up or down over time. That's the beauty of data visualization. It helps make data clear, simple, and easy to understand. Now coming back to Matplotlib, this is a Python library built specifically for creating visualizations. It's been around for a long time and is widely used in areas like data science, research engineering, statistics, and business management. What makes Matplotlib so powerful is its flexibility. You can create all kinds of plots like line charts, bar graphs, scatter plots, histograms, pie charts, and even 3D plots. And the best part is you can fully customize how your plots look, from colors and styles to labels, titles, and legends. When it comes to using Matplotlib, there are two main ways to make your plots. The first one is through something called the PyPlot API. This is the simpler and more commonly used method. You just import it using import matplotlib.pyplot as PLT and then use functions like plt.plot or plt.bar to make your charts. The second way is through the object-oriented API. This one gives you more control and is better suited for complex or customized visualizations, especially when you're building something that needs to be more advanced or integrated into an application. In this tutorial, we are going to explore both methods using easy examples. So go ahead and open your Jupyter Notebook or Google Colab and let's get started with Matplotlib and the world of data visualization. So before we get started with the implementation of Matplotlib, I want to quickly show you guys the anatomy of a Matplotlib figure. So a figure in Matplotlib is basically the entire window or page. It's basically the entire canvas that represents the various components like legends, your axes, the grids, your labels, everything, right? So all the components are contained inside a figure. So let us quickly go ahead and see what are these different components. So first we have the axis. So we have x-axis and the y-axis, and what these axes are representing is basically shown by the labels. So we have x-axis label and y-axis label. So say for example, I have the data of number of hours studied versus the marks scored. So I can represent my x-axis as the number of hours studied and I can label it as number of hours studied, and similarly I can do it for y-axis label as the marks scored. So I know what I am showing on my plot. Then there's something known as ticks. So we have major ticks and minor tick labels. So major tick labels are basically these marks that you can see on your axis. So 0, 1, 2, 3, 4 are basically your major tick labels, and your minor tick labels are the in-between marks like 0.25, 0.5 and so on. And then we have something known as a legend. So this basically represents what each color or mark is representing. Right, so over here we have a blue line and a red line. So whatever these blue lines and red lines are representing, that can be shown in a legend. Then you have your grids. So these are the dotted lines that help you figure out or read your plots in a more efficient manner. Then you can also label your entire figure. So you can give a title to your figure using the title component. So that is pretty much it about a figure. So these are basically the major components inside your figure. As we go ahead, we will see how to tweak these different components according to how we want our figure to look like. Alright, so in order to get started, I want you guys to quickly open any terminal and just run the command pip install matplotlib. And once you run it, you will see a few lines of code run over here for you. And finally, when you get the message requirement satisfied, that means your library is installed successfully. Now, once your library is installed, you can go ahead and import it in any environment that you like. I'm using Google Colab. You can use VS Code or Jupyter Notebook, right? According to your preference. So I'm going to go ahead and import my Matplotlib if I run it. So it's imported successfully. So along with my Matplotlib, I'm also going to import Pandas. And if I run it, so both my libraries are imported successfully. So just to give you guys a basic gist of what Matplotlib does. I'm just going to create two variables for you guys. So I have my variable x as 1, 2, 3 and my variable y as 4, 5 and 6. Okay, so these are my x and y variables. Now, in order to plot these variables using Matplotlib, all I have to do is say plt.plot, pass my variables x, y and just say plt.show. And as you can see over here, this is what Matplotlib gives me. So over here, what Matplotlib is trying to do is, it is trying to plot my data like this. So 1, 4, then I have 2, 5 and then I have 3, 6. Okay, so these are the variables that I passed and this is the data that Matplotlib is trying to plot over here. Okay, so if you go ahead and see 1, 4, 2, 5 and 3, 6. So if I want those dotted grid lines that we initially discussed in our figure, all I have to do is say plt dot grid and run it. See, now you can see I have my grid lines. Now it gets much easier to read my data in a more efficient manner. Now I can easily spot that this particular dot represents 2, 5 and this particular spot represents 1.75, 4.75. So now you're easily able to figure out what each of these points on this particular line represent. Right? So this is basically the major idea or the major implementation of Matplotlib. Now using this functionality of Matplotlib, we are going to try and plot different kind of plots for different data sets. So as we discussed earlier, Matplotlib has two types of plotting. So one is using the PyPlot API and one is using object-oriented API. So first we're going to cover the PyPlot API. So let me just write it down that we are only going to discuss PyPlot API right now. In the end of the video, I'm going to discuss how you can use object-oriented API as well. Okay. So in order to understand which particular plot is to be used for what kind of data, let me quickly introduce you guys to univariate analysis. So a univariate variable basically focuses on one variable at a time. It could be a height, weight, or a category like yes or no. Alright, so first we're going to cover the numerical column. So in order to understand, let me just create a data where I have a column, salary, and it looks something like this. Okay. So this is my salary column and this is just a dictionary and I have to convert it into a data frame. So I'm going to call my data set df and I'm going to say pd.data frame and I'm simply going to pass my data. Now if I try and print the first 5 records of my data set, this is what it's going to look like. Okay, so this is my salary column and these are my records. Let me also go ahead and check the total number of records in my data. So all I have to do is say df.shape and if I run it, so I have 20 records and I have only one column. So over here I have 20, 1. Alright. So now in order to visualize this particular column in my data frame, the first plot that I have is a line plot that we have already seen, but now we're going to see it in much more detail. So in order to plot a line plot, all I have to do is plt.plot. And in my parentheses, I just have to pass my column inside my df variable, that is my data frame, like this. So if I run it, so this is basically how my salary column is varying. Okay. So at some point it is really high, that is the highest salary is going to 55,000, whereas the lowest salary is somewhere around 25,000. Okay. Now what I can do is I can also go ahead and make some changes in my plot. Like I can say I want my color to be red and I want my grids to be shown, and I can also have my markers. So I can have my marker as letter O. Now what this marker is going to do is wherever I have a data point, it is going to be marked. So for example, over here, basically wherever I have a data point, it's going to be marked with the letter O. I can also go ahead and change the line width. Let me just run it. So as you can see, my color has been changed to red. I have grids in my plot and my marker is being represented with a dot over here, as you can see. Now instead of a straight line, I can change my line style to a dashed line like this. So now you can see my line is a dashed line, or I can also change it to a dot using the colon. So now you can see my line has been dotted. I can also go ahead and change the width of my line using the line width parameter, and I can say I want it to be 2. Okay, so as you can see, the width has been increased. So if in case I want my marker to be represented with a star, all I have to do is pass this particular symbol and you can see the marker style has been changed. Okay, so you can go ahead and play around a little with the parameters that are available in Matplotlib. Again, Seaborn offers a bit more functionality compared to Matplotlib, but this is great when you want to deal with your plots at a lower level. Okay. Then the next way we can visualize our column is through a histogram. So in order to plot a histogram, all you have to do is say plt.hist and pass your column in the parenthesis. And for now, I'm going to exclude the bins parameter and just show you guys how the salary column is going to look like in a histogram. Alright, so histogram basically tells us the frequency of our data distribution. So what this graph is basically telling us is that there are around 3 people that have the salary in the range 25,000 to 30,000. Then 2 people have the salary in the range 30,000 to 35,000. And there are 3 people again in 35 to 40 range. Okay, so this is basically how our data is being distributed. Now, in order to make it more clear, I can go ahead and pass bins and I'm going to, no, I don't want grids for this particular graph and I'm going to say my color is going to be green. So now I have divided my plot in 5 bins. So now it's more clear and more readable. Okay, so I have 6 people earning 25,000, then 5 people earning 30,000, then 3 people earning 35,000 and so on. Okay, so this is how you can read your data through a histogram. Then the next plot that we have is a box plot. So in order to plot a box plot, all you have to do is say plt.boxplot and pass your column over here and simply say plt.show. And this is what your box plot is going to look like. Okay, so whoever is not clear with what a box plot is exactly, let us quickly understand it with the help of this image. So a box plot has 2 endpoints. One represents the minimum value and one represents the maximum value. Then there's a line that is connecting the minimum value to the lower quartile and it's called the whisker. Now your lower quartile is known as Q1, which basically represents 25 percentile. So basically 25% of the data is below this particular point. Okay, then you have your mean value and your median. Median is also known as Q2 and it's the 50th percentile. This represents 50% of the data is below this particular point. Then you have Q3, which is 75 percentile. So 75% of the data is below this particular point, and then you have your maximum value. Okay, so Q1 to Q3 is known as your interquartile range. And then you have something known as outliers. Now outliers are basically the extreme values that are either lower than the minimum value or greater than the maximum value. Okay, so these are basically the extreme values and they are plotted outside the box plot. So box plot makes it very easier to identify whether there are any outliers in your data or not. Okay, so as we can see in this particular plot over here, there are no outliers currently. But if I were to add a salary, so at index 20, I'm basically adding a salary 0. Okay, now if I run it, now I go ahead and plot a box plot. You can see over here, I got an outlier value which is at 0. So this is the value I just inserted, as you can see over here, through df.loc. So we have already covered LOC and ILOC in my previous video of Pandas full course. If you guys have not watched it or you guys do not understand how I have added a new record in my dataset, I suggest you guys to quickly go ahead and watch that video before you continue with this video, because we will be using Pandas somewhere or the other throughout this video. Alright, so as you can see, I've got my outlier value over here, which is really far away from my entire box plot. So it's suggesting that whatever range my other salaries are in, this particular salary does not match that range. Okay, so I can simply go ahead and remove this value from my dataset in order to avoid any bias in my entire calculation when I'm going ahead with prediction models and all. Okay, so I'm just going to go ahead and remove this value. Okay, so I'm back to my original dataset. Now this was all about when you have a single numerical column. Alright, so salary was something that contained all numerical values. But what if I had a column that had all categorical values? So now we're going to deal with a univariate categorical column. Okay, So in order to deal with the categorical column, let me just quickly go ahead and add another column to my data set called department. So now let me go ahead and check my data frame, what it looks like. So as you can see over here, I have a salary column and a department column, and my department column is a categorical column. I can also go ahead and check that using the info parameter. So you can see this is of type integer and this is of type object. So basically all of the data that I have in my department column is of type string. Alright, now if I want to visualize this particular column, I cannot use a line chart or a histogram or even a box plot because those are used for a numerical column. So in order to visualize this column, I'm going to use something known as a pie chart. Now in order to plot a pie chart, what I have to do is I have to create a count variable where I am simply going to count the number of unique values in my department. So this is what it's going to look like. So I have 8 HR departments, 6 IT and 6 finance departments. Okay. Now I can go ahead and plot this data in my pie chart using plt.py. Simply pass my count variable, and if I print plt.show, this is what it looks like. Now over here, I do not know what these different colors are representing. So in order to have that on my pie chart, all I have to do is say labels equal to count dot index, and if I print it now, you can see the green color represents my finance, blue represents HR, and orange represents IT. But again, another issue is I do not know the values of these sectors. So in order to get my values printed in my pie chart, all I have to do is say auto PCT and pass 1.1%, 1.1 F. So you can see I have 40% HR, 30% IT and 30% finance. Okay. So the format I've given over here basically represents that I want one decimal. If I were to pass 1.0, I would get only my integer parts over here. If I were to say 1.2, you can see I got 2 decimal values in each of my sectors. Okay. And another important parameter in pie chart is explode. So the explode feature basically helps us decide if we want to separate any particular section in our pie chart. So let me just show you guys. So I can simply say 0, 0.1 and 0. If I do that, so you can see IT, which is my second sector over here, has been separated from my entire pie chart by 0.1 distance. Okay, I can do that for 2 sectors at a time also. I can say I want this to be separated by 0.2, the last sector finance. So this is what my pie chart looks like now. Okay, now if you feel that your pie chart is not a complete circle, it's not a proper circle, you can quickly go ahead and say axis and pass equal in the parenthesis, and that will make your pie chart in a complete circle. Okay, so this was one way of visualizing a categorical column. The other one is known as count plot. So in order to do a count plot, all you have to do is say plt.bar and pass your count.index and count variable and simply say plt.show, and now you can see your different sectors represented as a bar chart. Okay, you can easily understand that HR has 8 values, basically 8 people working in HR, 6 people working in IT, and again 6 people working in finance. You can also go ahead and change the color of your bars. You can make it, so if I want different colors for different bars, so I can go ahead and say green, black, red. So you can see I have different colors for my different bars. Okay, so this was all about univariate analysis. That is when we had to deal with only one column. Either it was just a numerical column or just a categorical column. But what if we had 2 columns at a time? That brings us to our next type of analysis, that is bivariate analysis. And over here, we basically try to analyze the relationship between 2 features or 2 columns. So first we're going to look at 2 numerical columns. Okay. So right now, if I check my data set, I have 1 numerical column and 1 categorical column, right? So in order to perform numerical analysis, I should have another numerical column. So let me just go ahead and create a new column. I'm going to call it age, and okay, so this is my new column called age. And if I go ahead and check my data frame now, so you can see I have 3 columns. 2 are numerical columns and 1 is a categorical column. Alright. So now if I want to visualize salary and age column together, the first plot that I have is known as a scatter plot. So a scatter plot is basically going to help us analyze the direct relationship whether salary increases with age or not. Okay, so if you want to check that, all we have to do is say plt.scatter and pass my age column, my salary column, and I'm going to give the color orange, and I'm simply going to say plt.show. So as you can see over here, my age and salary are increasing together. Okay, so this is also known as a positive correlation. Alright, so when my age is around 20 to 25, my salary is somewhere around 25,000 to 30,000. But as my age increases, so when I reach the age of 40, my salary is somewhere around 55,000. Okay, so this is how you can analyze the relationship between two numerical columns. And the next way of visualizing two columns is again by using a line plot. So as we saw in our initial example, we had two features X and Y. So right now we have two features called age and salary. So I'm going to go ahead and plot my line graph over here. So as you can see, my line graph is not very easy to visualize over here. You can see the lines are very random. So instead of line style as dotted, I'm going to have my simple and plain line style. So as you can see, it's going back and forth a lot. So why is this happening? Because my age column is not sorted over here. So I have random age values and random salary values. So in order to have a better visualization, what I'm going to do is I'm going to sort my age feature. I'm going to create a variable called sort age, and I'm going to simply sort my values of age. Okay, and over here, instead of passing my age directly, I'm going to pass my sorted age. So as you can see over here, now my line chart is giving me a better visualization of the relationship between the age column and the salary column. Okay, so this is how you can plot a line chart between two numerical columns. Then the next visualization graph that we have is a bar chart. So in order to plot a bar chart, all you have to do is say plt.bar, pass your age. I'm going to pass my sorted age features and my salary column, and I'm going to say I want my color to be green for all the bars. And as you can see over here, it is giving you the visual representation in forms of bars. Okay, so at the age of 22, I have my salary in this range. At the age of 25, I have the salary at this range. So I can also go ahead and create bins. So I want only 10 bars to classify my age. So I can also go ahead and align my bars, and I can say I want my bars to be in center. So if I run it, so they were initially like this. Now if I say I want them to be left, so align supports center or edge parameters. Okay, so this is how you visualize two numerical columns, but what if you had a numerical and a categorical column to visualize? So let me go ahead and show you guys. Bivariate analysis, but with a numerical and a categorical. So I'm going to consider my salary feature and my department feature, and now I want to see the visualization of how my salary is distributed according to my department. Okay, so what I'm going to do is I'm going to create my feature called HR salaries, and here I'm going to fetch all my salaries that have the department of HR. So basically my HR salary variable is going to contain the salaries of only the HR department. So basically these are the people working in the HR department and these are their salaries. Okay. Similarly, I'm going to do that for the other two departments as well. So I'm going to create IT salary, and similarly I'm going to create finance salary. Okay. So once I have my salaries for all the three departments separately, I can go ahead and plot them in a box plot. So I'm going to go ahead and create a box plot. So in order to do that, all I have to do is say plt.boxplot and pass all the three salaries that I have together. And you can see the distribution like this. Okay, so I have one salary that is an outlier, that is 55,000, which is, okay, so I need to also go ahead and label them. So I'm going to say label And I'm also going to show the legend for my plots. So if I plot this, you can see I have 3 box plots, and over here you can see I have an outlier value for my first box plot, but in this particular figure I'm unable to understand which box plot is referring to which department. So in order to clarify that, I can go ahead and say I want my labels to be HR, IT and finance. So if I run it now, you can see my first box plot represents the HR department, and I have an outlier value in the HR department. Okay, so this is how you can analyze a numerical column with a categorical column using box plots. Okay, you can also check their median values. So the median HR salary is in the range of 25,000 to 30,000, whereas IT median salary is 35,000 and finance has the highest median salary, that is 40,000. So this is how it gets much easier to visualize data using plots in Matplotlib, right? If you were to find out such insights just looking at the data, it would take you much longer, right? But using graphs like this, I can easily figure out which department has uh, a higher median salary, or the maximum salary, or the outlier lies in which department, right? So box plot was one way. Another way where you can visualize your numerical and categorical column together is pie chart. So in order to plot my pie chart, what I'm going to do is I'm going to sort, or I'm going to group my salary by department, and I'm going to say df dot group by department, and I want my salary to be grouped, and I'm going to use the sum instead of mean. So this is what it looks like. So I have a total of this number for my finance department. So basically all the people in finance together are earning this much salary, whereas all the people in HR are earning this amount, and in IT they're earning this amount. Okay, so now I can go ahead and plot it in a pie chart. I can say plt.pie, and I can give my salary by department variable, and I can call my labels as the index, and I'm going to label them using auto PCT. And once I print my pie chart, so in my pie chart I can easily see the distribution of salary in percentage for the 3 different departments. Okay, so this is another way of visualizing. So in my box plot I could easily figure out the minimum salary, the maximum salary and the median salaries for all the departments, and over here I can see the distribution or the percentage for each department, that is the total amount being earned by each department. Okay, so another way when you can visualize your numerical and categorical column is by using a bar plot. So I want to show the mean salaries of all the departments in my bars. So what I'm going to do is I'm going to say HR mean, and I'm simply going to say sum of HR salary and I'm going to divide it by the length of HR, and similarly I'm going to do it for IT and finance as well. So once I run it, I can simply go ahead and plot my bar chart over here. I'm going to say plt.bar, and I'm going to pass my HR, IT and finance as labels. And I'm going to pass these as variables as well, and I'm going to say I want my bars to be of color green, black and red. And once I print my chart, this is what it's going to look like. Okay, so in my bar chart over here I can easily see the mean or the average salary for the 3 departments in a very clean and neat manner, right? So my HR mean salary is somewhere around 35,000, whereas IT is a little more, and finance is almost crossing 40,000. Let me just use my grids over here. So you can see, now you get a better visualization of the mean or the average salary for the 3 departments. Okay, so this is going to further help you in analysis where you are building large predictive models. Right now I just have 3 columns and the values are really small, so I could even look at the data. But when you have a larger number of columns and larger values, visualizing your data becomes a much more easier, or you can say efficient way to understand what the data is trying to tell you, right? So with this we finish our bivariate analysis. Next comes our multivariate analysis. So basically this is where we're trying to understand how the 3 columns affect each other and how they change with each other, right? So first we're going to look at three numerical columns, that is numerical, numerical, numerical. So I'm just going to write 3 numerical columns. So in order to have 3 numerical columns, right now I just have 2 in my data set. Let me just check. Yeah, so I have 2 numerical columns, that is salary and age. I need to add another numerical column in my data frame. So let me just say df and let me add experience. Okay, so you can see I have added another numerical column, that is experience. So basically this column is telling us how many years of experience the person has. So over here there's 1 year of experience, here over here the person has 2 years of experience and so on. Okay. Also another thing that I missed over here is a few parameters in pie chart. So over here there's something known as shadow. So if you want to give these effects to your pie chart, you can simply say shadow equal to true, and over here you can see a shadow like structure has been created below your pie chart. Okay, so it kind of gives your image a 3D effect, right? And you can also go ahead and say explode and pass a list of the distance that you want your each sectors to be away from the radius. So I'm going to say 0.1, 0 and 0.1. So basically this makes your pie chart look a little more interactive and different from the normal images that are out there. So you can go ahead and customize it. Okay. Alright, so moving on with our multivariate analysis. So I have 3 numerical columns, as you can see over here. So now in order to analyze these 3 columns together, I'm going to use something known as a bubble plot. Okay. So a bubble plot is nothing but a scatter plot where your third numerical column, so in this case we're going to use experience as our third numerical column, and this experience column is just going to define the bubble size. Okay, so with that you get an idea of how much experience the person has. So basically the larger your bubble, the more the experience the person has. Okay, so let me go ahead and quickly create this plot for you guys. So I'm going to say plt.scatter. So basically I've passed my age column, my salary column and my experience column as the size of my bubble, and I'm saying I want orange bubbles. And if I print this, okay, so as you can see the size of my bubble by default is very small. So basically the smallest bubble is representing 1 year of experience and the largest bubble is probably representing 5 years of experience. But in order to have a better visualization, what I'm going to do is I'm going to multiply this by 20. Okay, so now you can see the bubble size has increased and now it's much more easier to visualize this particular graph than earlier. I can also go ahead and increase the number of multiplication. Okay, and I'm going to give the color blue because that would give a better bubble effect. So this is what my bubble plot is going to look like when I have 3 numerical columns. Okay, so you can go ahead and easily visualize that person of age 27 is earning around 35,000, and again the experience is also good, right? So I'm simply going to give the color as sky blue, and I can also go ahead and customize it as edge color. So I'm going to give my edge color as black so that I have a better understanding of my bubbles on it. So see, this is what my bubble plot is going to look like. Again, I can give a title to my plot. I can say plt.title, age versus salary versus experience, and my X label is going to be age, my Y label is going to be salary, and I do not need a grid. So now you can see my plot looks much neater and easier to read, right? So this was when we had 3 numerical columns. But what if we had 2 numerical and 1 categorical column? So in this case, we are going to again use a scatter plot. So the 2 numerical columns are going to be our age and salary, and our categorical column is going to be the department column. Now, in order to plot this on a scatter plot, instead of using a bubble plot, we're going to use a scatter plot again. But for the different departments in our department column, we are going to use different colors. Okay, so what I'm going to do is I'm going to say plt.scatter, and I'm going to pass my age column, my salary column, And I'm going to say I want my colors to be of the different departments, that is DF department. And I'm going to say I want the colors of a rainbow. So I want different colors in a rainbow. Okay. Or if I didn't want rainbow, I'm going to show you guys how I can customize the colors in my own way. So I'm going to say X label, and my X is going to be age, then Y label, plt.x label, and plt.y label. My Y label is going to be salary, and I'm going to give a title to my plot, and I'm also going to print my legend. Okay, so I cannot use a rainbow color. Rather, what I'm going to do is I'm going to say df.map, and I'm going to map the different departments. So if I have an HR department, I'm going to map it with, say, color yellow. And similarly, I'm going to map my other two departments as well. So I'm going to say IT, I want to be mapped to color blue. And finally, I have finance, say orange. Print it now. So as you can see over here, I've tried to print my legend, but I am not really getting an output. So I can resolve this by simply saying labels equal to df department. So as you can see over here, I have tried to print my legend using plt.legend, but I am not really getting any output for that particular line. So the reason being, I have explicitly defined what colors each of my departments are going to get, and Matplotlib is unable to read that. So I have to explicitly define the labels using label, and I'm going to say HR, IT, and finance. So if I print it now, so as you can see over here, even though we've passed the plt.legend parameter, our legend is not getting printed. So the reason is because we have explicitly defined the colors over here, and even if we try to get the label parameter as df department, so you can see it is not going to work for us. So we cannot use this particular strategy. Rather, we have to follow a different kind of format over here where we explicitly define our color using a variable. So I'm going to say my HR is going to be linked with yellow, IT is going to be with blue, finance is going to be with orange. Okay, now I'm going to iterate through each of my color and my department. So I'm going to say for DPT and color in color.items, and basically I'm going to classify each of the departments separately, and then I'm going to print my scatter plot of age and salary. I'm going to say my color is going to be the specific color for each department, and I'm going to label my department. And if I run this and I go ahead and print my legend, so now you can see I've got my legend successfully, because now Matplotlib knows which department is representing which color. Alright, so that is why it is able to generate a legend successfully. Earlier in this case, Matplotlib had no idea about it. So this is how you can create a legend when you're plotting two numerical and one categorical column in a scatter plot. Alright, so that was all about our PyPlot API plotting for a single numerical column, a single categorical column, then two numerical columns versus a numerical and a categorical column. Then we went ahead and saw multivariate plotting, and we did all that using the PyPlot API. That is, we directly went ahead and used terms like plt.bar, plt.boxplot, and so on. Now we're going to dive into object-oriented API. That is, we're going to create objects before we start plotting. Okay, so let me just comment it over here. So object-oriented API basically allows subplots or multiple axes or multiple plots in a particular figure. Okay, so till now we saw one particular plot in one figure, but now what we can do is we can have multiple plots and subplots in a single figure. Okay, so let's quickly see how. So first I'm going to create two objects called figure and axis, and I'm going to say plt.subplots, and I'm going to pass 1,3, and I'm going to say my figure size is going to be 10,5. Okay, So this is basically the x and y ratio. So in terms of x, I'm going to have the figure horizontally expanded and vertically just 5. Okay. So basically what I'm telling my subplot parameter is that I want one figure, and in that one figure I want 3 subplots. Okay. So now let's go ahead and create our first plot. So I want my first plot to be a line plot. Okay. So as you can see over here, this is one complete figure and I have 3 subplots. Right now, all these 3 plots are empty. Okay. So I'm going to go ahead and create my line plot first. So in order to do that, I'm going to use my sort age variable. Let me see if I still have it. Yes. Okay. So I'm going to use my sort age variable. So I'm going to say at my axis 0, that is my 0th x axis, I want to plot a line plot, and it is going to be sort age, pass my age and salary, and I want my color to be red, my marker to be a star, and my line width to be 2. Okay, I can also go ahead and define my marker size. So I'm going to say marker size equal to 2. So I can go ahead and set the grid. I can also set my title for this particular plot. I'm going to say it's a line plot, and I can also go ahead and set my x label and my y label for this. So I'm going to say dot set x label, and I'm going to call it age, and y label is going to be my salary, and then I'm just going to run it. Okay. So since I've not called my plot till now, it's not being generated. Now I'm going to go ahead and plot my histogram. Ideally, all this should be run in a single cell. So I'm just going to paste it in my cell over here. And then I'm going to plot my histogram. And over here, my axis is going to be 1, so that Matplotlib understands that this was my first plot. And I'm going to use axis 1 over here throughout histogram, so that Matplotlib understands that this is the second figure, while the earlier where I use 0 for axis is going to be my first figure. Alright, so basically I'm referencing to my first figure and my second figure over here. So I've created a histogram for my salary, and I'm going to give the color sky blue. And I'm going to set my title for histogram, and I'm going to set my label salary, and y label is going to be frequency. Then my third plot is going to be a box plot, where I'm going to say axis 2, that means my third figure, and I'm going to plot my salary over here. I'm going to set my title as box plot, and I'm setting my x label as salary again. And if I run plt.show, that is I print all my plots, this is what it's going to look like. So as you can see over here, my plot is sort of coinciding with my second plot. So I can go ahead and increase my x-axis direction. So I can say 15,5. Now you can see it's fitting perfectly. Okay, so you can go ahead and adjust the dimensions for your plots, that is your figure size. Okay, so this is how you plot multiple plots together, okay, in using object-oriented API. Cool. Now, if I want to save this particular figure in my local environment, maybe I want to use it for some sort of presentation or any sort of document that I'm preparing, and I want to use this figure in that, how do I do that? Okay, so you can either just right click and go to copy image, but that's not the right way. So Matplotlib offers an inbuilt feature where you can save your image. So all you have to do is say plt.savefig and give a name to your image. So I'm just going to say multiple plots, and now you can use any particular extension. So I'm going to use PNG. You can use the JPG format, or you can use the PDF format. Okay, any format that you want to download your image in, you can just use that particular extension in the end using the dot. So whichever image I need to save, I just need to run this particular line before the plt.show. And if I run this, so let me see if my image has been saved. So as you can see over here, multiple plots.png has been saved in my drives. So since I'm using Google Colab, it is unable to access my local environment, and hence my image is saved only in my drive, that is my disk space over here. If you're using VS Code or any other notebook like Jupyter Notebook, you can specify the path that you want your image to be saved in. Okay, so you can directly go and say, I want it to be stored in my C drive. Okay, so you can use a path like this, so that your image is stored in that particular folder. And I can also go ahead and download it from here. So this is how you save an image. I can also save it in, okay, let me just go ahead and, so if I click on this is what my image is going to look like. Okay. Now, before we wrap up with our 3D plots, I want to show you guys another interesting scenario where we have a data somewhat like this. Okay, so basically I have multiple numerical columns. Now, if I want to visualize all these particular metrics over here, like the sales and profit and expenses all together in one chart with reference to the year column, this is how I can do it. So first I'm going to convert it into a data frame. I'm going to call it df2. This also ideally should be data2 because I already have data variable initially. Okay. So in order to do multiple plots, all I have to do is say plt.plot and pass my year as my x variable. So this is going to be fixed throughout. All my x variables are going to have the column year because I want all these particular metrics to be represented with reference to year, but in a single plot. Okay, so this is how I'm going to do it. So I do year and let me plot sales, and I'm going to label it as sales. So similarly, I'm going to do it for profit and expenses column as well. Okay, and I'm going to label it as profit and expenses. So if I give my plot a title, financial analysis, and I'm going to label my X label as year and Y label as the amount. So now my Y label, that is the amount, is going to vary according to sales, profit and expenses. Okay, so if I run this, okay, so as you can see over here, I have my profit, my expenses and my sales. Now how do I know which line is representing what? I can see it through the legend over here. And my x-axis is representing the year and my y-axis is representing the amount. Okay, so basically we had lesser profit and our expenses were greater than our profit throughout the years. So basically the company is in financial loss. So that is something that we can easily predict through this particular graph. Although our sales were pretty high, we are not generating the required profit, right? So this is how you can analyze financial data in just a few lines of code. All right. So now coming to the last topic for this particular video, that is a 3D plot. So let's plot a 3D plot for this particular data frame that we have. Okay, so in order to do a 3D plot, all you have to do is create a variable. So I'm going to call it AX and I'm going to say plt.figure and I'm going to say projection equal to 3D. Okay, and now I'm going to create my scatter plot and I'm going to pass my variables. So I'm going to pass my age, salary and experience column and I'm simply going to say plt.show. Okay, sorry, it's not going to be plt.figure, it's going to be plt.axis and my d is going to be small. Okay, so as you can see over here, I've got a 3D plot. So in order to clarify what each of these axes is representing, I'm going to label these axes. And in a 3D plot, I'm going to use set X label, set Y label and set Z label. Alright, so once I run it, so as you can see over here, this particular axis represents age, this represents salary and this one over here is supposed to represent experience, but I'm not really getting the label over here. So this code is going to perform better if it was run on a Visual Code or Jupyter Notebook. Okay, Google Colab does not really support a lot of 3D animations. So if you were to run this particular code in VS Code, you would be able to rotate your graph on different axes and be able to visualize the data better. So if you want to achieve the same functionality in Google Colab, all you have to do is import plotly.express as px and if you run it, so it's run successfully. And then you can simply go ahead and create your figure, which is going to be your scatter plot 3D. So it directly comes with a 3D scatter plot and you can pass your data frame and your variables are going to be age, salary and experience. So what I've done over here is I've created a figure variable and I've used px.scatter3d. So it's directly going to plot a 3D scatter plot and I've passed my data frame, my age, salary and experience variables and I've titled it as 3D scatter plot. Okay. Now all I have to do is say fig.show, and if I run it, so as you can see over here, now I am able to rotate my graph. I can visualize the data on a 3D level. Okay, so this is how you can do it using Plotly library. Okay, Matplotlib also offers this particular option, this particular functionality, but just not in Google Colab. Okay, you can do it on Visual Code or Jupyter Notebook. So this was it for this video. I hope you guys were able to understand Matplotlib, the functionalities, and most importantly, which plot is supposed to be used for what kind of data set. So we've discussed univariate, bivariate, and multivariate analysis along with PyPlot API and object-oriented API.
So what exactly is EDA? EDA, or Exploratory Data Analysis, is an approach of exploring the data in a way where you are able to gather few insights from the data. These insights may include the pointers that best explain the distribution of the data points, peakness, and other necessary information like relationship between each of the variables in the data. You are able to identify the underlying patterns, which you may not be able to identify just by looking at it. You are able to remove the redundancies like null values and outliers. The idea is to use the processes and tools available to us to make sure that no stone is unturned when it comes to exploring the data. The main objective of the EDA is to understand which kind of solution, or if we are using the machine learning approach, we are going to use to solve the problem. This practice gives us enough room to decide the outcomes based on findings while doing the EDA. Now that we have a vague idea about what exactly is exploratory data analysis, let's go ahead and look at why it is so important for any aspiring data scientist to be thorough with the concept of EDA. So when we discuss the importance of exploratory data analysis, we have to cover some points. First of all, EDA helps us uncover underlying patterns and trends in the data that are not visible by just looking at the data. So let's say if you're looking at any data which is related to insurance companies, you might not be able to find the patterns in how the people are paying their premium just by looking at it. And when it comes to EDA, it will help you identify those patterns and actually work on those insights. Next up, EDA can highlight useful relationships between the data points to gather insights. Now, taking the example of insurance data again, we can actually find out how and why people are paying their premiums on time, or what are the different parameters which are holding them from paying their premiums on time, etc. EDA also helps in restructuring the data according to the problem statement. Let's say we have to create a prediction model against some data that we have. We have to know how we are going to structure that data. Do we need the outliers? Do we need the null values? Or do we actually need to standardize the data for further computations? So that is where EDA comes into the picture. And last but not the least, EDA helps in removing the redundancies from the data, which I have already mentioned, the outliers and the data imputation techniques that we are going to use to replace or either remove the null values. Now that we have a clear idea of what exactly EDA is and how it is very important for us to learn about the exploratory data analysis, let's go ahead and check out the steps involved in the exploratory data analysis. So the steps involved in the EDA starts from how you load the data into your program. That is where your actual EDA begins, and that is the first step of the entire cycle also. Once you're done with loading the data, comes the data visualization, where you use the data visualization tools. For example, if you're using Python, we have Matplotlib, we have Seaborn, we can use Plotly to derive different plots from the data, which is going to explain the distribution, the peakness, and other important points like outliers, etc. Then we can also find out the relationship between different variables using data visualization. Next up, the third step is data imputation, where we are going to figure out how we are going to replace the null values or how we are going to deal with them basically. So let's say if we have a distribution which is a normal distribution, we can just simply replace the values with mean. If we don't have a normal distribution, let's say if it is positively skewed, the distribution, then we can replace the values with the median, or otherwise if the presence of null values is very minimum, or let's say less than 5% of the entire data, we can just remove those values or drop those columns. Now moving on to the next step, that is the outlier analysis, With EDA, we are able to do the outlier analysis also. We can identify which features has the outliers, and we can also analyze and basically remove those outliers. And if we want to keep them, we can take a decision on that as well. So that is also covered in the EDA on repeat. So that is also covered in the EDA. And last but not least, the fifth step is gathering the insights. So from all these steps that we have performed, we have to come to a conclusion that our data has several insights. For example, let's say if I am analyzing the IPL data like we have done in one of the previous sessions, what we have done is basically carrying out an entire EDA on that particular data, and we have found out the 10 best players of that. Repeat. We have found out the 10 best players from that entire data. So similarly, we have to gather insights from the data, and now that we have actually understood the steps involved, we have understood the importance and the basic definition of EDA. Let's move on to the hands-on part where we are going to perform the EDA on metro data using Python. Before that, let's just quickly take a look at the problem statement. So we have the metro cities data, and we already know that subway system or the metro trains that we have in the various countries has been there for civilizations and has been helping the modern civilization to commute in everyday life. And it is a very big network all around the world. So we have gathered that data, and our job is to identify the underlying patterns by performing EDA, where we are going to use Python on the metro data. And in the end, we are going to gather a few insights from the data. So let's also take a look at the data set, how we have all these features: city, country, name, year last expansion, stations, length, kilometer, annual ridership, mil, and region. So we have also described the columns here. So city is basically the name of the city, then we have the name of the country, the name of the metro, the year it was built, and the year when the last expansion happened for that particular metro, and then we have the number of stations, the length of the entire network in kilometers, and then we have the annual riders, which is in millions, and last but not least, we have the column with region, which is basically nothing but the region where it is located in. It could be North America, it can be Europe, it can be Asia, or it could be Australia, and then we have Latin America as well. So we'll quickly go to the notebook and perform EDA. So let's get started, guys. All right. So this is our notebook that we have created. Increase the visibility here. So as you can see, we have already imported the dataset and we are using the Google Colab for this. You can perform the same on Jupyter Notebook if you like. It's up to you guys, whatever suits you better. So we are going to be performing EDA using Google Colab. So first of all, we have to load the dataset, and we have imported all these libraries. Pandas, because we are going to be using data frames here. NumPy for basic view computations. Matplotlib and Seaborn for visualization. So loading the data is very simple, guys. We can use the read CSV function over here from Pandas module and with the file name. If you're using Jupyter Notebook, you might have to give the directory over here, and you may find out that you're facing a few errors importing the data. But don't worry, guys, you can reach out to Intellipaat and we'll be happy to help you with this problem. And then with this, we are basically done loading the data. So the very first step that I'm doing over here is getting the name of the columns. So data.columns give me the column names. So we have city, country, name, year last expansion that we have discussed while discussing the description of all these columns in our data. Next up, we have data.info. So info is going to give me the information about, as you can see, we have 3 columns here. One is having the column name, basically all these names. Then we have the number of values and how many of them are non-null. So as you can see, we have 188, repeat, as you can see, we have 198 values over here, which are all non-null. The data type here is object for 3 columns. Then we have integer. The annual ridership is in float, and then we have object again. So we might have to change these data types if we are going to perform some linear regression, let's say. So that comes after we have gathered the insight or before we are preparing our data for the modeling. So that is also one of the things that we can cover in the EDA, where we look at all these data types and figure out which one needs to be converted to, let's say, integer. Now let's go ahead and check the shape of the data with data.shape. So we can see we have 198 by 9 is the shape of our data over here. We can check the dimensions also. So checking the dimensions helps you when you are performing, let's say you have a data which has 64 dimensions, then you may have to perform dimensionality reduction over there, which will help you in preparing your data for the modeling. And that is why checking the dimensions is also one of the good practices when you are doing EDA. Alright, so this is the part where we describe our data. So first of all, what we are doing is we are getting the first 5 rows in our data set using the data.head method over here. As you can see, the first 5 rows in our data, we have the cities, we have the country, the name of the metro, the year it was built, the last time it was expanded, and then we have the stations, the length in kilometers, annual ridership in million, and then Africa. So we have a lot of variables here which are not integer or float type. So what we are doing is we'll describe the data, but we are not going to get the values for those particular columns. Like if you can see over here, the describe method does not fetch us the count, mean, standard, minimum, 25 percentile, 50 percentile, 75 percentile, and maximum. For the columns, city, country, we don't have name over there. We won't be having region as well. So we have only got the year last expansion, the stations, length kilometer, and annual ridership. So this is one pointer that you can make a note of. Whenever you're using the describe method, it is not going to get you the values which is not in the type numbers, basically, which is integer, float, it could be a complex also. But if it is a object or a string data type, it is not going to get you these values. So describe is actually one of the methods which is quite useful while doing the EDA. So I can, for example, let's take this column, stations. So we can know what the count is, we know what the mean is, we know the standard deviation, we know the minimum, and there's a 25th percentile, that is a 50th percentile, then we get the 75th percentile as well, and the maximum also. So we know for sure the highest number of stations in the entire data is 424, the lowest is 6, and the mean value for all these metro stations is 68. Similarly, we can have the numbers on length kilometer. So the highest is 49,039 kilometers, and the lowest is basically 12 kilometers. So the metro station with the lowest network, or the lowest range of network, is 12 kilometers only. And then again, we have the minimum of annual ridership. So there is a station which does not even cross 1 million commuters every year, and the highest is 2834 million. So that is quite a number. So this simple 5-point summary you can get from describe method. So this is very crucial when you are doing the EDA for any data. You get the basic idea of how your data is. And then again, what we are doing is getting the unique values for region. So let's say we have this column region over here. So we can get all the unique values using the unique function over here, and we are printing those. So the number of unique values is 6, and the values are Africa, Latin America, Asia, Australia, Europe, and North America. Let's say if we wanted to narrow down our analysis only to one region, we can segregate the data based on this value and then perform our EDA on that particular set of data. So that is why we have done that, and we have done that same thing for countries. So we have 59 countries that has the metro network in our data, and these are the country names. And then again, if we do that for the cities, so 187 countries from the world in our data has the metro networks or metro trains. So this is a very simple finding from our data, which you can say in these 6 regions, 59 countries have metro stations, and out of these 59 countries, 187 cities are there. So that is our initial finding from the data. Now when we move on, let's check the distribution plots for each parameters. Now we are using Seaborn over here to create a distribution plot. Now distribution plot will tell you a lot about your data. Basically it will give you if it's a normal distribution or if it is positively skewed or negatively skewed. So if we take a look at this data, this is negatively skewed because we have a lot of values towards the end of the distribution, and that is how we can estimate or basically interpret this data. So most of the metros were built after 1975, we can assume that, and the first ones were built somewhere around 1900s or before that in very less numbers. When we take a look at the next plot, which is about the stations, this is also a skewed data, not a normal distribution. So most of the metro stations are in numbers 0 to 100, and only a very few metros have stations more than 200. So these are the findings we get from visualization. That is why data visualization is a very important aspect of performing EDA on any data. Now visualization can be it can be of any sort. You can find out the distribution, you can find out the relationship between the variables, you can find the outliers. So these are three basic things that we'll be covering in this session. But visualization is not just limited to finding out the distribution or the relationship. You can actually get beautiful insights or create dashboards using Plotly, or you can create a beautiful dashboards using Power BI and other tools available to you in the market. But we are only going to be using Matplotlib and Seaborn for this session. There's a surprise in the end where we'll be covering something interesting using Plotly. So hang on there if you are waiting to learn something new today. And moving on, there's another distribution plot where we are checking the distribution for the annual ridership. So there again we have a skewed data, and most of the ridership or the annual ridership falls between 0 to 500 million, and only a few goes until let's say crosses 2500 million annual riders. And then we go on to check the distribution of last year expansion. This is also skewed, and we can clearly see that most of the expansions happened after 2000. So that is how you easily find out the distributions here and make quick assumptions about the data using these values. So from these few plots, I know that most of the stations or the most of the metros that are located in these cities, countries has less than 200 stations, were built after 1975, and the annual ridership is less than 500 million, and were probably expanded after 2000. So these are the insights I have gathered so far. Moving further, I check the distribution for the length of kilometers, and this is where it gets interesting. So mostly all of the data falls under 10,000 kilometers. So that is where our distribution is not very helpful. So we'll be taking a look at this particular parameter while checking the box plot, so that we get a clear idea about how the data is distributed. Now we do the outlier analysis with box plots. Now box plots is not just about finding out the outliers, which is basically whatever values we're getting outside this particular line over here. These are the outliers, but we can get the median values, we can get the percentiles over here, which is the IQR range, minimum and max, and these are the whiskers. So these are the values, and we can clearly see that year is negatively skewed. So we hardly get any, what do you call it? So we can hardly get any normal distributions in this particular data that we are handling right now. So there's no normal distribution. So let's say if we are going to use this for linear regression, we might have to scale the data so that the standard deviation and mean is actually normalized, and that you can check out in other sessions where we have covered linear regression, guys. Now coming back to our session, we have gathered some insight on the outliers for the year column. Now what we'll do is we are basically going to get all the values before 1925, because that's where our outliers lie, before 1925. So we are taking a rough number here, and then this is the data for all those metro stations, which falls under this range, the outliers basically. And we have created a few plots over here, the visualization plots, to understand this data, the outliers. So we have a bar plot over here where X is the number of stations and Y is the city. The hue we have taken as region. So if you take a look at this, blue is represented by Latin America, orange is in Europe, and North America is denoted by green. So by looking at this plot, I can clearly say that most of the metro stations that were built before 1925 were built in Europe. So that is how I can make an assumption or an interpretation from this plot. And only a few were built in Latin America, and the other ones, the other majority falls into North America. And this also shows that New York has, let's say, New York has been mentioned twice over here. So that is why we get the line over here in this bar plot. multiple values. Now let's move on to the next one. Next bar plot is the length of kilometer and the city. Now I can make assumption about these because most of the metros that were built in Europe has a length of kilometer which is higher than everybody else, which falls under London. So my assumption from this plot is the metro station built in London or the subway built in London has the length in highest numbers that were built before 1925. So like this, you can make assumptions about the data. So these are the findings that we are gathering through this EDA. Similarly, we have another plot where we are checking the annual ridership. Then again, I can make an assumption over here that Paris or the subway or metro station that was built in Paris has the annual ridership in millions in highest numbers, which was built before 1925. So that is how you gather all the insights on the data. And this is basically what we are doing with the outliers. We're just checking the values of the outliers over here. And then again, we can also create the histograms over here where we have added the hue as region again. And there we have done the same thing. You can figure out the number of stations fall under the Europe region that are in the highest numbers. And surprisingly, North America has more than 400 stations. That is basically the highest over here. Annual ridership, if we check for this, that is 639 million. Alright, so I actually want to correct myself. It is not Paris which has the most number of stations. It is New York City, guys. One second, let me just correct myself. Yes, it is New York City that has the most number of stations. Alright, so let's move on. And similarly, we have done that for length of kilometers and annual ridership again. And same thing we have done for every column. We have checked the outliers for year last expansion, and most of them fall before 2005. So we have taken the number as 2000 over here. Anything built before 2000 we have over here. And we do the same thing. We check the annual ridership. We check the number of stations. We check the length of kilometer. And then we provide some histograms to get the better idea of how the number of stations looks like. There we have Asia again in this. And so we can also make a conclusion that most of the metro stations that were built in Asia started after 1925. So that is one assumption. We can get a clear number on that when we check the very first metro that was built in Asia. And this is how we can gather a few insights on the outliers. Now moving on, we have done the same for length in kilometers also. So anything after 2000, let's say, or 2300 we have taken over here, is falling outside the range, which is the outliers. And we have all these metro stations. Most of these falls under China, guys.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
And we have done the same thing. We have created the histograms for annual ridership. So annual ridership falls majorly in 0 to 500 million. And then we have the number of stations, which also falls majorly in 0 to 50, let's say 0 to 70 stations. And the histogram shows for length in kilometers according to region. So we have most for Asia because most of the stations are in China. That is why it all looks blue, guys. And if you take a look at Europe over here, we only have two cities, Madrid and London, which shows the length in kilometer. And this basically is where we can conclude that so the largest network of trains exist in Asia. So this is the conclusion from our analysis over here. And then again, we can check the annual ridership and all these things. So we have done the same thing for stations also. We have taken all the stations more than 200 are going to be in the outlier section. So we have all these cities over here. We have done the same thing again, plotted a few bar plots to get the clear idea on length on kilometers. So I think Delhi tops the chart over here. And then we have the number of stations. I'm sorry guys, this is the length in kilometers that we're talking about for Delhi. So that is the highest for any city that has more than 200 stations. And if we check that for number of stations, the most comes with Beijing and Shanghai. There is Paris from Europe, Madrid, London, and New York City. So I think New York City is the highest. Then on the second place we might be having Shanghai, and then we have Beijing also. Then we check for annual ridership. The hue is region over here again. So we have Asia, Europe, and North America. Surprisingly, we do not have Latin America in this. So probably Latin America does not have the metro network, which has more than 200 stations. So that we can conclude. And similarly, we have created a few histograms over here, and it is dominated by the Asian region for annual ridership, for stations, for length in kilometers. Number of stations actually is shared by North America, where New York City tops the chart. And then again, we have a box plot for annual ridership, where everything after 500 million is an outlier. So we have segregated the data based on this, which is greater than 600 million. That's going to be in our outliers list. So that is how we can analyze this data, check the annual ridership, which is highest in Shanghai. Similarly, Tokyo also has a few concerns over here. And then we have Beijing. Then we have Delhi also, Moscow. Mexico City from Latin America is also there, and then North America we have New York City. So majorly all the regions are here. Only the Australian region is not present over here, but let's carry on. And then when we check for stations, then again Beijing, Shanghai, Seoul, and then we have Mexico City from the Latin American region, and New York City, of course, it's topping the chart again here, which we already have concluded. When we check for length in kilometers, first of all we have Delhi, then there is Xi'an, Moscow, Mexico City again, and Sao Paulo is also there from Brazil. And alright, so when we check the histograms, there we can see the Asian region dominating the charts over here. So this is why we have used the visualizations to get beautiful insights from the data, which we might not be able to get just by looking at the data or just by inspecting it. Like if I just take a look at the 5 rows or the entire rows of the data over here, I might not be able to fix or gather a few insights related to this data, but through visualization I was able to do that. Now moving further, let's talk about how we fix the outliers. So I'll quickly give you a preview of what we have to do for that. So handling outliers is not a very big task. Like most of the times we can leave the outliers in the data because they might help in reaching a conclusion, because they are very useful information, the outliers also. Like for our metro data again, we might not want to do this because the information that we get from outliers is extreme but is important because those are facts. So this is just an example of how you can get your data fixed or remove the outliers. You get the IQR range, which is the 75th percentile minus the 25th percentile, and these are all the IQR range for every column. For year it is 36.75, for year last expansion is 7, stations is 69.75, length kilometers, and annual ridership. So what you can do is basically replace the values with this particular thing where anything above or beyond the range, the IQR range, we are going to replace it with that. So we are going to skip this part because we want to keep the outliers so that we understand the data better. And let's also check the number of null values. Since we do not have any null values in this particular data, what I'm going to tell you is how you can replace them. The first option is always to drop the null values. Then again, you can fill the null values with 0 or with mean or with median if you don't want bias in your columns, because if the distribution is not normal, you can replace the column values or the null values with the median. And then again, if it's object data type, you can replace the values with the mode, and that is how you can treat your data for data imputation, basically replacing the null values. Moving further, to understand the relationship between the columns, what you can do is basically plot a few scatter plots, and you will get the idea of how your relationship in between the columns is. So let's say if I wanted to quickly summarize or use this entire data to decide the annual ridership, what I'll do is check the relationship with all these values or all these columns with annual ridership, so that I get a clear idea if length in kilometer is going to affect the annual ridership, if number of stations is going to affect this, if the region is affecting this particular value, or if the last expansion that happened has affected the annual ridership. That I can find out by using the scatter plots. So scatter plot between the stations and length kilometers is showing a considerable amount of increase, but not that great. So we can't really say it has a linear relationship. But for stations and annual ridership, it clearly shows a linear relationship, not exactly that strong, but it just shows that there is a relationship between these two variables. Then again, if we check for length in kilometers and annual ridership, it's not exactly that strong, but we can say it's gradually increasing. So there is a clear sign of increase, but not that strong. When we check for year and year last expansion, it's not really great. We have taken the limit from 2000 to 2022 because most of the expansions happened in that time. Similarly, for X limit also we have taken that for length in kilometers. And when we check for year and stations, this also does not show a considerable amount of relationship. So this does not actually show a very good relationship between the two. For year and length kilometers also, there we can't find any considerable amount of relationship. And then again, if we plot all these subplots, these are the subplots that you can get: annual ridership with respect to built year, annual ridership with respect to stations, annual ridership with respect to expansion, and length. So length shows somewhat linear relationship, and the number of stations also show. So these two variables or these two features in the data are going to be very useful for us if we go for a linear regression model, let's say. So these two will be able to decide how our data looks like and how we can actually predict some of these values. Since we have not used any of the object columns, if we do a little bit of hot encoding or label encoding on that, we might be able to find out relationship over there as well. So you can take that up as an exercise. So I'll tell you two questions you can solve. Convert the object data type in this particular data into an integer data type, or perform label encoding in that, and find out the relationship between those variables and the annual ridership column. So that is one exercise you can take from this session. And then again, if you just want to get the relationship easily, you can just use the pair plot, which gives you all these plots with respect to each of the columns. And with the annual ridership in millions, we can see two columns that are showing considerable amount of linear relationship. And we are going to conclude with that. We can add the hue as a region also, where blue is Africa, then we have orange, which is Australia, Europe is in green, Latin America in red, North America and Asia. So if we check over there, the extremes are on the Europe over here, number of stations, and length in kilometer is in North America, the extreme. That is how we can visualize the data, guys, to gather insights. We can also create a regression plot. So annual ridership and the two columns that we have gathered, which is station. So the best fit line is over there, and here the error we can reduce. And same again, if we plot this for annual ridership in million with length in kilometers. So that is how we plot the regression line also. Now to sum up this session, let's also do a little bit of region wise analysis, and also a little surprise for you where we have used a few pie plots using Plotly. So that is something that looks interesting and gives you a better picture of the entire data. Alright, so we get the unique values, which is all these 6 regions. We segregate the data based on all these regions. We're using the data.loc or loc, where the region is equal to Africa, Latin America, Asia, Australia, Europe and North America. Now what we're doing is we're using Plotly for sunburst, which looks like a pie plot, but it actually opens up when you click on these. Alright, so just to quickly give you a review on this, we'll go to the Asian and let's check for Latin America first. So this is sunburst, which is going to give us the clear picture of the entire data or the entire metro network in the Latin America. What we have is all these countries. So these are countries. Let's say, alright, I'm sorry guys, these are not the countries. So we have only used the region, the city name and stations. We have not used the countries. I'm sorry guys, these are not the countries. So if I click on Caracas, we have the Caracas Metro, and which has 52 stations and 1 million Repeat. And the annual ridership in million is 358. Let's go back. Let's check for Medellin. And we have the Medellin Metro, which has 27 stations, and the ridership in million is 115. So I can check that for every city that we have in Latin America or in Africa. For in Africa, we have only one city, which is Algiers Metro, which has 19 stations and 45.3 million annual ridership. So this quickly summarized all the data based on regions. So that is how I have segregated the data. If we take a look at Rio de Janeiro, we have the Rio de Janeiro Metro, which has 41 stations, and the annual ridership is 118.7. Now when we have a lot of cities, we have a lot of these columns. So what we can do is we just check for the number of stations over here. Let's say we go to Seoul. Seoul has 2 metros. We have the Korail metro lines, which has 86 stations and 426.4 ridership in millions. And then we have the Shimbodang line New Trans, which has 12 stations and 122.5 ridership in millions. Then in Asia, we can check for other cities. Okay, let's go to Istanbul. So we have the Istanbul Metro, 107 stations. There might be there's Manila over there, which has the Manila Light Train System. Repeat, the Manila Light Rail Transit System, and number of stations is 33 and 218.2 million ridership. Alright guys, so that is all about how we can create a sunburst. So in Bangkok we have BTS SkyTrain, the Metropolitan Rapid Transit, 53 and 60 stations, annual ridership 236.9 and 95.3. So we have Bengaluru also, which is Nama Metro with 51 stations and 174.22 million riders or commuters every year. We have Hyderabad Metro also, which has 56 stations, and these are all the summary of all the cities that has metro in the Asian region. St. Petersburg is also there, the St. Petersburg's Metro, 64 stations and 495 million. So that basically gives me a summary. Then we have for Australia with Sydney Metro, has 13 stations and 12.9 million users. And then we have for Europe, Milan, Munich, Vienna, all these values, the Lisbon, Warsaw, Minsk, and we have Prague, Kiev, Rome. So for Kiev we have the Kiev Metro, which has 52 stations and 279.5 million riders every year. We have for Lisbon, the Lisbon Metro, 56 stations and 184.6 million riders every year. And Barcelona we have for Vienna actually has Vienna U-Bahn, 98 stations with 459.8 million annual ridership. So if we take a look at this Warsaw Metro we have, and similarly we've done that for the North America also. So we have Montreal, Toronto, Vancouver, Washington DC, and there's Miami also. So a sunburst is something that you can use to get a clear picture of all the data points in your data set. Now last but not the least, I want to talk about the data correlation, which gives you a better picture of all the variables that are going to be correlated to each other. And if we check for annual ridership in million, we can see stations and length in kilometers is showing a positive correlation, where stations is actually showing a strong positive correlation, whereas length in kilometers is not that strong but is considerably showing somewhat correlated values over here for annual ridership. So this is where we are going to sum up our session, guys. If you have any questions, you can mention them in the comment section below. And now that we have come to the end of the session, don't forget to subscribe to Intellipaat for more exciting videos, and press the bell icon to get the latest updates from Intellipaat. Also, tell us in the comments about your journey as an aspiring data scientist, which areas excite you the most, and where we can help you master data science concepts in the best possible ways. Thank you.
Machine learning is subcategorized into supervised learning, unsupervised learning, and reinforcement learning. So let's start off with supervised learning. In supervised learning, we teach the machine using data which is labeled. Let's say we have a bunch of fruits and each fruit is tagged with a label. So here the machine learns that an apple looks like this, a mango looks like this, a banana looks like this, and an orange looks like this. So once the training is done, the machine is fed with new data or test data. So here the machine is fed with a new image of apple, and the machine predicts that there is a 97% probability that this is an apple. Now, supervised learning can again be divided into classification and regression. So classifying the input data is a very important task in machine learning. For example, whether the mail is genuine or spam, whether the transaction is fraudulent or not. And there are multiple other examples. So let's say you live in a gated housing society and your society has separate dustbins for different types of waste. So one dustbin for paper waste, one for metal waste, one for plastic waste, and so on. So now what you're basically doing over here is classifying the waste into different categories. So the classification is the process of assigning a class label to a particular item. And in this example, we are assigning the labels paper, metal, plastic, and so on to different types of waste. And one thing to note in classification algorithms is that the output variable is categorical in nature. Let's take this example to understand it better. So over here we have gender of the student and result of the student. Here, gender is the input variable or the independent variable, and result is the output variable or the dependent variable. So we see that our output variable is categorical in nature. That is, it has two categories, either pass or fail. And here we are trying to determine whether the student will pass the exam or not on the basis of the gender of the student. So there are different classification algorithms such as decision tree, random forest, naive Bayes, and support vector machine, to name a few. So let's go through the concept of decision tree briefly. Decision tree, as the name states, is a tree-based classifier in machine learning. You can consider it to be an upside down tree where each node splits into its children based on a condition. So let's take this example to understand decision tree better. Here we are building a decision tree to find out if the person is fit or not. And based on a series of test conditions, we finally arrive at the leaf nodes and classify the person to be fit or not. So the next type of supervised learning algorithm is regression. So when it comes to regression, the output variable or the dependent variable is a continuous numerical. So let's take this graph over here. Here we have horsepower on the y-axis and miles per gallon on the x-axis. Or in other words, horsepower is the dependent variable and miles per gallon is the independent variable. So we see that our output variable is a continuous numerical. And here we are trying to determine how does the horsepower of the car vary with its MPG. So this is the concept of regression. Now let's see some of the use cases of supervised learning. So first we have spam classifier. So how do you think your mail is being classified as whether it is spam or not? So this spam detection basically works on the concept of filters. So mainly there are two types of filters, text filter and client filter. The text filter works by using algorithm that detects which words and phrases are often used in the spam email. So phrases like lottery or you won or free Bitcoin are often an immediate flag for removal by filters. So next is the client filter. As the name states, client filter understands the client identity and history to block malicious and annoying spam email. So how does this client filter work? Well, this is done by looking at all the messages of a certain user which he has sent out. So if a user has sent out huge amount of emails constantly, or several of the user's messages have already been marked as spam, then in that case their email will be blocked entirely. So this brings us the use of blacklist. So spam filters also include something known as blacklist. So blacklisting is the process of adding known email addresses of a spammer to a list. And this list prevents the user's messages to be forwarded to someone else. Now let's look at the next use case, fingerprint analysis. So in fingerprint analysis, you save your fingerprint in a machine as a record. So the machine checks the data and verifies whether the data belongs to you or not. So once the data is saved into the machine, from next time whenever you put your fingerprint on the machine will scan through all of its user data. And if the machine finds a match of your fingerprint in its data, then your fingerprint will be verified. Now that we've completed the different types of supervised learning algorithms, let's go ahead and understand what is unsupervised learning. So when it comes to unsupervised learning, the input data doesn't have any labels associated with it. The machine understands the underlying structure of the data to identify similar patterns, and the data which is similar in nature is grouped together. So here, even though there are no labels, the machine understands that all the apples are similar in nature and thus they are grouped together. And same is the case with bananas and oranges. So this is the concept of unsupervised learning. Now let's go through an unsupervised machine learning algorithm called as k-means. So the aim of k-means is to group similar data points into a single cluster. So there must be high intra-cluster similarity and low inter-cluster similarity. That is, all the data points within a cluster should be as similar as possible, and all the data points between two different clusters should be as dissimilar as possible. Or in other words, all the points inside cluster A should be very similar to each other. But when we compare a point from cluster B with a point from cluster C, then they would be very dissimilar to each other. And in k-means clustering, k denotes the number of clusters to be formed. So in this picture over here, the value of k is 3 and hence 3 clusters are formed. Now let's go through a use case of unsupervised learning. So Netflix recommendation is a perfect use case of unsupervised learning. So more than 80% of the TV shows that you watch on Netflix are discovered through the platform's recommendation system. It means the majority of what you watch on Netflix is the result of decisions made by a mysterious black box of an algorithm. So let me just give you a brief of how it works. Well, Netflix uses machine learning algorithm to recommend you a list of movies and shows that you might not have initially chosen. To do this, it looks through a thread within the content rather than relying on broad genres to make a prediction. This explains how 1 in 8 people who watch Marvel shows are completely new to comic book based stuff on Netflix. And finally, there's reinforcement learning. So in reinforcement learning, the algorithm learns through a system of rewards and punishment. And the goal here is to maximize the total reward. Let's take this example to understand reinforcement learning. So here we have a self-driving car which is supposed to reach its destination without hitting any barricades. So here, the self-driving car is the agent and the road is the environment. Here the car takes an action and goes straight. But when it goes straight, it directly hits the barricade. Now since the car has taken a wrong action, it will be punished. So the car realizes that going straight is wrong and it has to go right. So when it goes right, it will be given a reward. So this process continues and the car learns how to drive by itself without hitting any barricades. So the obvious application of reinforcement learning is a self-driving car. A recent study has shown that over 90% of road accidents are caused by human error. So to err is human, but behind the wheel, mistakes are often more catastrophic. Accidents have led to a massive amount of unnecessary deaths. So this is where self-driving cars come into the picture. So trust me, the autonomous car or the self-driving car is much safer than a human-driven car. They are unaffected by factors like human fatigue or illness, and this makes them very safe. And self-driving cars are always attentive, observing their environment and scanning multiple directions. It would be difficult to make a move that the car is not anticipating. So how does a self-driving car work? Well, self-driving cars mainly rely on 3 technologies: IoT sensors, IoT connectivity, and software algorithm. There are many types of sensors available for a self-driving car. For example, sensors for blind spot monitoring, forward collision warning, radar, and so on. So all of these IoT sensors work together to help in navigation of the self-driving car. Next is the IoT connectivity. Self-driving cars use cloud computing to act upon traffic data, weather, maps, adjacent cars, and so on. This helps the car to monitor its surroundings better and make informed decisions. And next is the software algorithm. all the data which the car collects needs to be analyzed to determine the best course of action. And this is the main function or the control algorithm. And this is where reinforcement learning comes into the picture. This is the most complex part of the self-driving cars since it has to make decisions flawlessly. So in today's world, the most famous self-driving cars are those from Tesla and Google. So Tesla cars work by analyzing their environment by using a software system known as autopilot. So autopilot uses high-tech cameras to view and collect data from their environment. So it's the same as what we do with our eyes. And autopilot uses this data to make decisions during navigation. Now let's quickly head on to the quiz. So this is our first question over here. Amazon product recommendation uses which of the following machine learning techniques? Supervised learning, unsupervised learning, or reinforcement learning? So guys, what do you think is the answer? So whatever you think is right, do put down in the comment box.
Just a quick info guys, Intellipaat offers a data science course in collaboration with iHub IIT Roorkee, which will help you master concepts like Python, SQL, machine learning, AI, Power BI and more. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth with the data science course.
Alright, so now I believe you are clear with what exactly the different types of learnings in machine learning are. You are clear with unsupervised and supervised learning through hands-on examples like, let's say, linear regression, logistic regression, support vector machine, decision tree, as well as clustering. Now that you're clear with all of these algorithms, the next step is to work on hands-on project. Project is very important when you're getting prepared for data science jobs. Projects are the key pillars that basically add value to your resume as well as your portfolio. So the next step is working on a project. So that is the reason why in the upcoming model, what we are going to do is we are going to cover one data science project. That project is based on recommendation system. So without wasting any time, let's dive deep into it.
If you're new to machine learning, linear regression is the easiest algorithm to understand and implement. In fact, this is the first algorithm you're going to learn at the very start of your machine learning journey. Even though it might seem like a big task, within this video, this concept has been covered in a way that even a high school student can understand it easily. For starters, let me help you visualize what linear regression is all about. Let's say I have some data on the heights and weights of a few people, and I want to use this same data to predict the possible weight of a new person provided his height. Now from this given data, we want to find a pattern that allows us to predict the weight of a new person for a given height. This makes our weight column the target variable and the height column as our input variable. Now how can we imagine the relationship between these two features? Simple thing, we can plot them and understand their relation. Now the simplest way to find this pattern is to assume a straight line relationship between height and weight. This is also called linear regression. The line follows the formula y is equal to alpha into x plus beta. Here y is a predicted weight or predicted feature. X will be the height. Alpha is the slope of the line. It shows how much weight changes with height. And beta is the intercept, that is where the line starts. To make the best predictions, we need to find the values of alpha and beta so that the line fits the data as closely as possible. Now what do we mean by this? Basically, the line should try and touch maximum of the data points. To achieve exactly that, we will minimize the difference between actual and predicted weights. Okay, this might sound a lot, but it's not. Let me hand over the proceedings to one of India's best data science trainers. He's right now leading the AI development team in one of the world's renowned fintech companies. And after he's done teaching, I am 100% sure you will never have to retouch upon this concept of linear regression.
Imagine you have a data set like this. You have weeks and sales, right? So week, W-E-E-K, week, okay? This is the first week, the second week, the third week, the fourth week, and the fifth week. Example, you have 5 weeks, okay? And the number of cars you have sold so far is like this, right? So the number of cars you have sold could be n number, right? So you have, let's take it like this, right? You have week in one of the variables, and the number of cars you have sold so far in those weeks could be 2, 4, 5, 4, 5, some numbers, right? This is the data that has been given to me. Sir, can we mathematically understand in depth how does linear regression work? What does it actually do? And how does it make our life easier? Okay. In order to understand how linear regression works, first we need to plot this data. Okay. We need to take the data and we need to plot it in the XY graph. How do we do that? In a very simple sense, I'm going to take the variable like this. I'm going to take a straight line and I'm going to pass it like this. Okay, I'm going to have this. So this is my x-axis and this is my y-axis. Okay, I'm going to point it out like this. So what is going to be my x-axis? Will week be on the x-axis? Can I say this is 0, this is 1, this is 2, this is 3, this is 4, and this is 5. Can I say it like this? This is the 5-week data. So this is 5, week is X. Okay. What is going to be my Y? The number of cars sold. So can I say this is 1, 2, 3, 4, and 5. So 0, 1, 2, 3, 4, and 5. Anybody has any confusion in what graph did I plot? No, right? It's a simple graph. Nothing complicated. Very good. So in the first week of my graph, how many cars did I sell? I sold 2 cars. So can I have the red pointer point like this? Good. In the second week, I sold 4 cars. So this is 4 cars. In the third week, I sold 5 cars. Okay, so I sold 5th car like this. In the fourth week, I sold 4 cars. So this is 4th car again. And in the 5th week, I have sold 5th car or 5 cars. So, like this. Is this the data that has been given to me with the weeks versus the car sold part? This is the data that has been given to me. Okay. My people, let me ask one question to all of you. Isn't it possible that there is infinite number of lines possible for this particular data? Meaning a line like this is also possible, this is also possible, this is also possible, this is also possible, this is also possible. Meaning to solve this problem, infinite number of lines are possible that will pass through the data point. Agree or disagree? I want to identify which line is the best line. Which line represents the best line for this particular data. In the previous example, I said line will pass, but what line? Which line? How do we identify that? We don't know anything. So in order to solve this problem logically, isn't it best to first understand where the line would pass from? Meaning, I'll give you guys an example. Listen to me. Suppose I have a point like this, a single point in a 3-dimensional space. Is this line possible in a 3D space? Is this line possible? Is this line possible? Is this line possible? Is this? Basically, infinite number of lines are possible through one single point. Yes or no? Okay. But will the point move if I fix the point? Meaning, if I tell you this is the fixed point, the point won't move, correct? Only the lines are possible through that point. Agree? Yes or no? Okay. So listen to me. Can I not do one thing that is a guaranteed good point? I mean, the point that I'm recommending right now is a good point. What do you mean? In your x-axis, what is the mean of your x-axis? Can somebody tell me what is the mean of x-axis? Basically, the mean x bar of mean and x bar or y bar of this. What is the mean of x-axis? Is it going to be 3? The number 3. And what is y bar? What is the mean of y bar? 4. Agree, disagree? The minute you plot the data, the first thing you should do is take the mean and take the mean of x and take the mean of y. So can I say that the mean of x is 3? So it is going to pass here. I'm gonna take a different color. Give me 1 second. I'll choose purple. I'll choose peach. Yeah, peach is good. Okay. So control Z. Give me 1 second. Is this the mean of x-axis? This peachy line that you see? Very good. What is the mean of y? Is this the mean of y? The minute you took the mean of x and mean of y, did you get a point for reference where the line should pass from? The minute you took the mean of x and the mean of y, you kind of got a reference via which a line could pass. Agree, disagree? But in this scenario also, listen to me. In this scenario also, isn't this line possible? Isn't this line possible? Isn't this line possible? Oh, it's complicated. So many lines are possible, but it's okay. We'll solve the problem one step at a time. Is this step clear to everybody? Take the mean of x and the mean of y. Step number 1. Take the mean of x and take the mean of y. Okay. Now, what you need to do is this. Okay. Your week data, I'm going to take it as x. So what is the x data that has been given to me? 1, 2, 3, 4, and 5. Everybody agrees? This is my x-axis data. Very good. What is the y data? It is 2, 4, 5, 4, and 5. Okay. This is my x-axis data and this is my y-axis data. Okay. What you need to do right now, the minute you calculate this part, x and y, so can we take first data point and try align with connect points? You will calculate something called x minus x bar. Hey, what is x minus x bar? Is this data point called x? This particular data point called 1 minus 3. From the perspective of 3, I want you to understand from the perspective of the number 3. Is this number 1 called x value and this is the x bar? This point is called x bar and this point is called y bar, yes or no? So basically, aren't you calculating that 1 is deviating from 3 by how much? 2 is deviating from 3 by how much? 4 is deviating from 3 and 5 is deviating from 3 by how much? Are you calculating this exactly? Yes or no? So tell me, x minus x bar meaning 1 minus 3. What is 1 minus 3? What is 1 minus 3? Minus 2. Very good. What is 2 minus 3? Minus 1. What is 3 minus 3? 0. What is 4 minus 3? 1. What is 5 minus 3? 2. So tell me, from the mean value, is this 1 point not in the negative 2 direction? Isn't from the mean this point 2 in the negative 1 direction? From mean, the mean itself is at 0 distance, meaning it is within calculation of itself. Then this number at 4 is 1 positive distance and this number to 5 is a 2 positive distance. Did it not give me the spread? The information, not exactly spread, but did it not give me the information of the deviation I have in the data? Minus 2, minus 1, 0, 1, and 2 with the number format. Is everyone clear? We kind of got the idea of how much is this part. Okay, because you did this with x, don't you need to do this with y also? So you need to calculate something called y minus y bar. Y minus y bar. So tell me, what is 2 minus 4? What is 2 minus 4? Minus 2. What is 4 minus 4? Is it 0? What is 5 minus 4? Is it 1? What is 4 minus 4? Is it 0? And what is 5 minus 4? It is 1. Is everybody clear what we did here with the calculation of x minus x bar and y minus y bar? What did we do with this? Why did we do it? To understand how far off my data lies from the actual mean value. Are we clear? Are we clear until here? Good. The next thing that we do, okay, is there any reason to take x equals to 3? What you have to do next is x minus x bar the whole square. You know why should you take the whole square? Because isn't minus 2 and plus 2 cancelling each other out? If I want to add them together, will I be able to add them together? Will I be able to add them directly together mathematically? The minus will nullify the plus value. Agree or disagree? So that the nullification does not happen, what do? We take x minus x bar the whole square. Doing squaring of a number, what does it make sure? That the number is always positive. Agree, disagree? If you take minus 3 and if you square it, won't the answer will be 9? And if you take 4 square, the answer is 16. So squaring will make sure that the number is never negative. So nobody will get cancel each other out, right? So what is x minus x bar the whole square? Minus 2 square. Can I say that is 4? Minus 1 square. Can I say it is 1? 0 square. Can I say it is 0? 1 square. Can I say it is 1? And 2 square. Can I say it is 4? Yes. Now, if you take the summation of all the values, what do you mean by summation? Addition of all the number. So tell me, what is 4 plus 1 plus 0 plus 1 plus 4? 8, 9, 10. Can I say it is 10? Can I say that the summation of x minus x bar into y minus y bar is this? Okay. Until here is everybody clear. Until here is everybody clear. The next thing you calculate is what we called as x minus x bar into y minus y bar. Now listen to me carefully. Can I say that this data point and this data point distance is called as x minus x bar? From this data point to this data point is called x minus x bar. Now listen to me carefully. Listen to me carefully. Can I call this also x minus x bar? This distance can be called as x minus x bar. Yes, good. Can this distance be called as y minus y bar? If I multiply x minus x bar into y minus y bar, essentially what I'm doing is, this is x minus x bar, this is y minus y bar. Multiplying them together gives me this answer. If I have an area of a rectangle, length into breadth gives me the entire area. Yes or no? This point, this line is nothing but x minus x bar. This line is y minus y bar. Am I not doing x minus x bar into y minus y bar? If I do x minus x bar into y minus y bar, can somebody tell me what is x minus x bar? Is it minus 2? Is the answer x minus x bar going to be minus 2? Yes or no? Multiplied by, what is y minus y bar? Minus 2. What is the answer? Is it 4? Very good. X minus x bar is minus 1. Multiplied by y minus y bar is 0. Is the answer 0? Okay. What is x minus x bar? 0. What is y minus y bar? 1. Is the answer 0? What is x minus x bar? 1. What is y minus y bar? 0. Is the answer 0? What is x minus x bar? 2. What is y minus y bar? 1. Is the answer 2? If you sum the numbers together, 4 plus 2, what is the answer? 6. Are you clear so far? What did you do here while the calculation of this x minus x bar, y minus y bar? You have a line equation called y is equal to mx plus c. Yes or no? This is the line equation. Everybody agrees? Do you know the value of m so far and the value of c so far? Are you clear with the value of m and c? The answer is no. Isn't this the first thing you need to calculate? What is the m, what is the c, so that we can find out the line that can cross? Okay. To calculate the value of m, to calculate the value of m, using mathematical derivations. Do you understand what is derivation? You start with the base equation, you solve, and you get some answer. So, mathematically speaking, to get the value of y-intercept, or sorry, to get the value of slope, the formula is summation of x minus x bar into y minus y bar divided by summation of x minus x bar the whole square. Do we have the values for this? What is the value of summation of x minus x bar into y minus y bar? What is the answer? Is it 6 divided by summation of x minus x bar the whole square? Can I say it is 10? So the answer is 0.6. Did you just get the value of m, the slope of your line? We just calculated the slope of the line. Now listen to me carefully. Sir, how did we get this formula? Did someone calculate it? Yes. Somebody has already calculated this using mathematical derivation. If you want, so first of all, I don't think you should learn derivations because somebody has taken enough effort to solve the derivation. Me teaching you the derivation is only going to take time, but it is not going to be important for you to know. What's important for you to know is to remember the formula. I can teach you derivation also. It's not a very complicated thing. It's a simple mathematical process. But the problem is that derivation will have no importance to you. Am I making sense? What formula it is, you need to understand that clearly. How you arrived at it can always be learned eventually over a period of time. But first, you need to understand what is linear regression, how it is applied, how can I practically implement it, then giving your energy to how did the derivation occur, who wrote it for the very first time, what is the history. I think you should focus on your priorities slightly differently. So did you understand why I wrote down the formula straight up for you so that you don't get confused? It is arrived using a derivation. This mathematical derivation is slightly complicated, slightly simple, but we have the formula. Okay. Here we are squaring the number and denominator. Yeah, I mean, this is the summation value. We are not squaring anything. It's summation of x minus x bar into y minus y bar by the summation of x minus x bar, the whole square. This will give you the y-intercept. The logic is pretty simple, but in the derivation, you will see why we do the division because this goes on the left side of the equation. So we put it in the bottom. Okay. Anyways, this is the value of y. Now, between y is equal to mx plus c, what did we calculate? Did we calculate the value of y? It is now calculated. But do we have the value of c? No. We don't have the value of c. So to calculate the value of c, how do we calculate it? The formula to calculate the value for c, you have to use this equation. Y bar is equal to mx bar plus c. Now tell me, in this formula or in this equation, do we have the value of x bar and y bar already given to us? What is the value of x bar? X bar is equal to 3 and y bar is equal to 4. Yes or no? So you have this equation called y bar is equal to mx bar plus c. Okay. To calculate slope of any line, mathematically, you have to calculate the delta, the difference. Meaning, if you have a line here, right? This difference in y and this difference in x will help you calculate this. And while the derivation of linear regression was done, right? So, पहली चीज क्या है ना, हर फॉर्मूला मैथमेटिकली सेंसिबल हो ये जरूरी नहीं है. लेट मी आल्सो टेल यू व्हाई. आप पहले सुनिएगा ध्यान से और समझने की कोशिश कीजिएगा और फिर मेरा तर्क समझिएगा कि मैं क्यों ऐसा कह रहा हूं. एक मैथमेटिकल डेरिवेशंस में क्या होता है, जो डेटा होता है, जो नंबर होता है, वो किसी फॉर्मेट में होता है. जैसे आपको एक एग्जांपल देता हूं मैं. हमने इनिशियल एग्जांपल जब किसी डेरिवेशन का लिया तो वो डेरिवेशन में हमको बहुत सारे अजम्पशंस लेने पड़ते हैं. लेफ्ट हैंड साइड, राइट हैंड साइड को 10 से डिवाइड कर दिया. लेफ्ट हैंड साइड को लॉगरिदम, नेचुरल लॉगरिदम से डिफरेंट बेस लॉगरिदम में कन्वर्ट कर दिया क्योंकि वो नंबर्स मैच नहीं हो रहे हैं. तो क्या होता है, इवेंचुअली हम किसी डेरिवेशन को जब स्टार्ट करते हैं, स्पेसिफिकली ये लीनियर रिग्रेशन की जो डेरिवेशन है ना, आपको अगर मैं पूरा डेरिवेशन सिखाऊंगा तो आपको समझ में आएगा कि क्या हो रहा है. कि इनिशियली जब हमने स्लोप को लिया था, जो स्लोप का एक्चुअल फॉर्मूला है हम उसी को कंसिडर करते हैं. बट इवेंचुअली जब हम इसको ना सॉल्व करते हैं, मतलब सॉल्विंग फॉर द लेफ्ट हैंड साइड एंड राइट हैंड साइड, जब हम सॉल्व करना स्टार्ट करते हैं ना, तो हमको रियलाइजेशन होता है कि मे बी लेफ्ट एंड राइट में ना कुछ और ऐड करना पड़ेगा ताकि वो बैलेंस आउट हो जाए। करते 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 जाते हैं तो इवेंचुअली वो जो फॉर्मूलाज हैं वो थोड़े डिफरेंट फॉर्म में कन्वर्ट हो जाते हैं। फिर हमें क्या करना पड़ता है, m के लिए ऊपर वाली वैल्यू को नीचे लेके आना पड़ जाता है। तो क्या हो जाता है कि आपका ये जो समेशन ऑफ x माइनस एक्स बार द होल स्क्वायर है ना, ये लेफ्ट हैंड साइड में आता है, और ये जो समेशन ऑफ x माइनस एक्स बार ये राइट हैंड साइड में आएगा। तब क्या होगा, ओवरऑल जब हम सॉल्व करना स्टार्ट करते हैं ना, तो ये समेशन वैल्यूज जो है, जो ये आपको ये फॉर्मूला दिख रहा है, इट स्टार्ट्स सॉर्ट ऑफ फॉर्मिंग इनटू दिस पर्टिकुलर फॉर्मूला। जो आपको ये दिख रहा है ना, ये इस फॉर्म होना स्टार्ट होता है। एक काम करते हैं, व्हाई डोंट वी सॉल्व द डेरिवेशन आल्सो सामने ही। इफ यू रियली वांट टू अंडरस्टैंड मशीन लर्निंग, yeah, the point is, if you want to deeply understand machine learning, like when I'm talking about deep, because here is the thing, when I started machine learning, right, I have implemented each algorithm, every algorithm in machine learning from scratch. I have done that. That is when my knowledge in machine learning increased 10 times, because when you do not use any packages, any libraries, understand the core mathematical concepts, you should be able to like build anything because you now understand the basis behind it, right? Just like that, learning the core mathematics is important. The reason I am not going ahead with the derivation and explain you logically how did we arrive at this conclusion is because it will end up taking a lot of time. Number one. Number two, the mathematical reasoning that it takes to arrive at this solution is also going to be very, very complicated for few people. So that's why I said, if you start with machine learning right now, you guys are just starting with machine learning, right? Focus on how to apply machine learning, then learning the foundational logic. But because if the question is, how did we arrive at this conclusion? We can always go back and learn the derivation also. So it's up to you guys. I mean, if derivation is also something that we can look at, we can also look at this. The derivation will make sense. Why are we taking this area x minus x bar the whole square will start making sense, because it is directly related to residuals. So now that we've understood, right, slope of the line using the data point or variable, which is one independent, one dependent, we are able to calculate the equation, slope using this particular formula. Now that we've understood how we calculated that using the slope, the next thing that's pending is for me to calculate the y-intercept, okay? Because y-intercept cannot be calculated directly, I need to manipulate my equation slightly differently, like y is equal to mx plus c. Because we don't have m and we don't have c, right? We don't have c, sorry, y and x. We calculate y bar and x bar. X bar is already given to me as 3 and y bar is already given to me as 4. So tell me, what is the value of y bar? Is it 4? Is equal to, what is the value of m? 0.6. What is the value of x bar? Is it 3 plus c? So mathematically, if I solve this, 4 is equal to, what is 0.6 into 3? Is it 2.2? Okay, that's good. 2.2 plus c. Now, listen to me. In mathematics, when you jump equal to signs, you convert the sign from positive to negative or negative to positive. Meaning, if this 4, if this 2.2 needs to jump to the other side of the equal to, what will it become? Will it become 4 minus 2.2 is equal to C? Yes or no? Whenever you change the number from one part of the equation to the other part of the equation, if it is a, so what will be the value of C? What will be the value of C? 2.2. Wait, 0.6 into 3 cannot be 2.2. I don't know if it makes sense to me, because 6 threes are 18. It should be 1.8, right? If I'm not wrong, 6 threes are 18. Point difference is 1.8, right? Yeah, this should be, I think the difference is 2.2. I think this is what you mean. Yeah, I think I got the concept. Okay. This is C.2. Yeah, D is 2.2. Exactly. So tell me, did you get the equation y is equal to mx plus c, and now you have an equation for the line 0.5 into x plus the value of c will be 2.2. Did you get the line equation for your data using the steps that we have done so far? We got the equation called y is equal to mx plus n, and we got the line. But our job is not yet done. Until here, is everyone clear? Until here, is everybody clear? What exactly did we do to solve until here? Everyone got the concept until here. 0.5 or 0.6. But there is so much more to achieve, meaning you got the line equation 0.6x plus 2.2 something something something. My people, based on the linear equation graph that you see that I have plotted for you like a while ago, which is this. Okay, give me 1 second. Let me copy the graph. Give me 1 second. Let me just go ahead and copy this and paste it here. Give me 1 second. Copy this and paste it towards the bottom. My people, we got the equation of the line equation as y is equal to something something like this. Like, so we got a line equation that passes the data like this. But observe very, very carefully that the distance between your actual data point, is this my actual data point? AP is my actual data point. AP is the actual data, the real data. And the line is the prediction. Agree or disagree? This is my predicted data and this is my actual point and predicted point. Can I say it like this? Do you see there is some difference between it? Some distance, some error? Yes or no? This error exists here also. This error exists here also, here as well, and here as well. There is some distance between this, and this, the data points are distance. This distance or difference is called as residual. What do we call this? What do we call this? Residual. Tell me, the point is very simple. When you make linear regression line happen, or when the linear regression line has been calculated, do you want the distance between data point and the actual point to be the least as possible or to be the maximum as possible? What should your intention be? Your intention should be to minimize, right? Your intention should be to minimize the residual, but your life and your job is not that simple. Let me explain why. Let me explain why this is not simple. Listen to me carefully. I'm going to erase these data point, okay? The line point, and I'm going to show you guys an example. Mathematically, also sensibly, it should make sense to you. Okay, give me 1 second. Let me copy this graph and paste it so that I don't ruin the graph. Give me 1 second. Why am I not able to copy? Okay, this is the copy, is it? Okay, fine. Yeah. So listen to me carefully. I'm going to erase the middle line for a second so that you guys don't get confused. Okay, X bar, Y bar, I'm going to remove. My people, now we have a line that passes through the data like this. Okay, it is passing through the data point like this. Listen to me carefully. And it is passing through the line like this. Like, this is the line that we have calculated. Okay. This is the distance between the predicted data point. This is the predicted data point, and this is the actual data point. Okay. So tell me, isn't this data point the data point which is predicted versus this is the actual data point? This is the data point which is actual, that is, this is predicted, that is actual, this is predicted, that is actual, this is predicted, that is actual. So listen to me carefully. This is the error, also called error number 1. Can I call this difference as error 1 E1? Yeah, can I call this error as E1? Okay. Can I call this error as E2? Can I call this error as E3, this error as E4, and this error as E5? Can I call this E1, E2, E3, E4? So the best possible line for me to claim that the line that I have has the best fit. It's fitting the data points in the best possible way. So shouldn't that be possible that E1 plus E2 plus E3 plus E4 plus E5, this number should be the most minimum number as possible? Yes or no? The number E1 plus E2 plus E3 plus E4 plus E5 should be the most smallest number possible. But the problem here is some data points are following in the positive direction, meaning in the bottom, and some number are at the top. So isn't it possible that E1 and E2 will also cancel each other out because the directions are different? Does that make sense? See, from this data point to this red data point, it is in the negative direction, but E2 is in the positive direction. So if I don't square them, won't they also cancel each other out? And the actual answer will be terribly wrong. So rather than combining E1, E2, E3, E4, E5, do we not take E1 square plus E2 square plus E3 square plus E4 square plus E5 square? Agree, disagree? Now listen to me carefully. Listen to me carefully in a most simplistic sense. Okay. If I take this line and rotate it a little bit more, the line that we have calculated it just for practical purposes, just to test something. Can I rotate it a little to the left and a little to the right? And when I rotate it 2 times to the left, one left, one left, one right, I got the value of error, ERROR, TOTAL, total error as 1.6, 1.2, 1.9, and 2.3. When I rotated the line, which line gave me the least amount of error? In this 4 rotation that I did, 2 to the left, 2 to the right, did this give me the least amount of error? That line is your best fit line. Did that logically make sense? Did that logically make sense? Okay. Can I show you an example? Can I show you an example practically to show you how in reality in linear regression, how it works? You guys want to have a look? Have a look at this, okay? Linear regression, best fit line, okay? Fit line. Look at this, my people. This is my linear regression data. Can you see what's happening to the line? Did you see what happened? Did you see what happened? See, I'm going to rotate the line, okay? I'm rotating the line. Is the error increasing and decreasing? Are the errors increasing and decreasing because of the rotation? Have a look at this also. See, this is the best fit line. Do you see the mean of X and mean of Y? Do you see the mean of X and mean of Y? We took the red color line. On that point, are we rotating the line that we just calculated Y is equal to mx plus c? When the rotation when we do that rotation, isn't it possible that we can get the value of multiple different error types? And whichever error has the least possible error, that line is the best fit line. Did you understand the logic behind how linear regression is able to calculate the least amount of error? And that line is going to be the best fit line for your example. Is everyone clear what we did in linear regression? First, we plotted the data. Then we took the X bar and we took the Y bar. Sir, we have to code for this. It's too long. The entire linear regression code is 15 lines of code. 15 lines. Without any library. Without any library, it's 15 lines of code. Do you think it's too much? Point B, first we plotted the data, then we took the mean X, mean Y. From that point, we passed the problem or we passed the line, and now we are rotating the line a little bit to check whether the data or the line is the best fit line. Did you get what exactly I was saying? What line rotation is showing exactly? Line rotation shows you the distance between the error. Meaning, suppose if this is the graph that I have, okay, this is the graph that I have, this is line number 1. Is it not possible for me to rotate the line slightly and have another line like this? If I rotate the line, the distance between actual data point and your prediction data point, does it not change? And your job is making all the errors together, E1 plus E2 plus E3 plus E4 plus E5, all the errors together. Don't we want a number, a value of the line where all the errors together is the least number possible? That is why you rotate the line. Rotate the line The only thing you need to change in your equation is m, right? Because y will remain the same. Or no? To rotate the line, what do you need to change? Both m and c, right? You need to change both m and c together for the line to rotate, right? So multiple values of m and multiple values of c will give you the answer. Isn't this like the initial guess of the line? The initial guess of the line, is it the best fit line? The first product you buy, is it the best product? No. We just made a guess on the y, axis equation. We did that. But is that line the best fit line? Are you sure that is the best fit line? Can you be sure? No, right? In order for us to understand which is the best fit line, we take the line that we just calculated and we rotate it a little bit. Based on the rotation, whichever error value has the least error, that is the best fit line. Now, my question is, how many of you got this and how many of you did not get it? Let me take up a quick poll. How many of you got it? Yes, yes, yes. How do we calculate it? How do we do it? I'm going to teach you all of that. How many times to rotate? The higher you rotate, the better chances of best fit line it is. The higher you rotate or the longer you rotate, the better the chances you will find a best fit line. If we rotate, are we not changing the C 2.2 which we calculated? Yes, we calculate both the L, M and C, we change and we check for multiple C and M. Okay, let me explain. How do we rotate? How do we rotate? Let's understand. Let's understand the rotation. Is this my line with some value of M and C? Yes or no? You first please tell me that. Is M is equal to, is the value of M 0.6 and the value of C 2.2? Yes or no? If I want to rotate, this is the line, okay? This is the line which will give me this y, M is equal to 6.6. If I want to rotate it by one degree, 1 point, increase M and decrease y, can I do this? Or decrease M, increase y, can I do this? Are you getting what I'm trying to say? This is my XY graph. This is my y point on which the line is plotted. And this slope of the point is 0.6. Make it 0.5 and make the intercept here. Will the line now rotate by some point here? Increase point number 1 by one more point, decrease the slope by 1. Will the line rotate now? Same thing, keep doing. Increase the point by 1 and decrease the point. Did you now rotate the point slowly, slowly, slowly by changing this decrement by 1, increment by 1? And now if you do the reverse operation, it will go in the opposite direction. Agree, disagree? Am I making sense? In this part, at least in this part, 1.1.1.1.1 increase. Won't you be able to calculate for multiple values of y, like the line will rotate? This is the line equation that we calculated. Listen to me carefully. Based on the data, what did we do? Based on the data, what did we do? Did we calculate the y is equal to mx plus c equation? That was the first thing that we did. Yes or no? Y is equal to mx plus c was the first thing that we calculated. The line equation that you calculated, y is equal to mx plus c. How sure are you that that line is the best fit line? Can we be sure that the line equation that I calculated, y is equal to 0.6 into x plus 2.2, this is the line which is the best fit line? What do you mean by best fit? The line passes through all the data point in the most perfect way. Are you sure that this is true? Should you not validate that? We are not sure. Should we validate? The answer is yes. You need to validate. In order to validate, how do we validate if something is good or not? Mathematically, we need to have some foundation for it, right? How do we identify somebody is a good ranker, somebody is a bad ranker? Shiv Kumar, who spoke to me a while ago, is a Bihar topper. How do we know he's a Bihar topper? He must have gotten good score. His percentage would have been higher. The number would have been bigger. If the number is smaller, does it equally mean that the person did not score well? Yes or no? This is called mathematical quantification, meaning some number is trying to give us the idea. So tell me, suppose I have a line called line number 1. This is my line. This is the line. My people, this red color point, is it my actual data point? Is this the actual data point that was available in the data? Good. But using the line, did you predict another data point, which is your prediction? This point on this line is your prediction. This is not the actual data. This is your prediction. Yes or no? Can I say the distance between the prediction versus the actual value is -2? Example. For example, it is -2. Can I say this? Good. The distance between this data point, the red actual data point, and this data point is +2. The distance between the red data point and this data point is +3. The distance between this data point and this data point is -3. And the distance between actual data point versus this predicted data points is -2. Example. So far, the total error in the program is nothing but the difference, right? Difference between the actual and the predicted is what the error will be, right? So -2 plus 2 plus 3. Okay, so -2 plus 2. Let me expand it and write this, okay? So let me say -2 plus 2 plus 3 plus -3 plus -2. If I add them together, will this not be the actual difference, the error in my program? Isn't this going to be my error? But -2 will cancel 2, plus 3 will cancel 3, and the answer is -2. Is the answer actually -2? No. Even if they are not equal, even if the numbers are not equal, okay? The problem here is mathematically, if this number was -2 and this was -2.1, won't the answer be 0.1, which is also not correct? The numbers don't need to be equal, but they cancel each other. They take a portion of each other. We don't want that to happen. So rather than taking errors like that, don't we square them, the errors? Yes or no? So rather than taking the answer like this, if I want to quantify the number, can I not take -2 square plus 2 square plus 3 square plus -3 square plus -2 square? The answer will be 4 plus 4 plus 9 plus 9 plus 4. Can I say now this will be some number that represents the error? Are we clear until here? Dipankar, even if it's not equal, it does not matter, my dear, mathematically. It won't make difference also. If one direction it's -2, other direction it is unequal number, errors will still get added together, right? At the end of the day, you're adding the errors together. It does not matter if you have 10 rupees, 15 rupees, 19 rupees. It does not matter what number you have. The errors at the end of the day are getting added together, but you're trying to nullify them. I am not nullifying them. I am taking the difference between the actual data point and the predicted data point and square them. I am saying that you should square it. I am not saying nullifying it. I am saying square it so that nullification does not happen. I know positive and negative predictions. That's why I'm saying squaring them will convert it into a positive number, and all the positive numbers you can add together. You got, this is a very simple thing, my dear, not a very complicated thing. -2 and +2, if you square, -2 square is 4, +2 square is 4. If you add them together, did you get the value 8? 8? Agree, disagree? Yeah, okay. Even if you have 15 points, 1500 points, whatever points you have, the distance between the actual versus predicted data point, you need to square them in order to get the error. So tell me, what is 18 plus 12? What is 18 and 12? So 8, 9, 10. This is going to be 30. So did we get the error? The total error using the line is 30. Yes or no? We are not nullifying anything. We are trying to get some number. Okay. Now tell me, I'm asking a very simple question. Very simple question. Are you sure this is the best possible line in the entire data that you have? No. If I rotate the line slightly to the bottom, isn't it possible that that total error now will be 29. Slight rotation gave me the error as 29. And we want the error to be as minimum as possible. So will you choose line number 1 or will you choose line number 2 as the best fit line? If this is my line, okay. Do you guys know that in mathematics, you can take a range between 0 to 10? I can take 0, 1, 2, 3, 4, 5, 6, 1 point at a time. This also is possible between to reach 0 to 10. Okay. 0 to 10 can be reached by 1 unit distance, meaning between 0 to 10, I can reach 10 by exactly how many steps? 10 steps, correct? Taking one at a time. Agree? Yes or no? If I want to count from 0 to 10, but I want to take one step at a time, so can I take from 0 to 10, making only one step at a time? I'll be able to reach 10 times. But same 0 to 10, you can reach in 20 steps by taking 0 0.5, 0, 0 0.5, 1, 1.5, 2, 2.5, 3. Can I say you can reach from 0 to 10 using also 40 steps by taking 0. I don't know, 25? How much to rotate? Should it not depend on how much you want to increment your MNC? Am I making sense? Your y is equal to mx plus c. Your value of m was 0.6 and your value of c.2 was 2.2. Your m can be 0.65, meaning 0.05 times your increment one step, one step, one step, one step, one step. Or you can also do 0.1. So 1, 1, 1, 1, 1. Does it not depend on the user how much you want to rotate? Does that make sense? And because it is a computer program, we can make it do millions of rotations. That line could be rotated in the positive direction and in the negative direction. And let me ask you a question. Let me ask you a simple question. Did we not calculate the mean of x and the mean of y like this? Did we not calculate the mean of x and mean of y? Should you even rotate it beyond this and beyond this? Meaning, should the line go beyond this point and beyond this point? It should be between the points, right? If it goes beyond, are you even calculating anything? I hope you got the concept. Did you get the concept of rotation? How exactly linear regression is able to do that? How are we able to find the best fit line? Exactly. Exactly. Thank you. Are we clear with what exactly is the definition of linear regression? How it is able to do it? It is a very simple machine learning algorithm that's able to do it. And based on that, and based on the best fit line, we will be able to make a prediction in the future because that line has the least amount of error. So if the prediction in the future is that for 4,000 square feet house, it is 2 crore, meaning it actually in reality is 2.2, but R isn't 2 crore nearer to 2.2, meaning with some error, we were able to very closely identify the answer. That is why linear regression is used. Concept of what is R square. Okay, my people, in linear regression, R square represents a very simple information, and that information is R square tells us how well the line predicts or fits the actual point, or how well the line predicts the actual point. This is technically more correct. So R square tells us, okay, R square tells us how well, how WELL, the line predicts, okay, predicts the actual points, POINTS, okay. R square is a way to tell yourself that your model is doing a good job or your model is doing a bad job or your model could do better. Okay. This is a way to quantify it to yourself. Now you can ask me one thing, sir, why don't we have a quantification already with something called residual error? We do. The problem is linear regression has a very big problem, and that problem is outlier. If you have a line of a linear regression where you have one data point here, one data point here, one data point here, one data point here, and one data point here. This is known as the best fit line. Okay, the red color thing is gonna be my best fit line. But by mistake, if your point is somewhere here, right, then your best fit line would go somewhere like this. So tell me, does outliers affect the output of your linear regression model? Does having an outlier create problems? Sir, 100% it will create problems. If you don't know, I'm telling you this right now. So removing outliers from your data should be an essential part of your EDA. Have you all heard of something called EDA? Has anybody heard of the concept called EDA? The full form is called Exploratory Data Analysis. It's called Exploratory, okay, Data Analysis. Are we clear? So now that we have spoken or learned about R square, what exactly is R square? Take a line. Listen to me carefully. Take a linear regression line. Okay. So for example, if this is like the y-axis and this is like the x-axis. Okay. If this is my x-axis and this is my y-axis. And suppose you have data points like 1, 2, 1, 2, 3, 4, 5, right? Like this. One. Suppose if you have a data point like that. R square, most simplest form I'll explain. Okay. It is nothing but the distance between and the distance between. Okay. There are two distances we will calculate. The actual value minus mean value, the estimated value minus mean value. When we did linear regression code, okay, when we wrote this graph in front of you, right? I'm not sure if I can copy this, but I'm gonna try my best. Give me 1 second. Oh yeah, I can. Control X. Yeah. Okay. You see this graph? We did this graph. Whoever does machine learning well, their level will be the best, is what I meant. You know what I think? Listen to me. Listen to me. Okay, listen, because this is a very important concept. Here's what I think. I think all of you need to make a Google sheet. A Google sheet. In that Google sheet, just write down your name and your address. Your name and your address. And what I'm going to do is I'm going to have a deal with Swiggy. And I'm going to be like, look, 7 o'clock I start my class. 6:45 I want you to send tea or coffee based on whatever preference you have to all my students so that they wake up. But before delivering the copy, take a hot water and just like on their faces so that they are up. Yeah. We'll speak about that. I think this is a good startup idea as well. It's a very simple idea. I am teaching you the concept of R square. R square tells you how good your model is or how good the estimation. What do you mean by estimation? Prediction only, right? Estimation is prediction only, right? You have some actual data point. You having actual data point is called ground truth. Remember, in machine learning, this is a very important term. Ground truth. GROUND. TRUTH. Ground truth means your actual data. It is a very important technical term. Just like how in marriage, I am sorry works every time. It's an important keyword. Ground truth is an important keyword. It represents all your actual data point. Okay. So now your ground truths are your actual data points and your line is the estimated data points, basically the one that you have estimated, right? So tell me, do you have something called the Y bar? This thing is called as the Y bar, the mean of the Y, the Y mean, okay? On this particular plane, what two things do you see? One is the Y bar and the other is the actual data point. Correct or not? There are two things on the graph right now. One is the y bar and the actual data point. Can I plot a line, a regression line like this? So now what do you see? You also see the predicted line. Now there are three things on this particular graph. Make sense? Now there are three things in the graph. The distance between actual data point and mean. Listen to me. The distance between actual data point and the mean value. Is this the actual data point? The red dot? The distance between actual data point and mean. So can I say this is the distance between actual data point and mean? This is the actual distance between data point and mean, and rest is on the same tribe. So this distance is what we are calculating first, the actual distance between data point and mean. Yes or no? Good. Then the next difference we calculate is estimated minus mean. Meaning, can I say these is the actual data point, the red one, and the yellow one is the estimated data point. This is the estimated data point. This is the estimated data point. And this is the estimated data point. The next thing you do is you calculate the distance between estimated minus mean, estimated minus mean, estimated minus mean, which is this much. Okay. Estimated minus mean and estimated minus mean. Did you get what I'm trying to say? The distance between actual data point minus mean data point and estimated minus mean. And when you want to do their comparison, this comparison is what we call as R square. Are we clear? It's not a very complicated topic. Everyone got the concept, right? You got the concept very, very well. So tell me, can I expand your knowledge now on how to do this mathematically? Again, I am not showing you how the formula has come up into picture, but like we have to take y-axis mean only because y is enough base for comparison. You got what I'm trying to say? Y is also an axis, which is a mean value. X is also a mean value. Taking from y makes more sense because you are doing y prediction. I hope you got what I'm trying to say. Your equation is y is equal to mx plus c, right? So y becomes a solid base. Okay. R square is the distance between the actual data point minus the mean data point. You compare against the estimated data point minus the mean data point. No confusion here, right? It's a comparison, simple comparison. It does nothing else. I'm going to show you mathematically what it does. Okay, good. I am going to take the X and the Y from the code. Give me 1 second. The X and the Y. Copy. Is this the value of X and Y that we have? Tell me, what will it mean if I do this? Y minus Y bar. What do you mean if I do Y minus Y bar? Is this line actual minus mean? The actual data point minus the mean is going to be called as Y minus Y bar, yes or no? This is simple logic. You guys must have learned that by now. So tell me, what is Y minus Y bar? 2 minus 4. What is 2 minus 4? 4 minus 4. 5 minus 4. 4 minus 4 and 5 minus 4. What is the answer, everybody? What is 2 minus 4 minus 2? What is 4 minus 4? 0. 1. 0. 1. Can I say this is the answer? For actual minus mean, Y minus Y bar? Can I assume my understanding is correct? Because the numbers could be both negative and positive, we don't want that. What do we do with those numbers? Whenever the number starts becoming negative, very good. So do we take Y minus Y bar the whole square? So does it become 4, 0, 1, 0, 1? Now, tell me, if I sum the number up, if I calculate its summation, what will be the answer? If I sum them up, 4, 5, 6, 6. Let's calculate something called y hat. Y hat is nothing but, what was the equation that you got? What was the value of m that you got here? 0.6 and 2.2. 0.6 and 2.2. 0.6 into x. What is the value of x? 1 plus 2.2. Can somebody tell me what is the answer? 0.6 into x is 2 plus 2.2. 0.63 plus 2.2. 0.6 into 4 plus 2.2. 0.6 into 5 plus 2.2. Am I predicting the estimated data point here using the y hat? Yes or no? This would be 2.8. 1.2, 2.2. What? This should be 3.4, right? If I'm not wrong. Right? 4. 4.6. Yeah, that's true. And that would be 5.2, right? 4.6 and 5.2. I'm assuming this is correct because it is at a very standard difference. Is it correct? Is my y hat prediction correct? 2.8, 3.4, 4, 4.6 and 12, 5.2. Correct? Okay, good. Did you all understand what is y hat? Y hat is the estimated data point. Using the equation only we calculated the estimated, right? Using the equation only we will calculate estimated, correct? So tell me, my people, I have actually taken something called actual data point, actual point minus mean I have taken. What am I remaining with? What is remaining? What is missing here? Which point is remaining? Estimated minus mean, correct? See, actual data point minus mean is taken. Estimated minus mean is not taken. What is your estimated value? Y hat. What is the mean value? Y bar. So what is the estimated value, my people? 2.8 minus what is the y bar? Is it 4? What is y bar answer? Negative 1.2. 2.8 minus 4 will be negative 1.2, correct? You know what? You do the hard work. 3.4 minus 4. 4 minus 4. I will write the answer. It is easy. Minus 4 and 5.2 minus 4. Come on, give me the answer for all of these. What should be the answer? Negative 1.2, negative 0.6, 0.6, and 5.2 minus 4 is going to be 1.2 because similar answers. Aren't these answers in plus and minus? Do we like answers in plus and minus? Do we like the answers in plus and minus? No. So what do we do? Y hat minus y bar the whole e square. What is whole e square? Everybody, what is 1.2 the whole square? It becomes 1.44. What is 0.6? 6 twos are. Nah, it's not done like that. It's going to be 0.36. Yes or no? 0. 0.36 and 1.44. Now what do we do? If I sum the number, what answer do I get? What is the answer? If you sum them together, 3 point. Is it correct? Is the summation going to be 3.6, everybody? That's good. That's good. Once you have calculated this, your R square formula is very, very simple. Your R square formula is summation of y hat minus y bar the whole square divided by summation of, what are you comparing it against? Estimated minus mean is compared against actual minus mean. What is the actual minus mean? The actual minus mean the whole square. So tell me, what is the number that we got? Is it 3.6 divided by 6? What is the answer? What is 3.6 divided by 6? What would be the answer? About 0.6. Remember one thing. R square is a number between 0 and 1. What is the number R square? R square is a number between 0 and 1. If your R square is closer to 1, the fit is good. If your R square is closer to 0, the fit is bad. What R square did we get? What R square did we get? Closer to 1. So what does it recommend? Is it recommend or is it recommending something that my fit is good? But R square has a problem. You know what is the problem? I'm going to show you what is the problem. R square formula. You are going to be very much confused when I show this formula, right? Have I taught you the formula like this? Okay. Did I teach you the formula like this? Y minus y hat the whole square, y minus y bar the whole square. Is my formula different from this formula in what way? Copy image and paste it here. Okay. What's the difference in my formula and this formula? Please, somebody tell me fast. Nope. Look at the numerator and look at the denominator. Y minus y hat. And here I have y hat minus y versus y minus y bar. Okay. Actual minus predicted and estimated minus mean. Okay. Two things. I'm also going to show you guys one more formula. Okay. I'm going to show you guys it like this. Okay. Give me 1 second. Copy image and paste it here. Is this visible to all of you? Is this image right there visible in front of you? Listen to me carefully. Do you see this thing called SSRES? SSRES. The full form of this is sum squared residuals. Residuals. And the third is SS tot. Sum squared total error. Okay. TOTAL. Now, I don't want you to get very much confused with this concept that, oh my God, what is this new thing? It's nothing. It's nothing. Literally nothing. Okay. The formula that I gave you. Okay. The formula that I have given you, which is this formula. Here, R square is nothing but sum of squared residuals divided by sum of squared total. Sum of square residual divided by sum of square total. You have to think of it like this. In R square, okay, while calculation of R square can be expanded in multiple different forms, like sum of square residuals by sum of square residuals plus sum of square error. Okay, that becomes sum of square total. When you rearrange the terms, you get an answer like this. 1 minus, okay, summation of y minus y hat, which is the actual minus estimated, actual minus, actual minus predicted, which is y hat, and actual minus mean. When you say you're comparing, you're basically dividing one comparison with another comparison, and you're taking something called as a ratio. Now, I am going to ask you guys a very simple thing. Do you know what is the meaning of the word ratio in mathematics? Let me give you guys a very simple example. Very simple example. Tell me, if you had 4 chocolates and 2 people to share it with, per person will get how many chocolates? 2. Reverse the situation. You have 2 chocolates, but 4 people. How many will each person get? About 0.5. Agree, disagree? Okay. This number represents the power of the method. Meaning, when you divide a larger number by a smaller number, you get a number which is significantly different. When you divide a smaller number by a larger number, you get a significantly different result. What do I mean by that is, does the answer of the division represents the equal parts for that particular division? For 2 people, you get 2 chocolates. For 4 people, you're going to get this chocolate. Division of A divided by B will give you some value called X. B times X is always going to be A, right? X into B will always be A. It will always come back to A. The value X represents equal portions. Equal portions for the value at the top, or equal portions with the value at the bottom, meaning sum of squared total, right? you will get some answer called X, has a relationship with this number. This X number represents the equality among the equation or equality among the among this particular division. Meaning, whenever you take R square and the number is larger to 1 or closer to 1, whenever your R square is closer to 1, what does that represent with numerator and denominator? What should it represent? Under what condition will be the number closer to 1? If the numbers are closer to each other or if the numbers are far away from each other. Meaning, you have a value called A, you have a value called B. Between A and B, if the number of A and B, if they are closer to each other, will that become 1? Or if they are far away from each other, will that number be 1? Please think and answer, okay? Please think and answer. If the numbers are closer to each other, meaning, let's take the example 3.6 divided by 6. 3.6 divided by 6. What is 4 divided by 6? Very much tell me, what is the answer? What is 4 divided by 6? This is not a very hard calculation. What is 4 divided by 6? 2 2s are 4, 2 3s are 6. What is 2 divided by 3? 0.67 approximately. What is 5 divided by 6? What is 5 divided by 6? 0.83. What is 5.5 divided by 6? 0.92. Let me ask you guys a simple question. When your sum of squared residual error, which is sum of square residuals divided by sum of square total, when both the errors are very close to each other, is your R square saying that the model is a good fit? Listen to me. But what does that mean in the graphical format? The closer the lines of estimated n minus mean or actual minus mean are, the better the R square. Meaning, when all the distance between the actual minus mean and estimated mean is as less as possible, the numbers will be closer to each other, and hence the R square will be bigger. You got the concept? If the distance between the actual minus mean and the estimated minus mean is as closer to each other, the numbers will be as closer to each other, and the R square will be equal to or closer to 1. And that will represent a good fit in the model. Did you guys get the logic behind it? You got the concept behind it, right? Why R square is preferred for the choosing or for the recommendation that my model is good or not. Are we clear? Is everyone clear until here? You guys got the concept? Okay. Now listen to me. Do you see this formula? Do you see this formula right in front of you called adjusted R square is equal to 1 minus R square into n minus 1 by n minus p minus 1? You see this formula a lot? Okay. So just listen to me, okay? Just listen to me. If you do anything wrong in your house, do we get punished? I'm not sure if the kids nowadays or the parents nowadays even hit their kids, but yeah, I mean, I was the champion at my time, right? Like anybody used to just, but you do anything wrong, you get punished, right? In machine learning, this technique is called penalization. What do we call this? What do we call this technique as? Penalization. I have a very simple question I want to ask you. This question is going to come in your interview. It's going to be asked in your interview. This is not a 5-star. This is a 100-star question. My people, what is the difference between a machine learning model where you have A, B, C, and D and a target column? How many independent columns exist here? In technical term, they are called as features. Features. So from now on, do not call it independent column, call it feature. How many feature columns are there? 4. How many target column are there? 1. Correct or not? If I want to run machine learning on a model or on a data where the number of features, features, is 100 columns and the target is 1. Do you think that machine learning should have no problem in running 4 feature, 1 target, 100 feature, 1 target? Or do you think the machine learning model will get a problem? My question is, if the number of features increase, listen, this is a very important question I'm asking you. Trust me, this is very important. If the number of features increase in linear regression or any machine learning model, okay, not just linear regression, if the number of features increase, does that cause problem in the machine learning modeling? The answer is yes. The answer is 100% yes. I'll tell you why. Listen to me why. For the prediction of some answer, for the prediction of some target variable, I'll tell you why this is a problem. Listen to me. Listen to me. I'll tell you why this is a problem. Suppose you have a column called age. You have a column called salary. You have a column called blood group. You have a column called civil score. You have a column called DPDs, days past dues. Oh, XYZ, XYZ. And the target column is whether this person should be given loan 0 or should be given loan yes or no. Tell me, for the prediction of the loan, will the age column also will be like a person? Hey, you should consider me also for your prediction. Then there will be one more person called salary. Hey, you have to also consider me for the prediction. Then the background will be like, hey, I am also existent. Sybil say, I am also here. DPD say, I am also here. More the column, won't there be more chaos because so many people are saying prediction should be 0, prediction should be 1, and the machine learning model will be confused. More the columns, more the people are talking. All the columns are saying, you have to listen to me, you have to listen to me, you have to listen to me. Won't the model be confused? Who do I listen to get my prediction? Right? And it is good to be wrong. My people, when I started machine learning, okay, and when I learned machine learning from my instructor used to also ask me questions the way I'm asking you. And I used to also say no, and then I used to say yes. It's okay. It's a fun part of the game. That's the beauty of learning together, right? The point is, the more the columns you have, the higher the chances of something called overfitting. Okay, I have not taught you what is overfitting, underfitting, but more the chances, more the overfitting. So tell me, does it not mean that by default, if a model, a machine learning model with 4 columns exists and a machine learning model of 100 columns exists, because the numbers of columns are higher, R square will always be closer to 1 because the number of columns are so many. So don't we want a true measure of R square? Even if the columns are 2000 tomorrow or 100 or 4, you give me the proper value of R square. Yes or no? You got what I'm trying to say? If the numbers of column increase for a linear regression model, higher the columns, R square will always be pointing to 1. But is the real value of R square 1? No, sir. It's because more the columns, more the representation. So don't we need to adjust our formula in such a way that even if the number of columns are higher, it will give us the right value of R square. That formula is called adjusted R square because the R square formula that I taught you, is it adjusted? No, it is not adjusted. It is not fixed. This is the formula that is fixed. So what is the formula of adjusted R square? Is R square nothing but your sample R square that you normally calculate the way I calculated? Yes. Absolutely correct. But you divide the equation by total sample size. Can you see I'm dividing this by total sample size n? The sample that I have taken for the consideration of R square, that sample. At the same time, can you see number of independent variable here? This is nothing but the number of features. If your data is working with 100 features, am I not dividing and subtracting it with n? So I am penalizing the model saying that if you take more number of features, your division also will be larger. You got what I'm trying to say? If your column is 100, suppose if your feature set is 100, I will divide you by 100. So the number also will be that much smaller. But if your column is 10, I will only divide by 10. So be careful. Don't get overconfident and take too many columns. You got what I'm trying to say? That's the logic behind the R square formula. If the number of features are higher, R square is likely to be near 1. Of course, 100%. If the number of features that you have taken are very, very large, what happens? in your R square, because each individual column will start saying that you have to listen to me, you have to listen to me, you have to listen to me. What happens in that situation? What will happen in that situation? I mean, think about it. More the number of dimension, more the number of models complexity increase. What will happen with that? If the model's complexity increase, what happens to the model? Will it get confused? So closer to one. That is your answer. It'll basically overfit itself. It gets so overconfident on the training data. On test, it basically performs nothing. Is everyone clear until here? This is the formula for adjusted R square, meaning you penalize it more. If you want to take more columns or features, I will divide you by that number of size, and you will be equally reduced in your R square. For more number of data or less number of probability of getting a good fit is high. See, let me answer this in this way. Sometimes when you do machine learning, listen to me, I'm asking you a simple question. Sometimes when you do machine learning, do you want more and more columns, more and more features? That is the requirement of my machine learning modeling, but are anyway trying to get R square closer to higher. How is it a problem? We never try to get the R square closer. And just focus on this part of the piece of code. Just be here, okay? I want to ask you guys a very simple question, okay? What data did we take for our prediction? What answer did we take for our prediction? Or what answers have we take? What data did we take week versus something, right? So what I'm going to do is import pandas as PD. Can I do this? Import numpy as NP. Can I do this? Import matplotlib.pyplot as PLT. Do I say these are the most basic kind of, I don't know, the most basic kind of approaches whenever we are writing any code? Okay. Exactly. That representation of R square is not good, because anyways, more the columns are adding and making the R square closer to 1. That is not a true reading. I'll give you guys a knowledge. Okay. Give me 1 second. So tell me, when you cook tea or when you make tea, you don't cook tea, you make tea. TEAT. For 4 people, the amount of sugar you add is 2 cup or maybe 2 spoons or 3 spoons. Agree, disagree? When you make a tea for 100 people, will the amount or the quantity of sugar that will go will be larger? This behavior is normal and is common in the human system, ecosystem, right? If you are making a tea for 100 people, of course, the sugar is larger. You make a tea for 4 people, the sugar quantity will be lesser. If you reverse this situation, what happens? Disaster. For people, you want to make 4 cups of tea, adding 100 cups of sugar. And for people, 100 cups of tea, you make 2 cups of sugar. Is it disaster? Okay. So according to the size and the quantity of the data, should you adjust the sugar size? Larger the feature set, do I need to penalize it, control it, maintain it, so that the R square value that I get is not a number closer to 1 by default? That is not the true number. That is not the true representation of the number. I hope you got what I'm trying to say. That R square is not the true representation. The actual R square should be adjusted, because automatically when the number of features are larger, it becomes overconfident and says that R square is 1. But in reality, R square is 60, 0.60, 0.70. It shows 0.9. Not good. Penalize. The logic is clear. Why we do this? That's why we do this. Have I taken all the packages? Matplotlib, NumPy, Pandas, and all of that. Weeks underscore data. Tell me, how many cars do I get to sell in a week? 1 week, 2nd week, 3rd week, 4th week, and 5th week. I only took till 5th, right? If I'm not wrong, I only took till 5th week, correct? Right? Okay. Then the sales underscore data. Sales data is, what did we take? I don't even remember the code. What was the sales value? 24545. Okay. 2, 4, 5, 4, and 5. Is this my weeks data and my sales data that I have taken as per what we did in the coding? Very good. So tell me, listen to me carefully. df equals to pd.data frame. If I want to convert all of them in data frame, do I take it in a dictionary format like this? Like take a dictionary like this, a single dictionary? Can I say it like this? Weeks, colon. What do I pass? Weeks data. Bracket, sales. Now listen to me carefully. Everything will start making sense a little bit more to you, okay? In machine learning, whenever you do in the production, whenever you're writing code, how you cut your birthday, right? How you cut your birthday cake. Just like that in machine learning, you need to do two cuts. Okay? Two cuts. C-U-T-S. Sir, what are those cuts? I'll tell you. Imagine this is your data. Okay? This is your column data. Your Excel data, your good looking, beautiful looking Excel data. Okay? The first cut you need to do is separate target and feature separately. Suppose I have a column called feature 1, feature 2, feature 3, feature 4, and target. Where is the first cut you will draw? Okay. Where is the first cut you're going to do? You are going to separate your target and your feature separately. Am I making sense? Your first cut should be to separate your target and your feature separately. Usually in machine learning, target is taken as X and the feature or your actual feature, sorry, your feature is taken as X. Okay. Your feature is taken as a variable called X and your target is taken as Y. Did it become clear? Your features will be separate, your target will become separate. So tell me here, can I take something called X equals to df of, specifically df at weeks? Can I say all the values of the weeks will be converted to X? So if I print X, all the 1, 2, 3, 4, 5 value of the weeks are separated in X. Yes. And your Y value will be, your value of Y will be df of sales dot values. So what did you do? Did you take your X and Y separately? Did you take your X value and your Y value differently, your variable separately? So you have done that. The second cut you're going to make is separate something called as training versus testing. I'll explain the concept. You make a cut like this. Okay. This much data is training data and this much data is testing data. Okay. I'm going to explain this concept a little later to you. I'm going to keep this graph in the next. Did I first make the first cut as per what I had done? X and Y is separate. The first step that we do is calculate the mean of X and mean of Y, correct? In the mathematical example also, I calculated the mean of X separately, then mean of Y. Mean underscore X equals to NP dot mean of, what do I pass? X. Mean of Y is going to be NP dot mean of Y. Did I take the X separately and the Y separately? The mean of X and mean of Y? N is equal to length of X. Basically, I am taking another variable called N where I am understanding how many X parameters do I have, meaning how many independent feature sets number do we have. N will represent that. NUMER, numerator is equal to 0, denom is equal to 0. What have I done here? What have I done here? What is the concept here? Numer is equal to 0, denom is equal to 0. Have I taken something called as a counter? In Python programming, this is also called as a counter. This is counter. I have initialized the number to 0, correct or not? This is a counter that I have taken. Okay. In the mathematical terms of doing the R square calculation, sorry, in the calculation of y is equal to mx plus c calculation, numerator is nothing but x minus x bar into y minus y bar. Agree? X minus x bar into y minus y bar. X minus x bar into y minus y bar. Please tell me, for I in range of n, how many data points am I going through? All the values of x? Am I looping through all the values of x? 1, 2, 3, 4, whatever values of x is, I'm going to calculate its x, x bar, y, y bar. I'm going to calculate all of that. Okay. Can I say numer, N-U-M-E-R, plus equal to, numerator plus equal to, keep on adding that number is x of I, which is the actual value of x minus mean of x. Is this x minus x bar? Is this code, as simply put, nothing but x minus x bar into y minus y bar? So y will be taken like how? Y of I into mean of y. Is this x minus x bar into y minus y bar? I am simply looping through the code. I am simply looping through the code. How many? First, I will take row number 1, then row number 2, then row number 3, then row number 4, then row number 5, then row number 6, then row number 7, and it goes on and on and on. I'm sorry. What? Isn't it minus? What is minus? What did I do? Where did I make mistake? X minus x bar into, oh, sorry, y minus y bar. Yes, sorry. X minus x bar into y minus y bar. Correct. Okay. So x minus x bar, y minus y bar. Numerator is done. What do we need to solve for next? What do we need to solve for next? X minus x bar is done. Denominator plus equal to, what is going to be denominator? Look at the formula. Denominator was x minus x bar the whole square. X minus x bar the whole square. So how do you write x minus x bar? X minus x bar the whole square. Can I say this? This is x minus x bar the whole square. Okay. If I come outside the loop to calculate the value of m, do I need to divide numerator by denominator? Numerator divided by denominator should give me the value of m, correct? M should be equal to numerator divided by denominator. Agree or disagree? Okay, that's good. And what will be the value of c, my people? What will be the value of c? I have written the formula right here. Can you see? Y bar is equal to mx bar plus c. Y bar, sorry, give me 1 second. Y bar is equal to mx bar plus c. So can I say c is nothing but mx bar, sorry, y mx bar plus c. So if I move y bar minus mx bar, can I say it like this? Can I say this is going to be y minus mx bar? So if I write it like this, mean of y minus m, whatever value of m I have calculated from top into mean of x. Can I say it like this? If I print f double quotes of m is this. And the value of c is this. Did I get the value of m and c? Now we make plots. So now I'm going to do some plotting. Why plotting? Because we just calculated y is equal to mx plus c. Yes or no? We have the value of m and c. We just need to put the value of x. So if I say max underscore x equals to, just try to understand the code I'm writing, okay? np.max of x plus 1. Min of x. np.max, np.min of x. Because it is the min value, I'm going to take minus 1. Okay. Who knows what this np.linspace? Have you all used the method called linspace? Have you all heard of something called linspace? Comma max of x, right? You guys have heard about something called this, right? mx plus c, correct. That would be 1, 2, 3, 4, 5, 6, 4 and 4, and then mx plus c, right? That should be fine. That's my equation, correct? From min to max, which is correct. Okay, fine. See, I'm very sure you must have studied something called linspace in you guys did do something called NumPy, right? You guys have studied something called NumPy, correct? I'm assuming that NumPy is done. Okay. Or maybe, I don't know. Let's take a little maroonish color like this. Yeah. Let's come to this part of the code and change this to hashtag this. Color is done. I can change the label also. X and Y in color. Okay. And you guys have studied Matplotlib, correct? So what I'm doing here is I'm writing a label because this is going to be sort of like my regression line. Okay. Regression line that we have just calculated from that particular thing. Okay. Line style will be, I'm going to keep it actually dashed so that you guys understand dash dash. That's more than enough. I will take no alpha if you guys don't want it. Plot dot scatter. Okay. Inside the scatter plot, I want to plot the original values. So I'm going to take x comma y, the one that I had originally. Okay. So the color is equal to, let's take sky blue. Sky blue. And the label I want to add, because I want to add a legend, legend later on. Label is equal to the actual scatter point or the actual data point. You can call whatever you want. POINT, right? Actual data point. And actually, I can make them bigger or smaller. I think I can make them bigger. How do you make the points bigger? Actually, there is something called width. Yeah, I think I have to check it. So plot dot plot is done. Plot dot scatter is done. I have taken two specific plots. Okay, so plot dot x label. So let me first take an x label. On the x label, I will say the number of weeks that have elapsed. Okay, weeks. And plot dot y label will be, the actual sales of the cars that have been done. So I will say sales. And plot dot title. I'm going to take the title of the plot to be, demo of linear regression or whatever it is. Linear regression demo. Okay, demo. And then we are going to do plot dot grid. Let's make it true because we want it to look good. And we will say plot dot legend, and the location will be equal to best, right? So the lock will be equal to best, upper left, upper right, depends on how you do it, right? Okay. Let's not make it sky blue. Let's make it black. Yeah. Okay. Not even black. It's not looking good. How do I make it lighter yet darker? Oh, I think this is darker color. This is like a good looking dark color. So I'm going to take this copy. I'm going to come to this code. We're going to go to hash and paste. Let's make the grid a little less lighter. Alpha 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 equals to, let's make it 0.5. Now let's make it little 0.3. Let's also make it line style is equal to, let's make it dashed, right? Let's make it like this. Please tell me if you're better. Looks good. Now let's make the alpha better, 0.4. Good. Okay. Do you see what has happened here? We have 4 data points. 1, 2, 3, 4, 5. 5 data points. The red color line is what is actually called as the fit line that we have observed. Yes or no? The red color line is the actual y is equal to mx plus c line, and the blue dots are the actual data points. You got what I'm trying to say? Let's make it a little bigger if you want. Please tell me if the code is correct. No. Is it capital S? I'm not sure. S is equal to 40. Oh, I think I'll get an error. Or small s equals to, let's make it 70. Yeah, okay. Now listen to me carefully, okay? What have I done here and how am I basically printing these values, okay? See, predominantly, I want you to understand just one thing, okay? I have taken something called max of x is equal to np dot max plus 1 and minimum of x is np dot min minus 1. Okay. The largest number of the value of x, is it 5? Plus 1 will be how much? And the most minimum number in x is what? 1. Minus 1 is 0. I want to make a plot. I want to make a plot where the x-axis will start at 0 and end at 6. Did you get it? Limitation on the x, the direction of x. Okay. Now what did we do? X equals to np dot linspace min x and max x. Do you know what does linspace method do in NumPy? Everybody? Do you know what linspace does? Everybody? You guys are clear, right? What linspace or this line space does? It's actually spacing. It's for spacing. You guys are aware. So I don't need to teach you this, correct? I don't need to teach this x equals to this, create equal spacing. Very good. I have taken something called y is equal to mx plus c. I plotted x comma y with a different color with a label and a line style. I plotted the scatter plot x and y, the actual data point, color, label. I did the x label, y label, title. I've put the grid in the background. Alpha is the intensity. How do you want the intensity to be darker or lighter? Line style is the style of the line. And then legend is basically regression line and data point. And I plotted this data. Yes or no? Are we visually clear on how this particular thing works? Are we visually clear with the concept of something called how does the whole thing work? It's good. Very, very good. You got what I'm trying to say? You don't know what is grid and legend. Okay, so you don't know what is grid and legend. Do you see the background grid? Okay, let me make it alpha 1. Alpha 1. Alpha equals to 1. Okay. Do you see the grid in the background image? Let me show it to you like this. How about now? Is there any grid in the background? No. Correct. But the minute you say plot.grid and pass inside the parameter called true, it will make the grid for you. If I run this answer, this red color line is what? The blue color points are what? We don't have that information. If I don't have that information, then the plot looks incomplete, right? I want to label it in the plot. So if you do plot.legend and print it, can you see the red color thing is called regression line and the blue color points is called data point. This difference is what we call as legend. How it figured out without giving figure size. Matplotlib has everything by default. If you don't give any figure size, it won't give you error. It will still run. I thought you guys knew this by now. Nobody takes figure size. Nobody in real practical applications takes figure size. Figure size is very illogical and also irrelevant because if you take more than 5 plots, subplots will take care of by itself. What max x and min x does is a very simple thing, right? When you plot any graph, you want to know how long do you want your x axis to go and where do you want to start your x from. You want your starting point for the x axis to start at some value. Now it so happens that not every time the x and y graph will start at 0, 0 only. Sometimes a graph can also start like this, right? A graph can start -3, -2, -1, 0, 1, 2, 3. Sometimes graph can start like this also, right? Not necessary that every time they start from 0 to 0. So what I did is I took the x column, which is this weeks column, and I calculated what is 5 plus 1 because the maximum of weeks is 5. Plus 1 will be 6. So it will plot a graph where the ending point will end at 6. And the starting point will be minimum value, which is np.min. The most minimum value of x is 1. 1 minus 1 is 0. So it will start at 0, go all the way till 6. And then I can plot whatever y value I want. So to restrict the columns, the values on x, I did that. So now tell me, let me ask you guys one more question. Sir, if I do it like this, 100%, let's take -10 plus 10 and run this. What is your axis value? What is your axis value here? minus 15 to 15. You got what I'm trying to say, right? Plus 10 and minus 10 were added to your data. So your actual data point got shifted below. Can you see the points are now closer to each other? Let me copy paste this. Sorry, not copy paste, and move this. And do you see the answer called 2.2734, 2.34, 2.42, 2.49? Okay. Y is equal to mx plus c. You will be like, there are so many values in this, right? There are so many values. Is that the question that you have? That y has so many values? Tell me, okay. Print length of y. Okay. Length of y. Tell me, what is the length of y? 50. Okay. How many data points does y need if I calculate y is equal to mx plus c? In actual y predicted value, what answers am I supposed to get just for the prediction of y hat? Y is equal to mx plus c is supposed to give me 5. Okay. Tell me one thing, right? When you print y is equal to m into x plus c, okay? Did I break my actual x into multiple different data points here? This is not the actual x, the capital X. It is the small x. You didn't understand. Okay. Is this y is equal to m capital X, which is the actual data point plus c, or I had to take linspace because I had to plot the value for line also? You didn't get it. I had to print the value for each individual line, correct? So have I not taken x is equal to np.linspace, and it divides the whole data into 50 different points. And that's how I got a straight line. You got what I'm trying to say, or is there confusion? Did everybody get the concept or no? Okay. How many data points do we have in weeks? Okay, listen. How many data points do I have in week? 5. The name of the variable, is it capital X or small x? Is it capital X or small x? It is capital X, not small x. When I did y is equal to mx plus c, is it small x or capital X? When I wanted to plot the point, I wanted to show the line for the entire data point, right? For all the 0 to 6. For all the values of 0 to small value, I wanted to show. So tell me, if I did x equals to np.linspace, if I print x, how many values of x did I get? Equal portion. 0 to this is one portion. This to this is one portion. This to this is one portion. This to this is one portion. Haven't I divided my value also into multiple small points? Meaning your x-axis also got divided into so many smaller points, equal spaced value. Yes or no? Now, don't I need to do a line equation for all small points? So that is why I have not taken capital X, I have taken small x. That's why the line will go from the 0 all the way till 6. Longer line. Why are we doing it? If you don't do it, will you be able to plot a line? If I don't do it like this, will I be able to plot a graph like this? Like the line going all the way from here to here. That line, that red line going from left to the bottom, will it go? No. Line will start here, it will end here. Correct or not? The regression line will be so small, it won't be visible. That's why we are doing it. If you don't do that, you're pretty much done. You will not be able to plot. Then you will be having only y is equal to mx plus c. That's it. Like you will have 5 different answers. You will get this answer. Y predicted is equal to this, but you will not be able to plot it. This value, y hat. 2.8, 3.4, 4, 4.6, 5.2, and you're done. So what it did is it created some values and then connected the dots to create a line. Yes, that is what it is doing. If I take the values to be more and more, the line will always be visible. The line will not become shorter and longer. It will always be visible. The regression line will always be visible. That's why we did that. I hope you got the concept. In reality, it's only calculating 5. That's it. That's all it does. It's not a very complicated thing. So what if we have only 7 data points and not 50? Still, we will be able to plot. You can do it, Piyush. It's not a very complicated thing. If you want to plot only is equal to y mx plus c, write a loop, write x of I, and you'll be able to calculate it. Shouldn't be a problem. It's not going to be a problem at all for you to calculate it. What value of x's do I have? Do I have the value of x's like this? X is equal to, let me show you. What is the value of x do we have? Is it an array? So if I do x of 0, will it give me the value 1? So tell me, for I in range of, listen to me, for I in range of length of x, will this run the loop 5 times? If I print x of I, will this give me the value of each number 1, 2, 3, 4, 5? Now that you have 1, 2, 3, 4, 5, can I do this? Y is equal to m into x of I plus c. Can I do it like this? And close it and close it. And if I go ahead and print y, each time that the y happens, I print it. So 2.8, 3.4, 4, 4.6, and 5.2. Can you not take this in an array and plot it? You can, na, sir. Of course. It's a simple method. You know how to plot this, right? You guys know how to take two array values and plot them, right? You must have done that like multiple times. If you take another array, ar underscore new is equal to an empty array, and take this ar underscore new dot append. Okay, inside that append, what do? We append the value of y. If I run this, what is my ar underscore new value? Did we get the answer? Take this and plot it. Done. Now, my people, let's talk about the calculation of R square. How did we calculate R square? What did we do in R square? Sum of square total, sum of square residual, all of that stuff. We'll be talking about that. Okay. So, as you guys already know, we calculated something called R square, right? To calculate R square, sum of square total, SS underscore TOT total. Okay. Is it going to be empty? It's going to be 0. Sum of square residual is going to be 0. Okay. I have taken two separate counters, sum of square total, sum of square residual. Listen to me. For I in the range of, how much do I need to run the model? How many times do I need to iterate? N times, because I've already taken the value of n on the top. Y underscore pred. For calculation of R square, I want the value of Y predicted values. Yes or no? For the Y predicted values, I want the values of Y pred. So can I say Y pred is mx? X is nothing but x of I and plus c. Can I say it like this? So sum of square total plus equal to, based on the formula that we wrote, y minus y bar the whole square. Listen to this. Y minus y bar the whole square. The whole equation is reversed. That's why we do 1 minus. I'll show you. Y minus y bar the whole square. So can I say the equation will be written like this? Y of I minus mean y the whole square. Y minus y bar the whole square. This is my sum of square total. My sum of square residuals value plus equal to y minus y pred the whole square. Opposite. Y minus y pred the whole square. So y of each individual point, actually this is capital Y, okay, because we are taking from the actual value. Y minus y of I minus y pred the whole square. I have taken the value of sum of square totals and sum of square residuals. Based on this, my R square answer that I got is 1 minus sum of squared residuals, right? So sum of squared residuals divided by sum of squared total. If I run this and print, go ahead and print, F double quotes, R square is going to be R square. If I run the answer, what answer did we get? What answer did we get? 0.6. What answer did we get here? The only difference in this formula and that formula is sum of square total and residuals are opposite. Agree? They are numerator is denominator, denominator is numerator. So if you do 1 minus the reverse case, is it the same thing? In mathematics, when you want to reverse A by B with B by A, you just take 1 minus of sum of square total by sum of square residual, and your answer is pretty much the same. I hope you got what I'm trying to say, everybody. So tell me, did we use any library in this? But we got the value of R square and Y is equal to mx plus c. Can we validate? Do you understand what is validate? If I would have used a machine learning library like sklearn, scipy, what answers are they saying and what answers do we get? Can we validate it? from sklearn dot linear model, I'm importing something from sklearn dot linear model. I will import something called linear regression. Can you see I'm importing something called linear regression? I'm importing a model called linear regression. I've imported x equals to, now remember, the problem is when you use a library like linear regression, sklearn, stuff like that, it needs the data to be in two-dimensional format. So your x value should be reshaped. I'm going to reshape the value to -1 or n comma 1. So if can I take it like this, n comma 1? What does this do? Do you guys know what reshape does? N comma 1. The value that we had, was it not a single array like this? The x value was a single array. If I print x here, is it not a single array, one-dimensional array, one bracket open, one bracket close? But in sklearn, you cannot run like that. You need to have the data, even if it's 1D array, it should be in what format? It should always be in what format? 2D format. So this reshaping, I converted the entire form into a 2D array. Are we clear? We converted the whole thing into a 2D format. Now that the whole thing is converted into 2D format, let's take this as a small x, not a capital X, because there will be a lot of confusion. So let's run. Okay, x value should be equal to this. The problem is what you need to do. You need to call the library. Regression is equal to linear regression. Close the bracket. Regression is equal to regression dot fit. And inside the fit, you will pass something called the actual value of x and the actual value of y. Did I make a mistake? I did make a mistake. I think there is a shape. Oh, I took it as a small x, correct? I did take it as a small x. Yeah. What did I do here? This 2 lines of code has run the model. The model has run, meaning linear regression has occurred. You don't need to do anything else now. Your value of y_pred, y underscore pred value, the predicted value that I want to calculate is going to be m into x plus c. If I do, you know what, let's take it in x format only because I'm taking it separately. So there is no confusion here. Okay. Mx plus c. My people, if I calculate the y_pred's value like this, mx plus c, right? And if I run that value directly, suppose if I want to just run the value of y_pred straight up, because I'm using the package directly, if I have reshaped the value, or maybe, you know, maybe I'll do it like this. Until here, is everyone clear? Let me run this once again. Until here, is everyone clear? I have run the linear regression part. This part is called linear regression. I have just used the method. Why do we need to reshape y? We never reshaped y. We only reshaped x. We only reshaped x. We never reshaped y. Where in this code do you see reshape y? Where in this piece of code have we reshaped y? Why not? Okay. When we run machine learning or when we run machine learning code, y is only for prediction, right? But the actual mathematics is happening with the feature numbers, right? Y is not even getting involved there. Does that make sense? Your x value, which is the feature value, your x is being crunched. Your mathematics is only operating on x. Y is just a number that can be compared. Suppose if the y value was 4, y_pred is 3, the maximum you do is y minus y_pred. Agree, disagree? The entire operation is running y is equal to mx plus c. The x is being multiplied with m and then added with c. All this operation happens on the x value, correct? So the reshape has to happen only on x, never on y. All of you got the question that features are the one that goes through a lot of mathematics. Target just sits. It has no operation. The maximum it will do is y minus y_pred. Done. Everyone got what I'm trying to say? What did I do here? I took a value, I reshaped x, and I'm running linear regression. Basically, this value here is running linear regression. Agree, disagree? This particular value is running your linear regression. That's it. You've run. Now, if I say y_pred value, whatever is your y_pred value that you want to score or you want to calculate. So if I want to calculate the value of, say, r square, you want to calculate the value of r square. If I say r square is equal to just R square is equal to reg, because I have taken everything in the small reg. Reg dot score, SCORE, pass X comma Y directly. And if I print R square like this, what answer did we get? What answer did we get? 0.59999. Is it 0.6? What answer did we get for R square? We got an error of 0 point or 10 to the power of minus 12 with least significant digit of 10 to the power of minus 12. Did you understand? I ran a model, a linear regression model. By the way, this is not modeling. Modeling, I will teach you how to do that. But when I ran the algorithm, the actual library versus our code, we got the same exact answer. You got the concept, my people, on how we wrote linear regression from scratch, how we implemented it from library, the numbers match. If R square is matching, M and C also is the same answer. The point and the plot is also the same answer. Everything that we've done is calculated. Did we get the concept clear? Now, in the formula of R square, did I not take the value here, the formula? Y hat minus Y pred the whole square. This formula, I have taught you this formula. This formula is already given. All I did, sum of squared total was Y minus Y bar, the whole square. And Y minus Y pred the whole square. We had taken opposite, but in actual R square formula, we take 1 minus of this value. When we take it like this, whatever formula we get on, whatever answer we got then, we got the same answer here. Validate part is confusing. It will be confusing. Have you ever used a method called linear regression or linear model ever? No. This is not for your understanding. This is only to show you that the answers are same. Even if you don't understand the code, it's okay. This is to show you the difference. Linear regression formula, library, and our way of written, we got the same answer. Is going to be a very simple thing, right? I'm going to be importing something called import pandas as PD. Now, I'm going to ask you all a very simple question. This is not the first or a very new library for you, right? I'm very sure you must have implemented this library and you have learned this library, so I don't have to teach you. Okay. Hiding internal implementation and use of existing libraries as and when needed instead of rewriting the code. Yes, absolutely correct. The abstraction in object-oriented programming is different from the abstraction that I am talking about, but you got the logic correct, right? So encapsulation, polymorphism, injection of control, dependency injection, adaptee, adapter. These are all object-oriented principles. SRP, single responsibility principles. These are all object-oriented principles. They are very technical in nature. What I'm talking about is the basic concept of abstraction, but I'm very glad that you got it. Knowing object-oriented skills, programming skills is very important, right? So now what we've done, we've imported pandas as PD. I want to load a data, right? So I'm gonna keep this thing as import all other OTHER libraries here. Okay, import all other libraries here. Here, I'm gonna load the data set. I'm gonna load the data set. Okay, let's load the data set. Data is equal to PD dot. Now, I already have an API or a method which is given to me, using which I can load the data set, right? So pd.read CSV. And my people, I'm going to give you guys certain tricks. I'm not sure if you know them or not, but I'm going to do it. See, in Pandas, you have a trick of loading the file directly, right? So if I want to load it directly, I have this. See, now my data is loaded. Okay. So I have loaded pandas and I have loaded the data set. Now, let me tell you the trick I use to load a certain file faster. Okay. Every computer has a structure called folder. Yes or no? You create your own folder. You can create your own folder. Inside that folder, listen to me carefully. Inside that folder, how many files are there? To find that out, you can use a trick called dot and forward slash. a dot and a forward slash. When you use dot and a forward slash and press on tab, you can see all the files. So you see this headbrain.csv. Now I have loaded this file. So basically, a method called dot read CSV reads the file called CSV. Now, what is CSV? It's comma separated value. Now, let me tell you two different things. You guys are currently learning machine learning on a tool called Jupyter Notebook. Like Jupyter Notebook, there is something called Google Colab. Like Google Colab, there is another tool called Visual Studio Code. These are platforms on which you can write the program. This CSV is the format of the file on which you work. Sometimes you work with Excel format. So the extension will be .xlxs. If you work on something called Apache Parquet, so you will have Apache Parquet, Apache Parquet, right? If you work on Hadoop distributed file systems, then you will have a different kind of data set that's given to you. If you work on Carrot file, it'll be different for you. Remember, in machine learning, you can use as many different kind of structures as you want. Depends on what is the file structure that you have, okay? It is so if the same folder available to, no. Dot slash only gets you the file from the same folder on which your file ml_ff is written. Your folder needs to be same. If the folder is not same, it's not going to go beyond that to get it for you. Okay. What is the difference between Jupyter Colab and Visual Studio? See, Visual Studio is something that you will appreciate a lot. Like if I show you a Visual Studio code, I'm not sure if I have it with me. I mean, not here, Visual Studio code. Okay, I'm going to show you the difference between Colab and Visual Studio Code. Actually, you should really know the difference between Visual Studio Code and this. So you see, right now, this is inferential stats that I was teaching a while ago. This is extension. Give me 1 second. Let me go ahead, and I think I had a folder somewhere. I'm going to open it up for you guys. Give me 1 second. Desktop. And I have A to Z. I think I was teaching. Yeah. Let me see if this is the, yeah. So this is like a small data structures code that I was teaching to a recent batch right now. So see, this is written in an IPYNB file. This is how Visual Studio is going to look like for you. So you see, it has a certain theme. So I'm just going to expand it a little bit, right? So I'm going to, show it to you. So what happens is basically, if you run a portion of this, so for example, how do you find the second largest and the second smallest thing from an array? So you have a certain way of doing this. So what happens in Visual Studio Code is, Visual Studio Code can help you write any kind of program with a proper and a beautiful file structure. So you can maintain and work on the database together, files together, multiple different stuff like Docker, Kubernetes. If you want to build a Docker container for your, code, if you want to do a blue-green deployment, so you can do all of that in one place. Jupyter Notebook is more like for beginners. If you're a beginner, you're just starting with your machine learning journey or starting with your programming journey, people usually prefer Jupyter Notebook. But Jupyter Notebooks are not predominantly used for deployment, meaning you don't take a Jupyter Notebook file and you're going to be use it for deployment. Some people do that using Amazon Web Services and Kubernetes services, but usually it's not preferred because you have to do load testing, stress testing, pen testing. It's like regression testing. That's like crazy amount of stuff you have to do. Okay. For VS Code, we need to create environment for Jupyter, or you can use it directly. It's directly. All you need to do is just download Darwin. So VS Code Darwin, if you just just download Darwin, you should be able to work on it, or just write Visual Studio Code, right? Like VS Code, depending on your computer, MacBook, or whatever it is, download. That's it. Just download, install the kernel, you're done. Okay. Colab is just like that. Colab is exactly like Jupyter Notebook, but it works on cloud. So if I go to Colab for you guys and show you just one example, I have a pro version. So I'm going to show it to you differently. So see, this is the code of large language model like GPT. If you want to make your own GPT, this is a code for that. I'm using something called Microsoft 5 3.5. So see, for example, if I want to chat with my model, so if I ask a question like, like, hey, can I extract some image information from from a given image or something like that? So see, I use something called as Google Colab Pro. The difference in Pro is I get an opportunity of connecting with something called A100. A100 is a very expensive GPU. So you will not have this option. I have this option. You will only have CPU or GPU or TPU. In Google Colab, what happens? You are able to load your data in a separate file called file structure to the left. So you have files here, so you can load your data there. That's the only difference. It's just like Jupyter Notebook, but the way it is done is slightly different. Okay. So Jupyter Notebook is same, Google Colab is same, and all of that is same. It's just that you can use a lot of, you can do a lot of fancy stuff with Google Colab. GPU for image processing. GPU for large language models, for inferencing. When you write a query to a GPT model, you need the answer to be as fast as possible. For that, we use GPU. Okay. So now coming back to the point, right? I have loaded the data set. I want to test my data set. How do I do that? Data.head of 5. And if I run this, what data do I have right in front of you, my people? Let's look at it. I have 4 columns. Those 4 columns are, I have gender, I have age, I have head size, and the size of the brain in weight. Okay. So this data set that is available right in front of you, you guys are able to see the, okay, how about now? Is this more clear? Much better? I've zoomed in for a better clarity. Okay, good. So the data set that I have right in front of you is a very simple data set. It has 4 different columns: gender, age, head size, and brain weight. Basically, I want to predict using linear regression that does increase in the size of the head increase the weight of the brain? Basically, if the size of the head is larger, does it mean that there exists a relationship between the weight of the brain? Meaning, larger the head, larger the brain, smaller the head, smaller the brain. To us, it looks like, I think it's common sense, but I don't know. There must exist a relationship, and we will calculate that using linear regression. So in order for me to implement it using linear regression, I need to identify one thing, understand one thing. Okay. And I want to teach you this very, very clearly. Okay. So see, I have taken this example right in front of you: gender, age, rank, whatever, XYZ, right? I'm going to come over here and I'm going to paste it in front of you. Okay. So give me 1 second. Cut. And I think, why don't I paste it in a view sheet? Okay. Are you guys able to see this original data set right in front of you? Okay. This data set is what I would like to call the OG, the original data set. Okay. Now I will tell you how important is data scientist's job. My people, look at the data and observe carefully. How many variables or columns are categorical variables and how many variables are continuous variables? How many variables are continuous variables and how many are categorical? First of all, let me ask you all one question. See, my people, in statistics, you guys must have learned something called continuous variable, categorical variable, ordinal variable, nominal variable. I'm going to revise that concept to you, okay? See, whenever a number is continuous in nature, for example, temperature, can temperature be 47 degree, 37.19 degree, 97.26 degree, meaning it can belong to any range of negative infinity to positive infinity. A number that exists continuously and can be any number between negative infinity to positive infinity. This kind of variable is called continuous variable. What do we call this? What kind of variable do we call this? This variable is called continuous variable. Let me show you an example. Between age, gender, head size, and brain weight, which number is any number that is continuously going on. Isn't head size and brain weight continuous? I'm asking everybody, whoever I taught you, both head size and brain weight are numbers between 4512, 3738, 4261, 3777, 4177, 1530, and all of that, and all of that, and all of that. Listen to me carefully. Data of just gender. If I just take gender, dot value counts, okay? Dot value counts, and run this. The gender column has only two kind of people. If you are one, it means you are a male. If you are two, means you are a female. So tell me, in the column of gender and age, let me also take age very, very quickly. Paste, remove gender and say age. And this, do I also have the same category like 2 and 1? It's like category, either this or that. Is it continuous by any chance? Everybody, whoever did not know the difference between categorical variables and continuous variables. So head size and brain weight are continuous variables. You will find numbers which can belong from negative infinity to positive infinity. But when you go to columns like gender and age, do we have infinite amount of genders available in this planet? No. So this value becomes categorical variable. What variable will it become? Categorical variable. So now that you have the clarity, this variable and this variable, gender and age, is it categorical? And head size and brain weight, is it continuous variable? And the answer and the distinction is clear. Am I making sense to everybody? What is the difference between a continuous variable and a categorical variable? Did you guys get the clear, your differences clear, everybody? In the most simplistic sense, I hope everyone is clear. Is there yet anybody again who has confusion? I don't believe there should be, but I am asking. No. Okay. The answer is clear. Okay. For implementation of linear regression, we have no use of gender and we have no use of age rank or range. We don't need them. It's not needed for my analysis. They are not helpful in any perspective. So I need to remove them from my original data. Now, here is what I want you to know and listen to me carefully. Sir, does that mean whenever I implement linear regression, I should never take categorical variables? I should only take continuous variable? The answer is no. If you want to implement linear regression, listen to me carefully. I'm telling you, this is very important. If you want to implement linear regression, your target variable should be continuous in nature. What should be, what variable it should be? Your target variable, whatever you're trying to predict should be continuous. Your features could be a combination of continuous, categorical. That's okay. Did that make sense? Whenever you want to implement linear regression, the rule is, the law is, the target variable that you will take will follow what variable? Should be of what kind? It should be a continuous variable. You cannot take a target variable where the data is categorical. This is not allowed for linear regression. Very good question. See, this is what I want to know. But gender and age might also have an impact on the head size and weight. It does. But the problem is, in machine learning, can I say that your gender, age, and head size is going to be my feature data set and the brain is my target? Can I split my data set like this? Can I do this? Okay. Meaning, using head size, I can predict the brain weight. Okay. Given the size of the head, I can predict the size of the brain. Okay. In machine learning, you can do something called feature engineering. What do you mean by feature engineering? Is gender important for my calculation of brain weight? Is age important for the calculation of brain weight? Or head size is important for the calculation of brain weight? And then the machine learning will only tell you, don't give me gender, don't give me age. they are not adding any value. Just give me head size. And when I did that and when I ran that, it says only head size has more correlation with the prediction of brain weight versus gender. Now, why am I not showing you feature engineering? Because that code is very, very large and you haven't yet come to the concept of feature engineering. So now did everybody understand why am I asking you to drop gender and age? Because these are not adding any value to the final prediction. Hence, we are going to be dropping these columns. But I will be teaching you how to do this calculation all by yourself. How to take a feature set of multiple different columns and identify which columns are important and which are not. In specifically linear regression, what variable cannot exist for target? Tell me, if you are implementing something called linear regression, your target variable should be not of this type. What is that not? Categorical. What it should be? What it should be? It should be continuous. Number one. So tell me, what do we do? What do we do here? First of all, I took something called gender. I took something called age. I got something called head size. I will be only using the data set from the original data set. What I'll do, I will take my original data set, okay, which is this, and I am going to, I'm gonna duplicate, okay, come to the bottom. And what I'm going to do is I am going to remove these two columns, age and gender. And now I will be left with this two columns. So originally, what did I do? I had this data, but what did I do in between? I dropped DROPPED, dropped some columns, and I got the answer called, I got the data set as head size and brain weight. Agree, disagree? This is my original data. Now, this was my original data, but this is my data now because I no longer have needs of these two columns. Taught you the concept of something called as in machine learning. Okay, just listen to me carefully and everything will make sense. Just like how we humans need to be shown some things for us to understand, machine learning also requires training. When I say training, it needs to go through something multiple times for it to get the idea. So tell me, my question is very simple to you. If I teach you 4 plus 5 is equal to, that's correct. 3 plus 2 is, reinforcement is different, Kalpesh, right? Reinforcement will be a different thing. But yeah, reinforcement also is like you have to train the model and get the idea. It's absolutely correct, right? So it's also going to be, same. You will get the concept. Okay. So imagine you have been taught how to do addition. 4 plus 5 equals to 9, 3 plus 2 equals to 5, 1 plus 2 equals to 3, and 2 plus 2 equals to 4. I taught you this. I taught you mathematics, okay, addition, where 4 plus 5 is 9, 3 plus 2 is 5, 1 plus 2 is 3, and 2 plus 2 is 4. I taught you this. If I now want to test, have you learned mathematics or not? Or have you learned how to do addition or not? What two numbers will I take? You didn't understand. Let me explain. I taught you how to add two numbers, 4 plus 5, 3 plus 2, 1 plus 2, and 2 plus 2. I taught you how to add using these numbers. Okay, good. If I want to test your mathematics skills, should the numbers be different from what I taught you? Because if I give you the same number 4 plus 5, 3 plus 2, 1 plus 2, you can also cheat. Right? You can also memorize. My question was very simple. I said that when I taught you mathematics, I taught you using four numbers, 4 plus 5, 3 plus 2, 1 plus 2, and 2 plus 2. If I give you a number called 2 plus 2, wouldn't that be cheating? Because you can always memorize what was 2 plus 2, 4 and write it down here, but you did not really understood math, correct? You can cheat like this. So what if I, for testing, give a number like this, 3 plus 6 equals to whatever this answer is, right? I think it'll be 9. Yeah. You understood what I'm trying to say? And then if you're able to answer 9, then I know you have learned math, correct or not? Agree or disagree? Machine learning works exactly like this. I'll tell you why. Imagine you have an entire data set of all these numbers. 4 plus 5 equals to 9, right? 3 plus 2 is 5. 1 plus 2 equals to 3. 2 plus 2 equals to 4. And 3 plus 6 equal to 9. This is my entire data set. Okay? This is my entire data set. To train my machine learning how to do addition, what will I do? I will divide my data set like this. All this from the top will be used for training my machine learning model, but I will keep this number separate. Why will I keep this number separate? Because I want to test my model also. Hey, model, did you learn mathematics? The model will say, yes, sir, I learned mathematics. Okay, let me give you a question. But the question I'm going to give you, you have never seen it in the training. This question is unique, one of a kind. You have not seen it. But because you say you have learned everything from the training, you should be able to solve the problem. Is this logical? Is this a logical approach to test whether something who says that I have learned, to test whether this person has already learned or not, actually learned or not? If I want to test your mathematics skills, if I want to test your mathematics skills, should the numbers be different from what I taught you? Because if I give you the same number 4 plus 5, 3 plus 2, 1 plus 2, you can also cheat. You can also cheat, right? You can also memorize. My question was very simple. I said that when I taught you mathematics, I taught you using 4 numbers: 4 plus 5, 3 plus 2, 1 plus 2, and 2 plus 2. If I give you a number called 2 plus 2, wouldn't that be cheating? Because you can always memorize what was 2 plus 2, 4, and write it down here, but you did not really understood math, correct? You can cheat like this. So what if I, for testing, give a number like this? 3 plus 6 equals to whatever this answer is, right? I think it'll be 9. Yeah. You understood what I'm trying to say? And then if you're able to answer 9, then I know you have learned math, correct or not? Agree or disagree? Machine learning works exactly like this. I'll tell you why. Imagine you have an entire data set of all these numbers. 4 plus 5 equals to 9, right? 3 plus 2 is 5. 1 plus 2 equals to 3. 2 plus 2 equals to 4. And 3 plus 6 equal to 9. This is my entire data set. Okay? This is my entire data set. To train my machine learning how to do addition, what will I do? I will divide my data set like this. All this from the top will be used for training my machine learning model, but I will keep this number separate. Why will I keep this number separate? Because I want to test my model also. Hey, model, did you learn mathematics? The model will say, yes, sir, I learned mathematics. Okay, let me give you a question. But the question I'm going to give you, you have never seen it in the training. This question is unique, one of a kind. You have not seen it. But because you say you have learned everything from the training, you should be able to solve the problem. Is this logical? Is this a logical approach to test whether something who says that I have learned, to test whether this person has already learned or not, actually learned or not? Okay. Do we need to clean data by removing any duplicates? We don't want to do that yet. The point I'm saying is, you will take your entire data set and divide the data set into 2 different portions. One data set is going to be called as training data set, and the other data set is called as the testing data set. Is this concept clear to everybody? Now listen to me. From the original data set of 100% data set, can you control how much percentage I want to use for training and how many percentage I want to use for testing? I can control that ratio also, meaning from 100% of the data set, can I use 80% of the data for training and 20% for testing? Should you have this control? Yes or no? Very good. Very good. Now listen to me carefully. Everything will make sense. This is my original data set, correct? Head size, brain weight, and all of that stuff. Yes or no? you should always do how many cuts in a data set? How many cuts will you do in the data set? 2 cuts. The first cut will separate the feature from the target. So can I say that head size is the feature X and brain weights is the feature or target Y? Sorry, feature X and target Y. Can I say this? So the first cut I'm going to do is where the first cut I'm going to do is on my original data set, which is this data set. So how do we cut it? Duplicate it. Give me 1 second, my people. You know, I am not very fast. Give me 1 second. So what I'm going to do is I'm going to make a cut. How do I make a cut? Actually, let's copy and let's make a copy of it somewhere here safer later on. Okay. So what will I do here? I will make a cut here. Basically, this is going to be my feature. I'm going to say, okay, my feature set is separate. And now I am taking another cut, which is going to be called as crop, which is going to be my target variable separately. So what did I do? I separated my feature and I separated my target. I did this. I separated them together. The entire feature set has the name of the variable as x equal to. So this is x equal to this and this is y equal to this. Agree, disagree? This is called as the first cut, separating the feature from target. The second cut you need to do is in the X and in the Y. You know why? Because between this data, you need to decide how much percent you want to take for training and how many percentage you want to take for testing. So can I do this? Listen to me. Okay, so let me explain. First of all, the data set that we have loaded has how many data do we have in it? 234. Okay, this is only 5. For example, it has about 200 data set. So tell me, the first cut I made was this cut, separating the X and the Y. And the second cut I made was separating this. You know why did I do the separate cut? Because this entire data set is going to be used for training and this entire data set will be used for testing. Did you understand what I did? I first separated the X and Y and then I separated the X separately and Y separately and I call them training and testing. Okay. For example, I have taken about 80% for training and 20% for testing. Agree, disagree? My people, this variable here, this variable, does it belong to X or does it belong to Y? Does this belong to X or does this belong to Y? This belongs to X. Underscore. Does this belong to training or does it belong to testing? So this variable is going to be passed in machine learning model as which variable? X train. This part of the data 4512, 3718 and 426 will be going to the machine learning model as X train. Now tell me, is this Y or X? Is this Y or X? Y. Y. Underscore. Is it training or testing? Training. So this will become my Y train. What is this? This is X. Is this training or testing? This is testing. So this is X test. What is this? This is Y. This is Y test. Did you understand? What did you do? You divided your data into 4 separate parts. X train, X test, Y train, Y test. Is everybody clear? We will be doing this in the example. But is the concept clear? Why do we do this? Is everybody following with me? You need to do this. You cannot escape this in your life of deep learning, generative AI, machine learning, statistics. You have to do this. So did you just divide your data set into 4 parts? Training, X training value is different. Y training value is different. X test value is different. Y test value is different. Agree? Once you divide all this data like this, how do you know your model has performed good or not? So I am asking you a simple question. This part of the data will be used for training. Agree, disagree? This training part of the data, both X and Y will be used for the training. Agree, disagree? The one that I have highlighted, both X and Y will be used for training. whatever model has learned, machine learning model has learned, should I not create another folder or another column called y underscore predicted column? Meaning, using the training example, if I give it the test example 37774177, it will predict some number like 12001500. This is the actual value 1282 and 1590. This is the actual value and this is the predicted value, yes or no. And comparing the difference between these two columns, I will be able to say that, oh, okay, I am off by 2%, 3%. This is your entire machine learning. Is this concept clear to everybody? If the concept is clear, remember one thing. I am coming over to my data set right now. Is this my original data set with which I'm working on? This data set called data.head of say 10. This is the data that I have. My people, your machine learning model has done a good job or bad job. How do we know this? How do we know if the machine learning model has done a good job or bad job? By seeing the results, correct? But to see the result, you need to be able to compare it with something, right? Let me give you guys an example. When we were young, our parents used to tell us how good the neighbor's son is, because neighbor's son got 90% and you got 80%. Example, I'm giving you an example. They had a comparison to do it with, right? Like you had somebody to compare it against. If you have nobody to compare against, can you do comparison? And by the way, I am Sharma. So, you know, Sharma ji ka ladka. So you get the concept. You have something to compare it against. So tell me, in the entire data set, how many data set did we take for testing? How many data set are we taken or have we taken for testing? 2 points. 80% is training, 20% is testing. Agree? 80% of my data will go into learning the module, meaning for training the machine learning model. For training the machine learning model. The machine learning model will learn from the training data. But now I want to test my module. I want to test my module. Okay. I want to test my answer. To test my answer, don't I need to give it the value of X for it to give me the prediction of Y? If I give it the value of X, it will give it, the machine learning model will give me some prediction. Oh, I think it will be this much. Correct or not? If I give the value of X test, it will give me some Y value, no? That Y value is called Y predicted value because this prediction is actually from the machine learning model. But the prediction is 1200 grams, 1500 grams. This is the prediction of the model. But don't we have the real value, the actual value that the model, the actual value in the data set, which is the Y test value? So won't you compare Y test with Y pred? You are comparing the Y test value with the Y pred value to compare and see, oh, okay. My algorithm is off by 80 points in this data point and 30 points in this data point. This will let us know how the algorithm is performing. Did you get it now? How you got Y test value? It's good, dear. Y test value comes from the original data, my dear. This is my original data set. I split the data into 4 different parts. So can you see what I did? The Y test value came from this part. I took the value of Y, I took the value of X, I split Y into 4 parts. Part 1, part 2, part 3, part 4. The 4th part is the Y test value. We need Y. Why do we need Y predicted value is, for example, Anaga, you work in a very big bank. Example, bank, PDFC bank. You want to build an algorithm by yourself there so that any customer can come to your bank's website and can ask and add the details like what is that person's age, what is that person's salary, what is that person's CIBIL, and you will give the prediction. Your machine learning model will give the prediction that, hey, come over to the bank, we'll give you up to 5 lakh rupee loan. Example. To build this model, you must have used 10,000 data points to train the model. Model needs to do prediction for millions of customers. For the future use of Also, from the same data set, the model, how well did it learn? How good of a job did it perform? To test that also, you need to hide some questions from the model. That data set is called testing data. Because we already know in real life, in actual life, for somebody whose brain size or head size is 3,700 centimeters square, the actual answer that we got using the using the calculation, actual answer was 1,282. But because our model has made prediction, our model will make prediction, the model's prediction is this and the actual answer is this. So can we also not compare and see how good our model has performed on the data set itself? My question is, we don't have actual y-test data in real time. We always have y-test value. I think you guys are slightly off by some points. Let me explain. Let me get the clarity. When you're training your machine learning model on 10,000 data points, you can only test on those data, correct? Okay, let me explain. Suppose you have 10,000 data set. Your data size is 10,000. How much is it? Ignore everything. I want you to answer my question. I have 10,000 data points, Baba. कितने data points है मेरे पास? 10,000. What is 80% of 10,000? What is 80% of 10,000? Is it 8,000? And what is 20% of 10,000? 2,000? Now tell me, is my model good or bad? I can only test on the 2,000 data points and validate, correct? Yes or no? If I make future predictions, my future predictions, I don't care if I have the y-test value for that or no. I am testing for the given 10,000 data point. How did it perform on the two? That's it. My accuracy, my model's performance will be judged only on the 2,000. On the 2,000, if it did a good job, I will use it for feature prediction because I know it's going to perform well. Did you understand why do we take test data? Test data is only to test. If it performs good in test, the point is it will perform good everywhere else also. You got it? Everybody? If the model performed good on the 2000 testing data, meaning while I tested from the 2000, it answered 93% correct. So isn't the chances if I use it for future 93% it will do good? That's the point. So is it the test data the basis of YPRED? Yes, of course. If you give it the X test value, it will perform Y test. That's it. If prediction is not accurate, do we not give it more data to train? Yes, if that's exactly the point. If the testing is not good, we try to feed more data or we change the algorithm. You got it? If the answer that you want is not arriving well, then you either change the algorithm or add more data. Are we clear now? This graph is clear to everybody. Have any confusions? You please let me know now. Is it clear? Okay, now listen to me carefully. This is my data.head. How we arrived at YPRED. Yeah, I'll show you how YPRED is calculated. I will show you how YPRED is actually calculated. I'll show you how YPRED is calculated. Is that cool? In the practical part, so that your knowledge will be clear. Is this my data that I want to run machine learning on? Okay. I want to take a variable called x equals to data of which variable do I want my x to be in? I want the head size to be my x variable. Agree, disagree? I have already taught you this. I want my x to be the head. I want my y variable to be what? Or let me take it one point at a time. Values, okay? Dot values. If I run this and if I print x, have I taken x separately? All the values 4512, 3738, 3261, whatever all the values of x is now separate. Now it is in the format of an array, a single array. It is become an array. Agree? Okay. What do I do next? I take another variable called y. Okay. I take another variable called y. Which portion of the y do I need to pass? Do I need to pass data of something called as, what do I specifically pass inside the y? I pass brain weights. I copy this and I paste it here. dot values. So what kind of answer did I get? I got all the values of y as an array. Agree or disagree? So have I separated the x and the y now? Have I separated all the values of x and y now? I did. Now, to implement linear regression, I need to import some libraries. These libraries are already given to us from sklearn dot linear model. Using sklearn.linear model API, I'm importing something called linear regression. Did I import linear regression also? This function will help me run linear regression. I don't care how it is written. I just need to call it. Agree, disagree? Yes or no? From sklearn.model selection, import train test split. Have I done this? From sklearn.model selection, I'm importing something called train test split. From sklearn.metrics, import mean square error. Okay. Import mean squared error. And I'm also going to import R square error. All right. R2 score. So tell me, what did I do? Did I import the libraries? I'm not even using them. I have just called them. I have just called them. I am making them sit on the chair. I have not asked them to do anything. Agree, disagree? So far, I have only called them. I have not done anything with them. Okay. Because I have taken the x value separately and I have taken the y value separately, the x value currently is in what dimension? Is it in one-dimensional data or two-dimensional data? One. That for sklearn, your data should be what dimensional data? 2. So can I say x equals to x dot reshape? Inside the reshape, if I pass this comma this, and if I print x again, did it become 2D? If I print x dot ndim, the answer is 2. The number of dimensions have become 2. From one dimension, I converted that into 2 dimension. Remember, you don't need to do this with y, only x, because x is the data that is being crunched by the model. Y is only for comparison. Only x needs to go through this process. Are we clear? Yes or no? Until here, is everybody clear? Oh, you don't know how reshape works? Okay. Have you ever done something called reshaping in NumPy? Have you ever performed something called reshape in NumPy? Okay. Okay. Sure. Okay. Okay. Listen. Array is equal to, listen to me. Listen to me carefully. Array is equal to np.array and pass any number inside it. 1, 2, 3, 4, 5, 6, 7, 8, 9, whatever it is. 1, 2, 3, 4, 5, 6. There is a name of a method called array.reshape. So if you change that like okay. Did you understand this is how you declare an array in NumPy? This is how a NumPy is declared. Array is equal to np.array 1, 2, 3, 4, 5. This is an array. Okay. What is the dimension of the array? Is it a 1D array or a 2D array? Is it a 1D array or a 2D array? Okay. The shape of the array is 1D. Agree? If I want to reshape this, reshape bit array is equal to reshape RESHAPED underscore array is equal to r reshape. Whatever you want to reshape it on, if I pass like this 2, 3, and if I just print reshaped array, okay, and run this, did I just convert my original array into a different array format? Did I do this? Did I just reshape the array into a different format? Okay, let me show you one more example. Array.reshape of, if you add the number -1, 2, what happened in the original shape of the array to this? What does -1 do? What does -1 do? Let me explain that clearly for you. What is the concept of -1? Why do you use -1? No. Listen. In NumPy, if you are not sure about the shape of the array, meaning if you don't know whether the conversion of the shape will happen properly, meaning you don't know if the conversion of the columns or the rows will happen properly. So first of all, when you say 2 is what? 2 is the row order. Agree? 2 is the row order and 3 is the column order. Is this clear to everybody? 2 is the row order, 3 is the column order. If you're not sure about the row order or the column order, you don't know. You just want to make sure that the row should be 3. Because tell me one thing, depending on 1, 2, 3, 4, 5, 6, if I take one more number called 7, can this happen? Will the answer pop up 7? No. But because you don't know how many numbers exist, even number or odd number, I don't know. But if I do it like this, what happened? Array.reshape cannot reshape array of size 7 into shape 2 because you have given the column order 2. Yes or no? Agree? If I cross and put -1 and -1 here, it will still not be able to do. But what if I do 7, 8, right? And if I come over and do it like this, okay, let's change this to maybe 3, right? Give me 1 second. 1, 2, and 3. What happened here? -1, 3 cannot reshape an array in the size of 8. 8 values, can it have some number of row which we don't know, but 3 columns? If I change this to maybe 2, 1, 2, 3, 4, 1, 2, 3, 4. But automatically, did I tell it how many rows it wants or how many rows it should have? But did it do it automatically? At the same time, did it convert the dimension from 1D to 2D? Just like that, how many number of data point does X have? Do we always know? Will we always know the size of the X? No, because we don't know. And also we want no errors and we want to convert it in 2D, always put -1, 1. So have I put only one column and one row, which automatically it gives, but in 2D format. So this is reshaping the whole array. So what did we do now, right now? Did we reshape the array? What if we have more than one feature? So do we have to make all the feature into 2 dimension? Always. Does not matter you have 100, 200, 300, 800 features. It will always be 2D. It should be nested array. It will be nested array. Does not matter. It has to be 2D. Otherwise, sklearn does not consume this. Are we clear until here? Are we clear until here? Now that we have reshaped the array, if I take it like this, x underscore train, comma, x underscore test, comma, y underscore train, comma, y underscore test. Call this method called train test split. And inside this, pass the value of x and y. Okay, so the values of x and y, you can pass inside it directly. At the same time, I can say test size is equal to 0.20. What happened here is, did I import a method, a function called train test split here using the library called sklearn.model-selection? Am I using the library's method called train test split? I am. I have just called that particular function here called train test split, and I'm passing the original value called x and y. And I'm taking the 100% of the data, but for testing, how many percentage will I use? 20%. If I make this 0.30, how much percent will this be? So training will be how much percent? Training will be how much percent? 70%. Testing will be 30%. Tell me, how much will be the training percent now? Did you get it? What happened? It automatically, this function called train test split automatically calculated the value of x train, x test, y train, y test in the data and gave the test data set to be 25%. Are we clear? I'm going to keep it only 20% and split the data. Also split the data. So did we get the value of x train, x test, y train and y test? Just what I taught you a while ago. Run this code. Your answer is done. That's it. That's all you had to do. The concept I had to take was so long, but it happened in one single line. Done. Now you want to implement logistic regression. Okay, some random and nums. Okay. Return nums. Okay. Okay. Some random of 1, 2, 1 minute रुक जा. Just give me 1 second. 1, 2, 3, 4, 5,6. Okay. Or I can do this. Okay, I can do this. Some random function of a comma b. Okay. Return a plus b and return a minus b, return a into b and return a divided by b. Okay. मैंने एक फंक्शन लिखा है. I wrote a function called some random function. ठीक है? In front of you. If I call this function called some random function and if I pass in the number 4, 5, is it giving me 4 different answers? Can I say that addition is this, subtraction is this, addition is this, subtraction is this, multiplication is this, and division is this is equal to some random functions, and I will pass the value of 4, 5. If I write the addition, 4 plus 5 is how much? 9. Subtraction kitna hua? -1. Multiplication 20 and division in Python. Yeah, good. No, you got what I'm trying to say. And write functions that can return 4, 5, 6, whatever values. This function called train test split is returning x train value separately, x test value separately, y separately, y test. So when I wrote all the variables, each variable got its own answer. So did we take the x train value, x test value, and all of that stuff? Okay. So I'm going to take linear regression is equal to linear regression. Did you all implement something called classes and functions in Python? I am using something called object, a variable LR is equal to linear regression, and I'm calling a class called linear regression. I will use or I will tell the Python program that, hey, I'm using a variable called LR. It is nothing but my model. Your model, your machine learning model is called what? What is the name of the model? LR. But what have I called the variable name? What have I called the variable name? LR. So I will tell the model that take the model, dot fit it. What do you mean by dot fit? Run the model. But will it run now? No. Because did I pass the train data? No. Did I pass the Y train data? No. Now it will run. Now I have passed the data, it will run. Do you see this blue color box in front of you? This blue color thing? This shows that the model has run. Your model has run, and the name of the model is called what? What is the name of the model? LR. You can give it whatever you want. I have named it as LR, and your model has run. Are we clear? Your linear regression has run. Now, I want to know how my model performed on the testing data. So I will take another variable called ypred equals to, don't you want to make prediction on the test data to compare? What is the name of your model? LR dot predict. LR dot predict. This dot predict comes from sklearn only. You don't have to program it. It comes predict. So will I give it all the values of y test? Because all the y test value will tell me what is the y predicted value. No, you can't do that. Because y test is for comparison. You need to give it the value of x test for it to give you the value of y test, which is y pred value. So I need to, rather than x, test value, I need to give it the value of x test. Now I have all the values of y predicted, calculated for me. See, the values of y predicted values that the model has calculated for the test data is now created. So basically, I have created one more column called ypred in front of you. It's right there. Agree, disagree? Now I want to know whether my model did a good job or a bad job. So can I say R2, R square is equal to R2 score of what do you pass inside it to compare whether your model did good or not? Won't you pass ypred and y test because you want to compare them together? Y test and ypred will be passed to see how good they are, how close they are to each other. Yes. So tell me, in the R2 square, will I say y underscore test comma y underscore pred, and we will get some answer R2 is equal to 0.71. Is the model closer to 1 or farther away from 1? Closer. So did our model do a good job in prediction? Is our model doing a good job in prediction? 100% it is doing a good job. I will show you how it is doing a good job. Plot. Inside this, I will pass X test, comma Y test value. Just the X test value and the Y test value, comma, you can take whatever color you want. So let me take color is equal to black. Okay, BLACK. And the label that you can give this is the actual data. Okay, the actual data point. Plot, because you want to also print your X test value with the Y pred value. I'll tell you why. Okay, I'll tell you why. X test value with your Y pred value. What will this give me? X test comma Y test will tell me the actual data point. X test with Y pred will tell me the predicted data point. So I will say color is equal to, I don't know, you can take red, black, whatever you want. I have taken red. Label is equal to predicted value, right? Predicted value. I have taken two different plots and I'm going to run this. Okay. I'm also going to give you, give me 1 second. Did I make a, tell me before plotting, what should you make sure for? Your X test and Y test value are scatter plot, not an actual plot value, correct? Yeah, this makes sense because this is the data point that I wanted to plot. This data point, the black color line that you see, the black color dots that you see, that is your what data point? So if I plot.legend, okay, plot.legend legend. Okay, if I do this, what are the black dots? Oh, you can also do grid. Plot.grid. And inside this, pass the parameter bool called true. Yeah, plot.grid. Let me make the alpha as 0.3. Yeah. The black points are the actual data point and the red line is the predicted line. Yes or no? Do you see that the fit is good? Are we able to see that the fit is good? Please listen to me carefully. The machine learning model has learned from so many different data sets that if your head size is 3,777 centimeter cube, how much is the weight of the brain? 1,282 grams, meaning 1.2 grams, 1.2 kg. Agree, disagree? Yes or no? Sir, I want to give my number. I want to give weird number. I want to know if my machine learning model is able to predict my number or not. If you want to do that, use only one function, lr.predict. Now, you know that machine learning model like sklearn can only take a two-dimensional data. So give me a number like this, like if the head size is 4,177 centimeter cube, the answer is 1590. Give me a number like that. I will make the prediction in front of you. 6,000. 6, 1, 2, 3. What answer did I get? If your head size is 6,000 centimeter cube, what will be the weight of the brain? According to the linear regression model, it will be 1,883 grams. If you want me to give 4123, what answer did it give? If your weight is 1,406, it is 4,123, it's 1,004. We did take that. Did we not take all the values of X test here and we calculated Y pred? This is how we took, right? Did we not take all the X test value and created Y pred value and then compared Y test with X test? Now you got the concept. We took the values from the model itself and we tested how good it performed from the original data. And that's why the answer of R square came up to be 0.71. Can we try 377? Oh yeah, 100%. See, 3777. What is the answer? 1282, correct? 1282 is the answer. See, look at this. 1318. Is it closer to 1282? You got what I'm trying to say? For the answer 37777, see, look at this answer. 3982. What is the answer? 1375. Okay? 1375 is the answer. 1375 is the answer. The prediction is 1370. You understood what happened? The R square that I made you do was from scratch. The R square that I did teach you was from scratch. Will you be implementing things from scratch in life? No. You will be using the function that is being called here. Can you see I have called a function called R square? You don't need mean square error now. R square. Do you see I have used this R square? That's it. That's all you need to implement. This is the machine learning code to predict whether somebody's weight will be given or not. How many lines of code minimum did we use here? Not even 10, 15, maybe 12. This is the power of Python. This is the power of abstraction. You don't need to worry about anything. Everything else is taken care by itself, and you're able to use the library and build your machine learning model. Some of you were asking me question, but sir, how will we predict? How will we predict? Did you see? Call the model and call the method called .predict and you will be able to get the answer. Are we clear? Did we get the concept? Is it clear until here, everybody? How did we learn the machine learning code and how did it implement and how did we write it? Okay, okay, good, good, good. My question to you is very simple. If we take one value from X train and it should predict exact Y train because we feed the value. What I taught you doing the concept of machine learning using actual prediction code was from scratch for your idea. But this is how you actually implement. Can you explain about lr.predict? Okay. Y is equal to mx plus c is the equation of the line. Agree? Some value of m must be calculated like 0.8. Some value of c must be calculated for 9. So won't the lr.predict do nothing but the actual value of y will be 0.8 into what is the size of the head did we take? 3982. So it will take 3982 plus some value of C, 9 will be taken. That's why the answer came up to be 1370. Did you understand? lr.predict is doing nothing complicated. What it is doing, it has created some equation called y is equal to mx plus c. It knows the value of m, it knows the value of c. The minute you take 3982, it is able to calculate the answer 1370. This is what this function is doing. This is what that prediction is doing. Same code can be used for Swiggy. This code is reusable wherever you want to use it. Is it also fitting best possible line? Yes, Ravish. The model fits the line to the best of its abilities and then it gives the answer. Are we clear? It will automatically do all of that for you. Linear regression code runs that and gives you the most optimal answer. Don't you see the line passing through exactly in the middle, meaning the most optimal way fits? It's not even off by certain points. So it does. Because you had question in reshape, my dear, if you want to convert a data or any dimensional data into two-dimensional data, one-dimensional data into two-dimensional data, dot reshape. When you want to reshape your answers into something, you have to first pass the row and then you have to pass the column. Are you clear? The 2 will represent that create an array of size 2 and the answer 3. May you share the data set? Answer the row value and the column value and it will reshape the answer. The concept of -1 is you don't care about how many rows it will form, but you for sure want only 2 columns. And I want NumPy to take care of how many ever rows it will give me, you give me. But I want only 2 columns. If that happens and you don't care about how many rows will form, just put -1 there. Can you guys do some research and on the same data set print the value for adjusted R square? The answer will be same, by the way, because one feature, one target. But still, will you give it a shot? Will you guys give some try? Okay, let me tell you something. Do you think 2 hours of machine learning with me is more than enough for you to learn machine learning? I don't think so. This is possible forever. Don't you think you want to do your own research sometimes? Maybe validate whatever I teach. Hey, is Rudra teaching correctly or not? I want to check. He taught me linear regression. Let me learn linear regression from somewhere else also. Oh, no, no, no. Rudra is correct. Should you not do this? Should you not validate? You should not have faith in me. Make sense? You should always get it validated. So don't you think whatever code I taught you, you will implement it on your own? Also print extra value like R square, adjusted R square, and see if you're getting the answer. Do your research. If you guys are incapable, I'm not going to say incapable, but if you have a problem, let me know. Can we look into examples where multiple features are invoked? Sure, Reena, if you want to do that, I can also do this. Since it's almost 9, I will take care of that example also. But it's not going to be very challenging, Reena. You will understand once. I mean, not multiple, like I can take hundreds of columns. It's not going to be a very complicated thing. Why don't you give it a shot, Reena? And let me know if you face any trouble. If you want to implement machine learning algorithms, right? I have a folder created for guys like you. If you go to my GitHub page, right, you will find a repository called ML codes, right? In this ML codes, you will, under the ML folder, you will find something called linear regression. See here, how do I teach you? Yeah. Can you see multivariate linear regression? Can you see? I'll show you the example. See, do you have area of the house, bedroom of the house, age of the house, and price of the house? Is it multivariate, meaning multiple features? If you go to my code, look at what I did. Listen to me. Just have a look at this data. Is this the bedroom? Yeah. Do we have this equation? Listen to me carefully. Do I load the data? df is equal to df.read CSV? Yes or no? df.read CSV. I'm going to zoom it. Yes. Okay. Do I have something called linear regression is equal to regression.fit? Can you see? Regression model dot fit, but I am dropping price as the part, meaning I am taking area, bedroom, and age in my regression model, but my y variable will be what? What will be my y variable? My target y. That's it. You just have to do regression is equal to linear model. X will be equal to area, bedroom, and age, and price will be separate. Now, what did I do? I run the coefficient. See, I'm doing regression.predict. If my house is 3000 square feet, what is the next thing? 3 bedrooms and 40 is my age. What will be the price? 4,98,408 rupees or dollars. Did you get the idea? See, I'm able to predict also now. Did you get what I'm trying to say? Here, what I did is I have just dropped y variable because I don't need y variable. In X, I have taken both area, bedroom, and age. Doesn't need to be in caps. It just, you can do it in small also. Can I confirm my understanding? There are R2 here, test train, and they indicate the line is best fit or not. But none of them tell us that we have selected all the right features or not. No, that isn't feature selection. Kishle Sinha, that's different. That is using chi-square and different techniques to validate that. That is not taught by R square. R square tells you how good the fit is. But data can have null values as we are working on data before data cleaning. Will the ML give issues? Yes. If your data has null values, your answers will be wrong. Fortunately, whatever data I'm teaching you today with has been cleaned with any null and none values. So you don't have to worry about it having null or non issues, right? So you see, gender has no null value, age has no null value, head has no null value, and brain weight has no null value. So basically, if you run this method called data.isNA.isNull anything.sum, it tells you the null values. It has 0 because I cleaned it before for you. Because I'm thinking first you guys should learn how an algorithm works. Then slowly we'll go to EDA, make the data, clean the data, fix the data, mend it, and then we will do implementation of that. Everything happens step.
Let me just give you a quick recap at the linear regression concept as we would be needing them in logistic regression. So let's start off linear regression recap with this example. So this is Lauren. She's looking for a property to buy, but she's confused how to start. So she goes to one of her friend, Josh, and asks him if he could help her to find a property with bigger garden area for X bucks. Our guy Josh on the right agrees to help her to find a property, but he himself doesn't know how. So what he do, he goes to another friend of him, explains him the whole situation and asks him if he can do anything about it. He immediately says yes and start doing some calculations.
Then he says to Josh that spending X bucks can get her a property of area Y. Now Josh is confused and asks him how did he find out. The friend goes like, simple linear regression. Now let's see how exactly he used simple linear regression to solve his issue. So here are our dependent variable and independent variable. Property size being the dependent variable and money being the independent variable. What this guy want to do? He want to find out a relation between the property size and money. So it's like if you want a house of bigger area or bigger property size, then you have to spend more money. So both of them are directly proportional, right? So in this case, we'll get a positive linear regression line, right? That is, spending more money will get her a bigger property, okay? In other case, but again, our next scenario is she wants a bigger garden area, right? So imagine the scenario keeping the property area constant. The house area is inversely proportional to the garden area. It's like if you want to increase the garden area, so you have to reduce the house area. So take it like this. Suppose you have already fixed the property and you want to construct a house with a garden in it. But now your demand is you want to have a bigger garden area. So if the size of the property is fixed and if you increase the size of the garden, then obviously you have to reduce the size of your house, right? So in this case, if you try to plot a regression line, you'd get a negative regression line, right? Bigger garden area means smaller house, right? Now let's take an example to see how exactly did he predict the value of the house. So in order to find the regression line, what he did, he took the historical data of property area sold in the particular price, okay, and he plotted it on the graph. So this was the plotted point of property area sold in past for a particular price, okay. Now what he did, he drew a regression line. Now to find out what property area she can buy with X bucks, he plots X on the independent variable scale and project it to the regression line. And then against that point, there he has the area Y. This is the area Y. So this is how he predicted Lauren can buy Y area of property in X bucks. Alright. Now let's see what he can and what he cannot say from this. So he can say that if Lauren spends X amount of money, she can buy a property area of Y. But what he cannot say is, will the property would have a good neighborhood or not? Or will the location be noiseless suburb or a bustling city? Right, so these are the questions which even he cannot answer using this graph. So the questions like, will the property will have a good neighborhood? Or will it rain tomorrow or not? Or is this mail a spam or not? All these kind of problems fall under a particular category known as classification problems in machine learning. Now with linear regression algorithm, we could not answer these problems. So that is where logistic regression comes into picture. Now let us see where this logistic regression algorithm that we just talked about lies in the machine learning algorithm tree. So in machine learning, we use two traditional learning techniques to build a predictive model: supervised learning and unsupervised learning. Again, look at the supervised learning. There are two categories, regression and classification, right? In regression, we have linear regression, and in classification, we have logistic regression and SVM. So our today's topic of discussion is logistic regression, which comes under the category of classification. Okay. So now that we have got a little bit idea about logistic regression, let's go a little bit deeper and discuss about what exactly is logistic regression and why do we use it. So what is logistic regression? Well, logistic regression is a statistical classification model that deals with categorical dependent variable. Again, you must be wondering, what are these categorical dependent variable? Well, these are some of the discrete variable that have two or more categories without having any kind of natural order. For example, temperature, area, or gender. Okay. So you can say that logistic regression is generally used where the dependent variable is binary, or where the dependent variable is binary. That is, only two outcomes are possible, either yes, no, true, false, 1, 0, etc. Right. And also remember a fact that you can use both continuous and discrete input data with logistic regression. So before moving ahead, let's look at the graph. See, there are two variables. One is independent and other is dependent. Can you figure out which one is dependent and which one is independent? So before moving ahead, let's take a look at this graph. So over here, we have two different variables, hours studying and probability of passing exam. Can you figure out which one of them is dependent and which one of them is independent? So if you have guessed that hours of studying is your independent variable and probability of passing the exam is dependent variable, then I'd say that you are 100% correct. So now that you know what exactly is logistic regression, let's move ahead and see why do we use logistic regression. Well, logistic regression can be used as a tool for applied statistics and discrete data analysis. Why? Because it gets the output in the form of probabilities, which help us to easily classify the given data. Okay, so this is why we are using logistic regression. So now that we have successfully established the basic of logistic regression by understanding what and why of it, let's go ahead and see how logistic regression can be applied for classifying data with the help of an example. So here we are using an example of spam email classifier. We need to build a predictive model that would classify whether a mail is spam or not. So let's look at the approach that we are going to take while building this model. First, we'll try to understand the variable that on the basis of which we are classifying the mail. Next, we'll plot the label data. Once we are done with plotting the label data, we'll draw the regression curve. And finally, we'll try to find out the best fitted curve using maximum likelihood estimator. Alright? So let's get started. So step 1 is defining the variable. So let's start off by understanding what is independent variable in our case. So in our case, the independent variable is count of spam words. Well, here are some examples of commonly used spam words. Word like buy, get paid, guarantee, winner, unlimited, etc. Okay, so these are the kind of words which when found in the mail is treated as spam. If the number of these kinds of words are more in a mail, then that mail would definitely be a spam mail. Okay, just for a better representation, let me put them in a bag of spam words. Let's put the bag. So there's a bag of spam words. Let's put all the words in them one by one. Buy, get paid, guarantee, winner, and unlimited. Okay. Now, what about our dependent variable? Well, our dependent variable is going to be the probability of mail being a spam. If the probability is 1, that means the mail is spam. If it's 0, it means it's not a spam mail. Well, in general, the mail with less number of words from the list of spam words will be treated as a spam mail. With 5 or more spam words in a mail would be treated as a spam mail. But there can be cases where you might find mails with less spam words being spam. Also, you might find cases where mails with more number of spam words is not a spam mail. So here our aim is to build a predictive model to classify the mail with minimum error. Okay, let's see what is our next step. So our next step is plotting the label data. Let's say this is a set of data that we'll be using to build the model. This is a very small data set, but just remember that whenever you are using logistic regression, make sure that you are using a large amount of data. Logistic regression works pretty well with large amount of data. It doesn't work that good with small amount of data. Okay, here just for the purpose of understanding, we are using small data set. Alright, so we have two variables, number of spam words and the probability of mail being spam against each mail. Okay. Next, as a step 3, we'll draw the regression line. So next what we'll do, we'll plot our data set on x-axis and y-axis with independent variable on the x-axis and dependent variable on the y-axis. So number of spam words in a mail is an independent variable, right? And the probability of that particular mail being a spam or not a spam is a dependent variable. It depends on the number of spam words in a mail, right? So let's plot these words one by one. So first we have is one word and the probability of this mail being a spam is 0. So it will be plotted up here. So next we have is 5 spam words in a mail and the probability of that mail being a spam is 1. So it will be plotted somewhere here. Next is 3 spam word is a spam mail. So it will be plotted again here. 2 words, it's not a spam mail. So I'll be plotting up here. 7 words, again a spam mail up here. 4 words, not a spam mail here. 9 words, it's a spam. 8 spam words, again, it's not a spam. So once we are done with the plotting, this is how our plotted data would look like. Now let's say that we have a new mail and now we want to figure out whether it's a spam or not. So before moving ahead, let me just tell you, in real world scenario to perform logistic regression, you need a large amount of dataset. And also you might find many cases where a spam mail might contain only 2 words, where a spam mail might contain only 2 spam words. Or also it might be possible that you get a mail where you are having more than 5 spam words, and even in that case, your mail is not a spam. Okay, so here we are building a predictive model with primary aim to reduce the error. Okay. Now let's say we have a new mail up here. Now we need to figure out whether this mail is spam or not. But how do we do that? Well, first of all, we need to plot a regression curve which would fit the best. And that curve would be our logistic regression curve. But now the question comes, how to find out which is the best regression curve? Okay. Well, this will contain 3 steps. Well, the first step is to convert the y-axis from the scale of probability confined between 0 and 1 to a scale of log odds. Then drawing a random regression line out of the data that we already have. Then with the help of sigmoid function, we'll convert the log odds to the probability of mail being spam. We'll plot each mail on the base of their new probability values. And this will form our regression curve. Then finally from this plot, we'll find out the log likelihood values of each mail. Now from this plot, we'll find out the log likelihood values of each mail. The individual likelihood. At last, we'll find the log of likelihood. That would be our log likelihood of the regression curve. Now the question comes, what are these terms such as log odds or log likelihood means? So before moving ahead, let's discuss that. So what does log of odds mean? Let us explore this with the help of an example. So before we proceed any further, let me just clarify you one thing. This probability and odd, these are not the same thing. Let me explain you this with an example. Suppose this guy, he goes to fishing 5 times a week. So out of 5 times, he catches a fish 2 times and he failed to catch 3 times. Okay. So now in this case, what is the probability and odd for getting a fish for dinner? So let's first calculate probability. So probability is chances for divided by total chances. So chances for catching a fish. So what is the probability of catching a fish? That is how many times he caught a fish. That is 2 divided by total chance he had to catch the fish. So that was 5, right? So here probability of getting a fish for the dinner is 2 by 5. Okay. Next comes the odd. Chances for divided by chances against. That is the ratio of how many times he caught the fish divided by how many times he failed to catch a fish. Okay, so he caught the fish for 2 times and he failed in catching the fish for 3 times. So the odd for getting a fish for dinner is 2 by 3. Okay, so now that we know odds, now let's see what log of odds and log odd ratio are. Are they same? Let's find out. For your information, log odds is also called as logit function. Okay. So in our previous example where the fisherman was catching a fish, let's add another factor to his fishing. Let's add a factor as weather. So then we can recreate the entire scenario as he was successful 2 times on a rainy day. But on a sunny day, he was successful for 3 times. Now the odds of catching fish on a sunny day is how much? It's 2 by 3, right? And the odds of catching on a rainy day is 3 by 2, right? As it's already mentioned that on a sunny day, he catches 3 times. So he is successful for 3 times and he failed for 2 times. So let's see he was successful 3 times on a rainy day and 2 times on a sunny day. So odds for catching a fish on a sunny day is 2 by 3. That is, he's successful 2 times on a sunny day and he failed for 3 times in a week. So odd for catching fish on a sunny day is 2 by 3. Similarly, odd for catching fish on a rainy day is 3 by 2. And now log of odds of catching a fish on a sunny day is just log value of 2 by 3. And similarly, log of odds of rainy day is log of 3 by 2. Now log of odds ratio is nothing but the log of odds on a rainy day divided by odds on a sunny day. Okay. Next is log of odds ratio. So log odds ratio is nothing but the ratio of log of the odds on a sunny day to log of the odds on a rainy day. That is log of 2 by 3 by 3 by 2, which is nothing but log of 0.44. So here we can say that odds and odd ratio are both different things. Now let us go back to this step So now that we have understanding of log odds, so we are ready to perform this step. Okay. So let's see how we converted the 0, 1 axis to minus infinity to plus infinity axis. So here we'll be converting the probability scale to scale of log odds. Okay. So for the log odds, we have a formula as log of probability of spam divided by 1 minus probability of spam. So here the probability of a mail being a spam is 1. Okay. So we get the value of log odds as log of 1 divided by 1 minus 1. That is log of 1 by 0. It's positive infinity. How we got that? So log of 1 by 0 is nothing but log of 1 minus log of 0. And log of 0 up here is minus infinity. So minus of minus infinity is what? Plus infinity. How log of 0 up here is minus infinity? Let's see. So in general logarithm, so we have log 0 with base b equals c. So if you convert it into exponential form, we get 0 equal b to the power c. Right. So if the value of b is less than 1, so the value of c has to be extremely small or closer to minus infinity for this equation to be true. Okay. And we'll get a positive infinity in the case where b is greater than 1 or our base is greater than 1. Okay. So coming back up here. So here log of 1 by 0 is nothing but log of 1 minus log of 0. And we got the result as positive infinity. As log of 0 up here is minus of infinity. And minus of minus infinity is what? Plus infinity. How we got the value of plus infinity? Let's see. So log 0 with base b equals c. If we convert this into exponential form, we get something like this. 0 equal b to the power c. Right. So for the equation 1 to be true, if the value of b or the base is less than 1, then in that case the value of c will be positive infinity. Okay. For example, 0.1 to the power 1000 would be smaller than 0.1 to the power 100. Right. So more the value of c up here, more closer will the number get to 0. Right. And in next case, if the value of b is greater than 1, so for this we have to make the value of c closest to minus infinity. Why? For example, we have 10 to the power minus 1. Okay. Or 10 to the power minus 10, which is more smaller. 10 to the power minus 10. Right. So which is much smaller or closer to 0? 10 to the power minus 10. Right. So that's why we have to keep the value of c as less as we can. So here, if the value of b is greater than 1, the value of c would have to be close to minus infinity in order to make the equation true. So in this case, log of 1 by 0, by default we have base as 10. Okay, so that's why we took the value of c as minus infinity. So minus and minus of infinity is plus of infinity. So that's why we got the plus infinity up here. I hope this thing is clear to you. How we got the value of log odds as plus infinity. So I'll plot this up as plus infinity log odds. Now next, let's find the log odds of non-spam mail. So here we have the formula as log of probability of a mail not being a spam divided by 1 minus probability of mail not being a spam. So log of 0 divided by 1 minus 0. So we have log of 0 by 1, which is log 0 minus log 1, which tends to minus infinity. Okay, similar concept. Now we have our data up here. So first we'll assume one regression line. So now we have our data up here. So first we'll assume one regression line. Then we'll project our data onto the regression line. Okay. Now let's just go back to this step where with the help of sigmoid function, we'll convert the log odds to the probability of mail being spam. Okay. But what does this sigmoid function mean? So sigmoid function is the standard logistic function, where logistic function is defined as L multiplied by e to the power k times of k minus k dot upon 1 plus e to the power k times of x minus x naught. So here L is the curve's maximum value, k is the steepness of the curve, x naught minus x is the value of sigmoid point. Okay. So here the sigmoid function e to the power x divided by 1 plus e to the power x, here k equal 1 and x naught equals 0 and L equal 1. So this mathematical sigmoid function form S-shaped curve which is confined between 0 and 1. Let's try to understand how logistic function works with the help of an example. So let's say we have a set of unspecified data and on these data we need to apply a sigmoid function. So let's see what a sigmoid function can do by visualizing this graph. So let's say we have a unspecified data, and on these data we need to apply sigmoid function. So plot this data and find out the respective y for these points. Okay, so what a sigmoid function is doing, it can be visualized from this graph, right? So you are giving some values on your x-axis, and using sigmoid function you can predict its probability on the y-axis, right? So this is the reason why sigmoid function is very useful while solving the classification problem. It takes any real valued number and maps onto a value between 0 and 1. Okay. Well, now that we have an idea of how sigmoid function works, let us move ahead with our spam email classifier. So we are ready to perform this step. That is converting the log odds graph into a sigmoid function graph. Now we have to find out the best MLE. Okay. Best maximum likelihood estimator. So we are going to replace the log odd value of each mail to get the probability of each mail being a spam. So we have the formula up here, probability equal e to the power log odds divided by 1 plus e to the power log odds. So 1 by 1 will place the log odds of each mail into this formula and calculate the probability for each mail. Okay. For example, I have this mail which after projecting into the regression line gives us log odd value of minus of 3.2. Okay. So what we'll do up here, we'll calculate the probability using the value of minus 3.2. We'll place the value minus 3.2 in our formula, e to the power log of minus of 3.2 divided by 1 plus e to the power log of minus of 3.2. So from here, we'll get the probability as 0.03. So plot it accordingly onto the new graph between probability of mail being spam versus spam word count. So on the basis of probability, our mail would lie somewhere near to 0. So according to the prediction, this mail is not a spam mail. Again, for another mail which is projecting on a regression line, this gives us a log odd value of 5.6. So when we put the value of 5.6 in the formula, we get the probability as 0.99. So the probability of this mail being a spam is 0.99. So again, we put this into this graph. Similarly, 1 by 1 will calculate for each one of them. For this mail, after projecting onto the regression line, we get the log odds value as minus of 4.5. So minus of 4.5 when put into the formula, we get the probability as 0.01. So the prediction of this mail is not a spam mail, which is same as actual, right? So again, we plot this mail onto a graph, alright? So similarly, you can repeat this step for the rest of the email as well. And finally, we got the S curve up here. So this is our regression curve. But you must be wondering, is this the best fitted curve? Or how do we find out whether it's best or not? Well, this is when the concept of maximum likelihood comes into picture. So now that we have regression curve, let's find out the likelihood of this curve. So first find out the individual likelihood of each mail. Again, you must be thinking, how do we get the likelihood value? Well, likelihood of each mail is nothing but the probability value of each mail being spam. So likelihood of first mail being spam is 0.01. Likelihood of second mail being spam, again 0.01. Similarly, third 0.03, fourth 0.05, and so on till 8th mail being 0.99. Okay. So once you get the individual likelihood of each mail, multiply them to find out the likelihood of the entire curve. Okay. Then calculate the log of likelihood. For calculating the log of likelihood, you can just take the log of the previous result. Okay. You can just take the log of previous multiplied result. Here we are adding all the logs because log of A multiplied by B equal log of A plus log of B. Okay. So we got the value of log likelihood of this curve as minus of 0.084. Now let us rotate this line to find out the best fitted regression line. So we got the log likelihood of this curve as minus of 0.084. Now let us rotate this line to find out the best fitted regression line. Again, we calculate the individual log likelihood of each mail. For this one, let's say we got log likelihood which is shown on your screen. So final value we got up as minus of 0.207. So we got the value as minus of 0.207. So now if we compare the log likelihood values for these two regression lines, we'll see that line A has bigger value of log likelihood than line B, right? As line A has log likelihood value of minus of 0.084. So the log likelihood value for line A is minus of 0.084, whereas for line B is minus of 0.207. So minus of 0.084 is bigger than 0.207, right? So therefore we can say that line A has better likelihood value than line B. Now again we'll rotate the line. We'll keep on rotating the line until we get the maximum value of log likelihood. And then finally we'll choose a line which is having the maximum log likelihood, and that line would be the best fitted regression line. So I hope the concept of logistic regression is clear to you guys. So for now, this was all about the theoretical and mathematical concept of logistic regression. So the confusion matrix shows the ways in which your classification model is confused when it makes predictions. It is basically a summary of prediction result on a classification problem. The main key to a confusion matrix is summarize the count value of correct and incorrect prediction. So the image shown on your screen represents a confusion matrix. Let's see what exactly does it mean. But before that, let me just tell you how to create a confusion matrix. This would make things more clear for you. So let's see how. So for creating a confusion matrix, you would be needing a test dataset or a validation dataset with expected outcome values. Then make a prediction for each row in your test dataset. Then from the expected outcome and prediction, count the number of correct prediction for each class and the number of incorrect prediction for each class, organized by that class that was predicted. Okay, let's see what exactly does it mean. So here's an example. We have some expected output and a predicted output for that. So from here you can see that all the red color results are the incorrect predicted values and the green ones are the correct ones. So in total we have 7 correct prediction out of 10. Okay, so from here you can say that the accuracy of your model is 70%. Now here men classified as men are 3, 1, 2 and 3, and women classified as women are 4, 1, 2, 3 and 4. And now men classified as women, men as women 1 and men as women 2. Okay, so 2, and women classified as men 1. Now if you create a confusion matrix out of it, you will get something like this. Men classified as men 3, men classified as women 1, women classified as men 2 and women classified as women is 4. So from here you can say that total actual men 3 plus 2 is 5. Total actual women 1 plus 4 again 5. And total correct values, men classified as men and women classified as women, that is 3 plus 4. It's 7. So from here you can say that there are more errors while predicting men as women rather than predicting women as men. Okay, so this was about how you can calculate a confusion matrix. Now let's come back and see how to interpret a given confusion matrix. This is the sample of a confusion matrix. So here we have created a confusion matrix for a fire alarm. So this represents an actual alarm, this represents no actual alarm. Here predicted fire positive and here predicted fire as negative. So if the alarm goes on in case of fire, so it's a true positive event. The alarm goes on and there is no fire, so it's a false negative event. There is no alarm in case of fire, so it's a false negative event. And there is no alarm and there is no fire, then that means it's a true negative event. Okay, so let me just explain you this example. This should make things more clear to you. So actual alarm and predicted fire. So total true positive events we have 40 and total false negative event we have 10. So from here you can say that total number of times the alarm rang was 40 plus 10, that is 50. Okay, here we have false positive event as 5 and true negative event as 95. So the total number of times the alarm did not rang was 5 plus 95, that is 100. And this one is the predicted fire or not. So true positive plus false positive, that is 40 plus 5. How many times the machine positively predicted the fire? So that is 40 plus 5, 45. And how many times the machine was not able to predict the fire? That is 10 plus 95, that is 105. And total number of events, that is 50 plus 100 or 45 plus 105 is 150. So we have mentioned n equal 150 up here. That is total number of events. Okay, so this is how you interpret a confusion matrix. So let's move ahead. So now let me just show you in my Jupyter notebook how you can create a confusion matrix. Let me just open my Jupyter notebook. So there's my Jupyter notebook, and what we are gonna do is create a confusion matrix in Python. So the very first thing that I'll be doing up here is importing the required libraries. So from sklearn.metrics, so I'll be importing confusion matrix. Next, let's create some expected value. Let's say expected equal. So let's add some values in it, like 1, 1, 0, 1, 0, 0, 1, 0, 0, and 0. Now this is my expected value. Now let's create some predicted values for that. So predicted equals, first it's predicting correct. Next, let's say 0, 0, 1, 0, 0, 1, 0, 1. So this is a predicted value. Now let's calculate the confusion matrix. So let's say results equal confusion underscore matrix. Inside this we'll pass our expected and predicted value. Expected, comma, predicted, and print the result. That's it. Let's execute it. So here you got the result as 4, 2 and 1, 3. So what does it mean? So first we have is 4. So 0 predicted as 0 is 4 times. 1, 2, 3 and 4. So 0 predicted as 1 is 2 times. 0 predicted as 1, 1. 0 predicted as 1, 2. Okay. Next is 1 predicted as 0. So 1 predicted as 0 is just once here. Okay. And next is 1 predicted as 1, that is 3 times. 1 predicted as 1, 1, 2 and 3. So this is a confusion matrix. And what we can say from here, so total number of correct prediction made by machine is 4 plus 3, that is 0 classified as 0 and 1 classified as 1. Okay. And total number of incorrect prediction is 2 plus 1, that is 3. So we have 7 correct prediction and 3 incorrect prediction. Okay. And the total number of times the machine predicted the value to be 0 is 4 plus 2, that is 6 times. And total number of times the machine predicted the value to be as 1 was 4 times. Okay. So from here we can say that our machine predicts the result 7 times correct and 3 times wrong. So the accuracy of our machine is 70%. So this was all about how you can create a confusion matrix in Python.
A demo with logistic regression with the help of scikit-learn package. And we're going to build this logistic regression algorithm on top of the heart disease dataset. So let's quickly go to Jupyter Notebook and start with a demo, right? So this is Jupyter Notebook, guys. And our first task would be to load up the heart disease dataset. And for that purpose, we would have to import the Pandas package. So I'll just type in import Pandas as PD, and I'll use this read_CSV method from the Pandas package. So I'll type in pd.readCSV and I'll pass in the name of the dataset, which is basically heart.csv. And I'll store this in this dataset object. Now let me have a glance at the first few records of this dataset. So this is our dataset which comprises of all of these columns. And we're going to build the logistic regression algorithm on top of this column over here, which is basically target. So target would be our dependent variable and the rest of the columns would be the independent variables. Right. And this target basically means that, so you have 1 and 0 values over here. The 1 value means that the person or the patient has the heart disease, and 0 basically means that the patient does not have heart disease. Right. Now let me also have a glance at the shape of this dataset. So I'll just type in print dataset.shape, and this gives me a value of 303 and 13. So 303 means that there are 303 records in this dataset and 13 columns. Now let me actually have a glance at the value counts of this target column. So this value counts basically tells me the frequency of these two values. So I have these two values in this column, which is basically 1 and 0. So there are 165 records where the value is 1 and there are 138 records where the value is 0. So this basically means that in this data set there are 165 patients who actually have the heart disease and 138 patients who do not have the heart disease. Now I'll go ahead and actually visualize this. So I'll load up the Matplotlib package and Seaborn packages, and I will pass in this target column onto the x-axis, and the data is our data set, which is basically this heart disease data set. And what I'm doing is basically building a histogram, and I'll plot this up over here. Right. So this is the bar plot for the value of 0, and this is the bar plot for the value of 1. And this basically tells us the same thing. So 165 is the value of the number of patients who actually have the heart disease. So this basically is for all of those patients who do not have the heart disease. Alright. Now let me go ahead and divide the data set into features and label sets. So I'm storing all of the features into this X object. So all of these 12 columns would be my features, and this target column would be my label or would be my dependent variable. Alright, and this is how I'm going to divide the data set. So I'm going to extract all of the columns except the last column and store it in this X object. And similarly, I'll only take the last column and store it in this Y object. Alright. Now let me have a glance at these individual independent variable and target variable. So x.head gives me all of the independent variables, and y.head gives me the target. Right. So now that we have our independent variables and the dependent variable, let me go ahead and divide this data set into training and testing set. And for that purpose, I'd have to load up the train test split method from sklearn.model selection, and over here I'm setting the test size to be equal to 0.2. So this means that 20% of the records are in the test set and the rest 80% records are in the training set. Alright, I'll click on run again. Now we have divided the data set into training and testing sets. Now finally it's time to build the model, and for that purpose I'll be importing Logistic Regression from sklearn.linear model. And I'm going to create an instance of this. So I'll just use this method Logistic Regression, and I'll name that instance to be log model. And I'm going to fit this model on top of the train set. So I'm basically passing x train and y train as the parameters. Right, I'll click on run. Right, so we have successfully built the model on top of the train set. Now we're going to go ahead and predict the values on top of the test set. So I'll type in log model.predict and I'll pass in xtest as the parameter, and I'll store the result in ypred. So we have also predicted the values. Now it's time to calculate the accuracy. So I will type log model.score and I'll pass in xtest and ytest. So I want to calculate the accuracy for the prediction on top of the test set. Right. So the accuracy comes out to be 73%, which is actually not that bad. And let me actually also build a confusion matrix. So confusion matrix would give me a table of values which actually comprises of the correctly predicted values and misclassified values. So I'd have to import confusion matrix from sklearn.metrics, and again I'll just pass in ytest and ypred as the parameters inside this function, and I'll print this out. Alright. So this left diagonal which you see, this left diagonal actually represents all of those values which have been correctly classified, and this right diagonal represents all of those values which have been misclassified. And if you want to get the accuracy, all you have to do is add up 20 plus 25 and divide it with all of the values, and you'll get the same accuracy. So let me actually add up a new cell over here and calculate the accuracy from this confusion matrix. So I have to divide this left diagonal with all of the values. So that would be 20 plus 25 divided by 20 plus 25 plus 10 plus 6. And this gives me a value of 73.77, which is the same as I got over here. So the accuracy is 73%, right? So we have built the confusion matrix. Now I'll also go ahead and build the ROC curve. So the ROC curve, it sort of gives me the right trade-off between the true positive rate and the false positive rate. So let me go ahead and plot this, and this is what we get over here. So on the y-axis we have the true positive rate, and on the x-axis we have the false positive rate. And basically you can understand this plot this way. So the closer this curve is to this top right corner over here, the better the model. That is, this curve needs to cover greater area. And this, what you see, red line, so this basically represents a classifier which would give you around 50% accuracy, and your model would be as better as it is far away from this red line. That is, this blue line has to be towards the top left corner, right? And this is how we can implement logistic regression model with the help of sklearn.
Just a quick info guys, Intellipaat offers a data science course in collaboration with iHub IIT Roorkee, which will help you master concepts like Python, SQL, machine learning, AI, Power BI, and more. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth with the data science course. Now, the next fundamental algorithm that you will learn in your machine learning journey is SVM. It might seem tricky at first, but by the end of this tutorial, you will see how simple and effective it really is. To make things easy, let's start with an example. Let's say there's a basketball coach handling a bunch of players and he wants to categorize these players as tall or short based on their height. Here's the data he collected. Now your goal is to help this coach draw a line or a boundary that best separates the tall players from the short players. This is exactly where the SVM algorithm comes in the picture. It finds the best possible boundary, also called a hyperplane, that separates different categories in your data. So we know that SVM finds the optimal boundary for categorizing data, but how does it exactly do so? It works by maximizing the gap between the two categories. Think of it like placing a fence between two groups so that the fence is as far as possible from both sides. Mathematically, the boundary is chosen in such a way that the margin, that is the distance between the closest points of each group, and the boundary is maximized. The points closest to the boundary are called the support vectors. These are the most important data points that define the boundary. But what if the data is not perfectly separable? That is, real world data is often messy and we can't draw a straight line to separate the groups. In such cases, SVM uses something known as a kernel trick to transform the data into a higher dimension where it becomes separable. This allows SVM to handle even complex data sets. It might sound like an advanced concept, but in reality, it's just about drawing the best possible boundary between different groups in your data. So far, we've explored linear regression, logistic regression, and SVM. Now let's dive into another powerful algorithm, decision trees. So let's break it down with a simple example. Let's say there's a restaurant owner and he wants to predict whether a customer will order dessert or not. He has collected some data based on the past orders. Now your goal is to build a model that can predict whether a new customer will order dessert based on their age and whether they ordered a main course. Now your first instinct would be to use logistic regression because it's used for classification problems like predicting yes or no. But here's why it's not the best fit for this case. Logistic regression works well when the data is perfectly separable. That is, logistic regression relies on a linear decision boundary in feature space. But in our case, the data is not perfectly separable. Look at customer B and D. They both ordered a main course, but one had dessert and the other did not. This suggests that the decision might depend on a more complex interaction between age and the ordering behavior, something that logistic regression is likely to struggle with. A decision tree, on the other hand, works by splitting the data into smaller and smaller groups based on certain conditions, just like how we make decisions in real life. For example, let's say we first check whether the customer ordered a main course. If yes, then we check their age. If the age is below 30, they are more likely to order dessert. If the age is above 30, they are less likely to order dessert. This forms a tree-like structure where each decision leads to a new branch, eventually leading to a prediction. But how does a decision tree decide where to split? The algorithm tries to find the best question at each step to separate the data into the most pure groups possible. It uses a mathematical concept called information gain or Gini impurity to determine the best splits. The idea is simple. The cleaner the split, meaning all items in a group belong to the same category, the better the decision. But real world data is often messy and complex, and sometimes a decision tree can become too complicated by making too many splits. This is called overfitting, meaning the tree learns the training data too well but struggles with new data. To avoid this, we prune or cut down unnecessary branches, keeping the tree simple and effective. I hope this explanation made things clear. Since these topics are also important parts of machine learning, we've covered all of them in separate detailed videos. You can find the links to those in the description below as well as in the eye icon on the top right corner of your screen. Alright, now let's dive in clustering algorithms and see how it helps us group and understand data in a whole new way.
Going to start the unsupervised learning, which is known as K-means clustering. What is K-means clustering? Before I get into K-means, I hope you recall what is unsupervised. So far we were doing only supervised learning, but if I may ask, what is unsupervised? Use of unlabeled data, right? That's correct. So, see, remember when we were looking at supervised learning, we had a data structure like this. Just hold on. So let's say you used to see a table and used to have different variables, right? Right? X1, X2, X3, X4 up to Xn, n variables. And then you used to have a Y. This Y we call the labels, right? That actually helps you. So this is how we say level data, right? Y stands for your target or response. So in supervised learning, you used to have this, but in unsupervised learning, this guy will not be present, right? This will not be there. Okay, so only the X values. So this is what you see in supervised learning. So let me write here. This is supervised learning. And if I just make a copy of it and I say this guy will not be there. So let's say this is X5 dot Xn. You got it, guys? This is X5. Just trying to, improvise that. Yeah. Then this becomes your unsupervised learning. So there are no targets, no labels. Okay. Means no labels. Implies unlabeled data. Cool. So you guys have an idea. So when you are in such situation, right, under unsupervised learning, right, you try to group data into clusters, So it's more like you're trying to find patterns. Since data has no levels, so you find patterns on the basis of similarity and then try to group them into cluster. So maybe I can also write it down. So in unsupervised learning, there is no output variable to guide the learning process. Data is explored by algorithms to find patterns. Given that data has no levels, the algorithm identifies similarities on the data points and groups them into clusters. Okay. So let's try to understand within that there's a concept of k-means clustering. Okay. So k-means clustering, K stands for number of cluster and means stand for averaging the data point position to find the center of the cluster, right? That's your mean. So k-means clustering means you're trying to divide the data, right? Basis the similarity into groups. So let me take a very simple example of demographic data. So demographic data, when you go and visit a mall and you go to a store like Zara or something like, some similar kind of stores, they take some of the data points from you, right? They can collect the customer data and try to divide the customer into different segments. So again, this brings me to this topic of that, when you're trying to go to a certain store, you will be, giving some data to different, different stores. They will be taking your, name, age, gender. They might ask you some personal questions also, like how much your salary and all those things, and then try to, come up with down the line, you will get a mail, some marketing campaign is happening and you are getting informed, right? So that's what we say customer segmentation on the basis of similar trait. Okay. To solidify this conversation, I can take an example of, let's talk about how to say, have you ever gotten an ad or a call or any message for buying Audi? Anybody in this session? Audi or Merc? Merc is like Mercedes. Never ever, right? I know why. Because they know that we are not their customers, right? How they know that? Because they have the data for us. In India, too, it's very easy to get the data. बहुत आसान है. Now, if you talk about those kind of, examples, right? Students never get called for credit card, those who are really poor laborers, right? They don't give a call for loans, right? Why? Some of the guys get calls for loans, some of the guys get called for credit card, and some of the guys get called for, audit, because they have the market segmentation. They know their market. How they know their market? So they have the data of their customers and then divide into different clusters. So can you see on the screen? And this is your customer base, right? On the left. I hope you can see a nice chart there. So this customer base, right? They divide into, as of now, here 4 clusters, saying that, these are my, recent customers. These are my champions. So they keep coming, keep buying, right? Keep spending money. They are like at risk customers. Maybe they have not, they have not bought anything in last 1 year, right? And these are my loyal customers, right? So those kind of segments they have done, so that they know that how they can reach out to, to these kind of segments. And to give an idea, I think if my customers are at risk, what you will do to retain them? What should a company will do, right? They'll give some discount, right, guys? Come on, discount or offers. You agree? Those who are their loyal customers, right, they might not get a lot of discount, because anyway they are loyal to us, so they might come every time, even keep pulling them, right? Champions and are the ones which are very aggressive. They have done a lot of shopping in recent time. You might not also give any discount to them. But if a new customer has come, you might give some more offers so that they keep coming back to us, right? So those kind of strategies can be used or leveraged if you have proper segmentation. Now you understand the application of k-means clustering can be, one simple application can be like this. Okay, so as I go more into details, I'll tell you more about, but this is a very simple example, and this algorithm is also very easy to understand. Okay, so how does k-means clustering, work and all, I'll talk about in some time. Okay, let's move on. So let's try to answer what is k-means clustering, right? Means how do we define it? In k-means clustering technique, each cluster is represented by its center called a centroid, which corresponds to the assigned to the cluster. So if you see, we are saying each cluster is represented by its centroid, right? So center is called centroid, which is the arithmetic mean of all the data point assigned to that cluster, right? So when I'll take an example, you understand, okay? Now the question comes, what is a centroid? So a centroid is a single data point within that cluster, which represents the center of the cluster, and that means the mean, and that's where this mean is related to your k-means. Okay, that's where you got the name. So a centroid is a single data point within the cluster, within each cluster, which represents the center of the cluster called the mean, and it might not be necessarily be a member of the data set. So it can be a calculated value also, right? It's not necessary it's coming from one of the data set, is assigned like the mean, okay? So that is a very important point to keep in your head. That is not necessary that one of the data point will be given the role of the centroid. It may be possible that you might have calculated the centroid, although that value lies within that cluster, that group, but it's not necessary it's coming from one of the data points. Clear? Now, see here. I'm showing an image just for your reference. Can you see? So there are 2 groups of the data it has formed. One group is this one. Okay. Other group is this one, and it looks very logical because all these blue data points are more closer to this centroid, which is your red color, right, guys? Come on. And these are close to green, right? You agree? Because finding someone close to this is really not making sense, right? Saying this is close. So here you have two clusters. This is cluster 1 and this is cluster 2. If you try to see cluster 1 and cluster 2, they are having centroids, right? So this is your centroid of cluster 1 or for cluster 1. This is your centroid for cluster 2. Clear? So that's how you you get to the centroid. So K-means clustering is all about finding that centroid, calculate. It's a calculated value. So calculate that centroid, and it's an iterative process. So first, they will assign any data point or any value as the centroid, and they keep updating it to find and I'll show you the example that how does this iteration work, but they'll keep trying to find the better one. And the whole idea is to minimize the within cluster distribution and maximizing the, across the cluster distance. So what is the objective of the algorithm? K-means clustering tries to minimize distance of the points in a cluster with their centroid. So see, it tries to minimize what? Minimize the distance of the points in a cluster, right? There will be only one centroid for one cluster, Vikas. Okay. For now, you should also understand what is my message here. My message is that you are trying to minimize the distance of the point within each cluster so that you find only one centroid, the better one. Okay. So you might start here. This is my centroid. Then you realize, okay, no, I'm not in the center of the position. See, tell me one thing. If I draw a circle, you will try to find the balance where? Till the time you reach the center. So centroid also works in the similar fashion. But your distribution doesn't mean that every time it will be a circle. Your distribution can also be like this. Then you try to go there. Our distribution can also be like this. You can go there because here you have more data points, right? So it can be, keep shifting to find the balance. Okay. So that's the point I'm trying to make. Okay. Now, number of groups you can decide. That is also another discussion I will do. But for now, the idea is this. So I'll show one more nice image and you try to understand that what I mean by saying this. You have two types of cluster, right? One is intercluster. You see here, to use white color. Intercluster, and here it is intra-cluster. Intra means within cluster. Okay. You know, right? Intra, very famous. Intra-LAN, interLAN, intercity, intracity. And this is across clusters. So if you see here, within cluster means within a cluster, you want to minimize this distance between each data point. You try to find a cluster in such a way that within that cluster, data points distance are minimized. That's the objective. And you want to maximize this across cluster distance. Why? So that the separability is highest. So you want to maximize this. I'm writing again. And you want to minimize this within cluster. Here also we'll say within these guys, I'll minimize. So that's the, I would say in a layman term, the beauty of this algorithm. But how will you do it? Okay. So to do that, you have a step-by-step algorithm in place. Okay. Now steps to do. So let me talk in steps. Steps for finding, or maybe I can say K-means algorithm steps. Okay. So there are, few steps, guys. Number one, specify number of clusters you want. Specify number of clusters. Okay. So for now, I think starting this is an user input. means you will tell in the model how many clusters you need. Okay. Generally, people say 3, 4, right? K equal to 3 or K equal to 4. So this is more like, the modeler will give, right? Who's building the K-means clustering model. Then second step says initialize centroids by first shuffling the data set and then randomly selecting K data points for the centroids without replacement. Okay, so that can be any weird K centroids, means that's the first one. So you are selecting K data points for centroid without replacement, means you are shuffling the data set, and you are trying to find any random K centroids. Okay. Now in this diagram, if you see, there are 8 data points, 9 data points, 8 data points, right? The model has randomly selected this as the centroid for cluster 1. Can you see that? And this data point as centroid for cluster 2. I have only taken, 2 groups, 2 cluster here. Clear? That's what I mean. So here, this red and green represents the cluster of within the data points. Okay? Clear? Now, point number 3, what you will do? Now you will assign all the points to the closest centroid. So as of now, all the data points are like, okay, so you will tell me here that, okay, you tell me who is my boss. So how will you find the boss? You will assign all the points to the closest cluster centroids, right? Someone has to go to some boss. Okay. So here idea is that you will find the Euclidean distance, right? And try to assign. Now you tell me this is closer to this one or this one. You tell me. You find the Euclidean distance, the C1, right? So definitely this is not closer. This one is closer, right? So that's why you assign the centroid to the closest point, assign all the points to the closest cluster centroid, and then you realize that you have another image coming as, right? Can you see that? Now, I think everybody will be okay with this coming to this guy, right? Except one, I know you might be thinking what's going on there. So this is closer to this. You also know that these guys are closer to this, but we have a doubt that whether this is closer to this or this, right? You can clearly see that it looks closer to this. Okay. But obviously you will not be doing like looking at like, who is closer by doing eyeballing. You do a maths, and the maths is that you find Euclidean distance. Okay. So it's not like you are doing just looking at it. So what I'm saying, Anthony, yeah, that's why please pay attention. What we are saying, assign all the points to the closest cluster centroid. The meaning of it, this is my centroid which I have randomly assigned. I was talking about this particular data set, right? Tell me, is it closer to this guy or this guy? There are 2 centroid, right, for this point. Which one it is closest to? So C1, that's why you have assigned C1. So all these guys have been assigned to C1. All these guys have assigned to C2. Now this guy is a little controversial guy. As of now, it is also assigned to C1, but, right, are we going to do something about it? Clear? So now you can clearly see that now the centroid itself doesn't make sense, right? Now this is we have calling centroid, right? But it might be possible that centroid might shift somewhere here. Okay. So once we have formed the clusters, right, you have to, you might have to recompute, and that's where I'm telling it's an iterative process. Recompute the centroids of newly formed clusters. Recompute the centroids of newly formed clusters, and again finding the mean. So this is like using the mean. You have to recalculate this centroid again. So earlier you were just assigning one data point as the centroid. Now you are going to calculate the centroid again. If you look intuitively, guys, now you might feel that for the green, I think centroid should come here, somewhere here, right? That's where more balance you will find with this. So this is your cluster one, guys. Can you see that? So centroid might look little bit here and here, right? Depends on how we are getting, and I'll show the image. And for the green one, please pay attention. Green one definitely centroid C2 doesn't make sense. It should come somewhere in the middle, guys. You agree? Everyone here? So if you try looking at, and the algorithm gives you a new centroid, and I was trying to do a more like a by gut feeling, but see, more or less, I was right? So this is the recomputed centroids. It will never come like this when you recomputed centroids. Initial centroids were selected randomly by the algorithm itself. So you read this point. Initialize centroid by first shuffling the data set and then randomly. So it's being random. We are not selecting it. Randomly algorithm picks something. It's written in the first second point. Okay. Then what will happen, guys? Once you have recalculated the centroid, okay, then again, right? Then again they are going to repeat it. Means they'll keep moving it around. So they'll keep connecting, again calculating the distance where it should be, right? If every data point within the cluster is same or not. So that's the exercise it does. Okay, that's the exercise it does. It doesn't stop here. It will repeat its step to fine tune the cluster till the time it doesn't find a better cluster. So that's where it will stop doing. Okay, so let me show you one more nice diagram, and you will love it, I guess. Now this is how the step looks like, right? So if you don't look at the final one, if you just look at the first one step, right, you will realize that they are first trying to find the clusters. Like this is my, one group. Can you see the blue dots? Hello? So first they thought they will divide like using this plane, right? So two clusters. Everybody please pay attention. Then what if I try dividing like this? So then they divided the data on the basis of similarity again, saying, okay, maybe this can be my two clusters, right? Look at that, how it is changing every time, right? And then it fine tunes, see? So earlier, if you see the cluster points were like this, then the cluster has moved. If you are paying attention, don't look at every steps. Please follow me here. The cluster has moved somewhere here, see? And the blue has moved here. So I think earlier it was here and then it has come here. Guys, can you see that? Somewhere here. Then they realize that what if I move this guy to this completely, right? All these guys are more closer to this. Listen to me. All these guys are more closer to red. So that's why it becomes all red. So the cluster definition has changed. Now what they're doing, they're fine tuning a bit. Can you see that? So now this cluster has to go somewhere center. So that happens in the next. See? So cluster is coming in more center. Then again, this has also come little more in the center. Then they are, trying to do more fine tuning little bit. And then finally becomes your cluster. So one becomes this, right? See, there are only two clusters, but look at the beauty. You might have thought the grouping is being done, right? But see how they evolve to find you the two fine-tuned clusters. So that's why they start randomly. They find the distance, then they update the cluster groups, right? As you can see here, to fine-tune, and fine-tune. But the steps remain the same. First, they will assign something to as a centroid, calculate the distance, right? And then, recompute the centroid, again calculate all the distance from all data points, distance from the new centroid. If they find that, okay, we have to move to some other place, they'll move. Clear? Now I'll talk about some key applications, real life applications. Already I've given one, but maybe I'll just give you a few pointers around it. So real life applications of K-means clustering. Okay, so number one, customer profiling, right? Also known as customer segmentation, market segmentation, more or less related to customer segmentation, document classification, right? So different documents can be classified into more 4 or 5 clusters. So document classification, so there they use OCR, which is optical character recognition, to understand the document's nature, and then on the basis of similarity, they group into clusters. Okay. I think there are a few more like geostatistics, understanding the similarity of geologies, or finding astronomy, right? Astronomy is also about finding patterns. So yeah, astronomy is another big area. So where they do all those kind of understanding the planetary positions, and making some conclusions based on the similarity and patterns, right? Although they also try to predict why, and why can be anything that you can change anytime. Yeah, that's all from my side on this. Maybe I'll talk a little bit more about how to also decide number of clusters, because sometimes people think clusters is like I can always get. It's not like this. What are the cool things about k-means clustering is that you can actually stop uh, going intuitively that how many clusters you need. You can also go by using machine learning concept. You can also find the value of k. So let me give the heading. I'll come back to run. If I can put the heading, finding the value of k. You can also find that by using the concept of elbow curve. So let me explain that. So using machine learning only, you find the how many k I should pick. So you can plot the elbow chart. So if you have seen an elbow, right? So this is your hand, but can you see this is known as elbow? Okay. So this elbow chart is just similar, right? Okay. So when you are trying to see that what is your, sum of squared errors, right? And using that, you can see that if you take two clusters or three or four, right? Till the time it keeps adding value to it, you're trying to minimize the error and error, right? So you will go with more number of clusters. Ideally, you have to find an elbow here in this chart, to be honest. So if you try to fit an elbow here, right, you will realize that wherever the curve for the elbow comes, right, that will be your number of clusters. But how do we decide that? So if you have a sharp decrease, more like a very fast decline in the value of this y, which is WCSS, right? That is mostly your sum of squared errors driven, right? Sum of square error. If it decreases the error drastically, you will keep increasing the number of clusters. The moment it starts getting into a flat line kind of concept, just like this becomes like a flat line, you stop adding more. Because even if you take, tell me one thing, if I take, let's say this is 5 clusters, and if I take 8 clusters, do you see any much difference in the error? Guys, come on. So why do you want to add more clusters to your data? Hello? Does it make sense when I say this, guys? There's no point, right? But if you see, if you take 3 clusters and you take 5 and if you draw a line, can you see that how much error you have reduced, guys? Are you feeling it? And if I say I have taken 2 clusters, right? 2 though you have to anyway take minimum. So 2 to 3, you can also see that you have quite a lot come down. So that's how you can do this. Clear? So testing different number of clusters and measuring the resulting sum of squared errors, which is SSE, and choosing the k value at which an increase will cause a very small decrease in the error sum, and increase will cause a very small decrease in error sum, while a decrease will sharply increase the error sum. So this can be a little confusing language, but that's how it is. So guys, what we are trying to say, please understand, if you go from 5 to 6, so I'll also give you the color coding. If you increase k, increase means what? Increasing k will cause a very small decrease in the error sum, right? If you go from 5 to 6 or 5 to 7, do you see any big decrease in the error sum? No, guys, correct? While a decrease in the k, while a decrease k in k will sharply increase the error sum. So if you go backward from 5 to 4 or 5 to 3, can you see that? Your error sum sharply increase from here to here, guys. Can you see that? Look at this green line. That is the second part of the statement. So in the middle of that, can you see that? In the middle of that, in the middle of this, you find your optimal cluster. Are you feeling this? That's where the language is. That's where you find your optimal number of clusters. So far with me, guys? Clear? This is your optimal number. What is this in this case? 5 is the answer. So you can take it from me. Stopping criteria for k-means clustering. Stopping criteria for k-means clustering. Okay. So there are essentially, 3 stopping criteria that can be used to stop the k-mean. Number 1, centroids of newly formed cluster do not change. So I'm saying that your centroid is fixed, it does not change. Second, your centroids are not changing and your points remain in the same cluster. So nobody is changing the party here. Okay, that can be another one. And third, you can also set a maximum iteration. So suppose your algorithm, you don't want to run it forever. Just like in decision tree, you set, right? How many leaves you want to stop at or how many decision tree you want to stop at in random forest. Likewise, you can do maximum number of iterations and then you want to say, boss, stop it. I don't care. So in 3 ways, you can stop the k-means clustering. Make sense? Clear? So these are your stopping criteria for k-means clustering. Okay. I'll be going up and do the hands-on and let me know once you have the data, guys. Okay, you try loading that data. In the meantime, I'll also get back to you. So I'm also loading the data. So we have those typical import. Let's do it. Import numpy as np, right? Import pandas as pd. Import os. Import matplotlib dot pyplot as plt. Import Seaborn as SNS, right? I might be using a bit of Plotly also in this. So you can import Plotly as py and import plotly.graph objects objs as go. So someone can say hi on Q&A. I can share all these libraries which we are importing. And here you go. Okay, Aryan has shared a big list. Okay, so you should also know, Aryan, which one we are using where, right? Now, let's load the customer data, guys. So df underscore customer, and it's a mol data. So let me read it. What happened? I'm not in this working directory. Where I am? I'm in, yeah, and data is also there. So what is happening? It was not in the right folder. See, now it came. Okay. This is the data, guys. Can you see that? So you have gender, age, annual income in $1,000, and what is your spending score? Look like more like a customer profile, right, guys? Agreed? Now to plot scikit-learn we need. So one more you need to build the cluster, and that is import k-means, right? So this is something you should also get it, and then we're good. So guys, first thing first, I'll teach you how to make a basic clustering, right? Basic clustering on 2D. So you can actually use more than 2 variables. But for now, let's understand age and spending, and then you can go from 2D to 3D, 3D to n variables. That's up to you. First, get a good idea about clustering by looking at this. So you know that the columns are this. Maybe I'm going to pick only age. So I'll say df underscore customer. So I'll select the columns, age and spending. So I'll just say age and spending score. I'll take this guy out. and should be good. See, this is my data, guys. Okay. And if you try to plot a scatter plot to understand the distribution, all right, guys, you know how to do it. I don't need to teach, but I'll write plt.figure, or we can use plt.subplots, and then you can write fixed size equal to, let's say 15,7. Yeah, looks good. I think I can keep it 15,6. Yeah, and maybe I can keep 12,6. I'm just trying to get a good shape. plt.show. Okay, and then within this you have to use plt.scatter. You know, you have to use x equal to age, y equal to spending score. Data you already know, you have df, and size of the scatter can be 100, right? Age, spending score. Okay, cool guys. It's really bold. Now better, everyone. So you might think that, okay, my groupings can be, you know, like, you know, people can think of different types of clusters here. If you are talking about two clusters, you might be thinking, I'll assign this to one, assign these guys to be two, right? Can you think like that, right? Someone can say, okay, Akash, can I do something like this? So how do you do that, right? Means clustering is all about that, right? So I think the first thing first, we need to decide the K value, right? And give some levels to the chart. So first, let me give the levels. So title is, you know, age versus spending score, distribution, plt.x level, and it can be age, plt.y level, and can be spending score. Yeah, see, now we have to decide the K value. Why we are deciding the K value? So that, you know, we can assign how many clusters we need. For that, I will use the elbow chart. Right, guys? Remember? So remember, elbow chart technique plots the different cost error function. As K increases, average distortion and variance will decrease, right? Cool. And this is some funda, right? The same thing. Now, guys, first need to create the data for elbow. So we'll call elbow df underscore customer, and then I'll pick only two columns, which is age, and I'll check spending score, right? This one. Perfect. And now, guys, I want to get only the values. So I'll take, you know, all of it, only the values. This helps you to get the 2D array out of it. Okay. And trust me, you can get the array in multiple ways. See, this is a 2D array. It's the same data. If you see 19, 39, 21, 81, 26. Let me come down and show you. It's the same data, guys. The only thing here is that you are getting a two-dimensional array. Remember, I taught you, so you cannot say no. It's starting with 2 square braces, ending with 2 square braces. So it's a 2D array. Are we clear, guys? See, ending with two square braces. It's a 2D array. That's a requirement for the plotting. Then I want to keep an empty list called inertia. So this is an empty list. And now I'm going to go one by one. So I'll say for n in range, I want to go in a range of 1 to 11 so that I can plot as high as 10 clusters. I'll use the algorithm to calculate the elbow, and I'll say k-means, and I'll use n underscore cluster that is coming from scikit-learn. I'll put n here, and I'll say init. This is to initialize. K means init means initialize. Remember that oops, might have heard a little bit on oops. Init means initialize. So that's your initialization of the K means. And you want to go till 11. So last is 11. Max iteration, I think, right? I'm putting 300 iterations, which is quite enough. Tolerance is more like how much accuracy you want to maintain, like till where you want to go. 0.001 delta is fine. Random state is 45, again to set the randomness of the sample algorithm is EK Euclidean, so EK-LAN, right? So now this is your algorithm, okay? And then you will fit it to your data, which is your 2-dimension array, and then you will append the values you are calculating to this empty list, which is your inertia dot append. You have seen me doing append to a list, and once these values have been calculated, you can keep appending to your inertia. LCAN, not ECLAN. So you will see that inertia has taken your value of the cost, right? Right, and that's where you will also get the cluster. So let me do it. Let me plot the elbow chart. Okay. So again, I will use the same concept of it, plt dot subplots. Maybe why don't we use that, right? Why to waste time? Let's use this now. Now we don't need a scatter here. So I'll say plt dot plot. I need a line chart, and then I will create np dot arrange. Okay, 1 to 11 inertia, and line marker will be O. Okay, this is to just align with the number of clusters. Okay, so this np dot arrange, guys, what it does, it creates a value from 1 to 10. Okay, and see, so it gives you like, the value of those data points, right? 1715135, right? Can you see that? 1715135. So are you feeling that you are getting an idea about, hold on, right? You are going to put some kind of this, right? No, 1 to 11 is that, remember, you have created, what is the length of this? Hold on. What is the shape of this? It's a list. So what is the length of this list? You tell me. 10 data points, right? So inertia is just the y-axis. You also need x, right? So that's where I've used this np.arrange. So this is your y. This is your x. Line chart, no? So we need to, so that's why I needed an x also, no? Like 1, 2, 3. Now definitely this age will go. It will become your number of clusters, and you will start getting to making sense now suddenly. So that is more like your data manipulation to update your x-axis, because inertia just gives you the y-axis, which is your cost. Now you will start seeing a lot of difference, right? And title and I can go, it can be set here, elbow chart for optimal number of clusters, isn't it, guys? Now I also need a line to it. So I'll superimpose plt.plot. And again, it will be same thing, only the marker will change. See, so here marker will be a line this time, and you will see magic. Look at this, right? Isn't it the chart I showed you while I teaching you this, right, guys? Okay. Now, inertia. Okay. So, Indrani asking what is inertia? Inertia is nothing. Inertia is your cost, which is being calculated from this algorithm, scikit-learn k-means. So now if you look at let me show you the documentation. Hold on. Right. So if you see here, I've written, init k-means, let's understand it. Okay, hold on. See, init means you have more like to initializing the method for your solving. So k-means is your algorithm you're using, clear? Init is clear. Right now, what is it? N cluster, how many cluster you want to take? So that's why you're plotting for 1 cluster, 2 cluster, 3 cluster, and what is your cost? Okay, now come back. What is your max iteration? Maximum number of iteration for the k-means algorithm. I talked about it, right? So that's your max iteration. N init is what? Number of times the k-means algorithm will. If I'm running a for loop, for how many times? If it is 1 to 11, it will start from 1 till 10 only it will run. So total how many times I'm running the k-means clustering? For 10 clusters, right? So it will also has to match this, right? That's why I've written the same thing, 11, 11. So this means it will run for 10 times. Okay, and that's where if you see, you will see that I have given number of cluster 10. So it is solving every time, my dear. When you have only 1 cluster, when you have 2 cluster, when you have 3 clusters, every time it will solve and calculate the cost. Model is doing that. I think rest everything you can handle. Simple, clear? Inertia is an outcome of this, right? Inertia is more like your cost. So don't worry too much on it. Okay. It's your cost. Okay. That's sum of square error if you are trying to divide it into the syntax. Okay. Now, once you look at it, guys, you can clearly see that I think ideally you should have minimum 3 clusters, right? See, between 3 and 4, see 4 and 5 same. 3 and 4, you have some delta. I think let's start with k equal to what? K equal to 3. First, we can start with k equal to 3, guys. You agree? That's correct. Very good, Indrani. You got it. Each data point on this elbow chart is one iteration with the cost, right? So every time you run it, you get a cost out of it. Let us start with k equal to 3. So again, it's the same algorithm. I'll use k means 3 means 3 clusters, k means, and then I'll copy everything from right. यहाँ आपको 3 clusters. I think number of iteration can be 3. Maximum is fine. Tolerance is fine. Random state is also fine. Everything is good. Okay. Now you will say algo 3 dot fit on your data, which is your elbow, which is your array. Sorry, this is your whatever it is data frame. I think elbow was your array, right? Let me print and see. Yeah, it's an array. And then you can find, so this is your done, model is ready. Labels 1, you can say algo 3 dot labels underscore and centroids. See, centroid will be cluster centers. So guys, you can see that labels will get that, first data point goes to cluster 1, 0 means 1, 1 means 2, and cluster 2 means 3. So there are 3 clusters. That's why it starts from 0, 1, 2. And if you look at the centroids, you will see 3 values. Can you see that? The value of centroid 1, value of centroid 2, and the value of centroid 3. Yes, cool. You have everything to plot the clusters. So I'm going to, guys, now plotting the clusters with centroids. Okay. So again, plt dot subplots fixed size equal to 15,7. Maybe I'll keep it 12,6. The same plt dot scatter. So you already have the data elbow, 0, elbow, everything, and 1. C can be your color, can be your labels 1, and C map can be bodies. There it is. Right, and then I also need to plot the centroids. So I'll use centroids :0, centroids 1, and you can give the marker like X. Yeah, good observation, Prava. And color equal to red, 100, and bingo, done. See, interesting, guys. Can you see this? Remember, the data distribution was looking like this. So this is what you had, and when you try to look at it, guys, can you see it has created a cluster like this. Another one is little different, something like this it has done. It's a real data, so you can expect clusters like this. And the other one is this. And the centroid makes a lot of sense, guys. As you can see, center, center, and center. Because of the outliers on this side, it has shifted towards little bit this. Else it could have been here, right, guys? Agreed? Same story with this one. But see, this is real data, and you have 3 groups of people basis your age and the spending score. So how it is dividing, guys? Those who are spending between 60 to 100 and those whose age is less than, hold on. So the demarcation is like this. Anybody whose age is less than 40 and spending score is 60 is one cluster. And you are saying that I don't care about the age. I only care about the spending score. So anybody who is having 40 to 60, roughly, you have one cluster, right? Another line coming, guys. Correct? Hello? You agree? So another line is this one, 40 to 60, and anybody who's spending score is 0 to 30 is another cluster. See, so beautifully it has classified. That is with 3 clusters, right? But if you want more finer cluster, I think you can go with, so I can just see, you have to very smart. You have to just copy this whole thing and I'll paste it. And now what I'll do, I will say, let's go with 4 clusters. So you have to do nothing. You have to just change here 4, make this guy equal to 4, make this 4 so that you don't overwrite. Let the model solve for 4. Create the level for 4 by calling it 2. See, I'm just repeating the step. You could have written a for loop to do that. Trust me on that. Okay. So let me run it. Ta-da. See, now you can see there are 4 cluster points. You can just use same data, but you have to use levels as 2, centroids as 2, 2, right? I don't want to. See, now it makes a little more sense that now you have divided this part. Then again, so see, I thought so. Can you see that? So now it has divided like this: 1, 2, 3, and this whole thing is like a 4 cluster. Interesting, guys, and it seems intuitive also, right? So you know that who will be part of your which cluster and how you can target that. That's all from my side, guys. So nothing else on this. You can try to get more in details of it, but I think I'm done from my side on the K-means side. Segments are already there, no? So if you see, you have to just join the data. So you have this data set, right? You have an array here, right? So what you have to do? You have to use label 2 and assign it to the elbow data, right? So maybe let me do it. So you have your elbow data, correct? And you have an array. So you can convert these two into a pandas frame and just, concatenate, right? That too by axis 1, right? So you already have this guy. You know how to convert an array to a pandas data frame, right? So what you can say, df levels for 4 clusters, right? And you can say pd.data frame and your, I think, levels 2 column equal to cluster. Okay, guys, this is my, and now I'll do pd dot concat, and I'll say, remember I have taught you these things, and you have the data df underscore customer, and you also have this guy df levels for axis 1, and that will be a combined thing, right? df customer with clusters, right? Correct, Indrani? So you have to do a little bit of data preparation, which I expect you guys to do it. Now you can clearly see that these are your customers in which cluster you are. Now interpretation I did. So while I was drawing this vertical lines, what is the meaning of it? So vertical horizontal line. So anybody who is in the age group of 65 plus and spending score of 60 plus and age group of 40 or so, that's your one group. So you can use this for selling premium products, right? So their spending score is really high. So you can always target this customer for like some premium product, high pricing, high volume products, right? Premium means like selling some goods, jewelry item or whatever, XYZ. But if you look at these guys who are part of the bottom one, can you see that? Irrespective of age, their spending score is really less. So you have to give some offers here, and that too on like a low price products, right? LPP, right? So that's the interpretation. So you know that whom you have to target, right? If you don't have this cluster, you might be giving offers to these guys who are anyway premium customers. They keep buying things. They are like people like me who are spendthrift. So you don't need to give them any offer, and you have to position premium products to them, right? And then these are your like mid-level kind of customer. Okay, you got it? So that kind of interpretation comes from the your clustering algorithm.
we will basically discuss about the recommendation system theory. What exactly recommendation system is? Okay. So there is a quick disclaimer for the session, guys. I know it is quite strange, but yes, it is. So, do you think that if you will do this project as a recommendation system, immediately you will be able to take job in any of the Netflix, like suppose the Netflix company, and you can start the recommendations there and all that stuff? Do you think so? That this one project will give you the entire knowledge of the recommendation system, and immediately you will be able to build a model? No, right? That's what, today's project is recommendation system. It's not necessary that whatever we will discuss, you are able to get 100% of it. Maybe some will get 80%, maybe some will get 70, maybe some will get 50% also. Why I'm saying so? Because we even know like what is the backend going on. In PC we know what is the backend going on, but in recommendation system, guys, actually we do not know what is the backend going on. Trust me, it is just we know that okay, I'll use this and I'll get some recommendations, but how actually we are getting that, we don't have any idea, because there's a very very advanced mathematics behind, which we are not going to discuss. Why this concept is scheduled for you to get an basic idea of how actually the things works, what is the deep behind mathematics, and all that stuff is something which is not in your control as of now. With the future, when you will come to your AI part, because it's a very basic concept which we will discuss today. In AI you will try to enhance this with more kind of concepts and all that stuff. Clear? Okay. What do you mean by recommendation system? Everyone uses Netflix, everyone uses Amazon or Flipkart or Spotify or your JioSavan, means any kind of music apps, any kind of movie apps, any kind of online purchase app. You get suggestions for some items. So if it's a movie app, you will get suggestions for the movies. If you have a product app, you will get the recommendation for the product. If it's a bookstore, online bookstore, you will get the suggestions for books. That's what they are recommending you, some product. They are recommending you some entity. How do they recommend you? How they know that what are the things you like? How they know which movie you will prefer more, or which type of book you will refer, or what kind of product you will buy from Amazon? How they know that? Even if you have noticed, like I have noticed a lot, if I'm sitting in front of you and I'm talking about something like suppose I want to go to a beach, like we are discussing about our trip on a beach, suddenly my Instagram will show me reels based on that beach. Have you noticed this thing? Even if you're talking about like randomly with your friend sitting there that I want to buy a watch, something like that, your Instagram or any other app will actually try to recommend you watches. Have you noticed this? That's what recommendation system do. So it basically predicts the ratings and preferences of users on products. So that product can be anything. Either it could be a song, either it could be a movie, either it could be a book, or any Amazon, Flipkart, or Myntra product, anything. So basically, the primary application, or we can say, the primary application of recommendation system is to find the relationship between user and products. So primary application is finding a relationship between user and products. And why basically are we finding it? Why we recommend? Like why these big companies are recommending you something. What is the reason behind it? Marketing, okay. Sales, exactly. They want to sell more. They want, like, if they are recommending you the songs which you like, ultimately the engagement with that particular app will increase. Because if they are recommending you songs of your preference, you will listen to that frequently, you will use that app frequently. Or if they are giving you some good like comparative to Netflix or Amazon Prime, the app which is giving you more relative movies you like, you're going to use that platform more, right? So they are finding the relationships to maximize the user product engagement. Okay, we understood what exactly recommendation system is and why it is, right? So I hope no examples is required, but still I'll give you Netflix or Prime for movies, Spotify or Geo7, like any other also, for songs and many more actually, right? Now the thing is how this recommendation is done. We know what it is, we know why it is. Now how it is, the question arises is how we are doing recommendation system. So this recommendation system is, guys, broadly classified into three categories. What are those? The first is known as collaborative filtering. Collaborative filtering. Then it is content based. The second is content based. And the third one means hybrid. Hybrid filtering. So these three types of recommendation systems we are having. Okay, now let us discuss about this one by one. So collaborative recommendation system. So from the name itself, collaborative. What could be this collaborative filtering? So from the name itself, collaborative means collaborating with others, right? Collaborating with others. Collaboration. That's what the English meaning, right? Now try to answer that what could be this collaborative system. Collaborative type, we are collabing, or we can say we are making collab with others. That's very basic English meaning. Now whom we are collabing with? So what the thing is, this recommendation will see. Now see, this recommendation system will say that if I am having a person A, okay, I am having a person A, and one more person I am having, that is person B. They have read, or let me take off movies only because we are doing the project based on movies. So they have seen, both of them seen suppose Pathan movie, right? Both of them have seen Pathan. So what is the importance of Pathan is, one, obviously SRK, yes or no? And the second could be action. If guys you have not seen, basically Pathan is a movie of a Shah Rukh Khan. So SRK means Shah Rukh Khan here. And the second Pathan was an action movie, right? Now, okay, both have seen Pathan and both has given good ratings to this movie. Like user A also liked this movie a lot, user B also liked this movie a lot, and they have given a high ratings to this movie. Now, according to collaborative, what it will do is, now when it comes to a movie, another movie, Animal, suppose, Animal, it's a action movie. And when it comes to Donkey, it is a movie of Shah Rukh Khan. SRK again. Now your collaborative, what it will do is, if user A has seen donkey, it will try to recommend this donkey to this also, user B also recommend. Why? Because A and B were having similar kind of interest. Similarly, if your B has seen animal and given good ratings to animal, your recommendation will recommend this movie animal to user A also. Getting the point? So collaborating with the users having similar kind of interest. Now what I'll write here is, it makes personalized suggestions to users by leveraging the preference and behavior of other users. Clear everyone? Any doubt? Now this collaborative itself is further of two categories. Further it is two categories. One is user based, one is item based. User based and item based. Now when it comes to user based, tell me what could be it? The example we just look now of SRK and this movie is a kind of user based, because we are recommending, or we are doing the collaboration from user to user, right? If user A likes this, user B likes this, and they have the similar interest, so we will try to recommend movies same to both of them. So that is user based. So example we took is of user based. Recommendations are made by finding users who are similar, very good Akhil, to the target user. Now what could be this item based then? Think what could be this item based. So here basically we discussed that if both have the similar interest of Pathan, which was two importance, SRK and action. Now if user A has seen a movie of SRK, it will recommend you to user B. Why? Because it was seen by user A. That's the one option, user U. But now if user A likes a SRK movie, so whether anybody has seen or not, it will try to recommend all SRK movies to the system or to the user. So based on users' individual interest and also on the item. Like if another example of Amazon, today I was seeing, suppose I was looking for an iPhone or an iPad. Now what will my recommendation system will do? That I have seen iPad today, it will try to recommend me things which are related to that iPad. Maybe the charger, maybe the pencil, Apple pencil, maybe the case of it. So like if you have noticed in Amazon, like suppose if we are finding anything, like suppose I found an iPad here, so all the description of the iPad will be there. And when we scroll down, there will be an option where they will add 3 more items and give you certain price. Have you noticed this thing? So that will be basically iPad, suppose with its cover and a pencil. Have you noticed this thing? They will try to recommend you 2 more items which are related to the item you are looking for, so that you will get a proper interest into the full complete set and then will recommend you. So this basically, I was looking for an iPad, that was my interest, but they are recommending me the cover and the pencil as well. Getting the point? Item based. So based on the items I am interested in, it will try to recommend me. So in item-based collaborative system, recommendations are made by finding items that are similar to the ones the user has already liked. Not only liked or interacted with, whatever it could be, right? Now I'll give you like one more example here related to movies, because we need to do movies only. If a user liked movie A and B, movie A and B, both movies are the one the user liked. then if movie A and suppose the third movie C have similar characteristics. I'm giving these examples writing so that you cannot, you don't need to go to the recordings back. You can easily read the notes and you can recall what we have discussed. So instead of going through recordings again and again. So if movie A and C have similar characteristics, the system might recommend movie C also. So here, let me write one more thing, key features. It is user-centric approach. So let me write it, otherwise I'll forget. It is user-centric approach. Okay, guys. So we discussed about collaborative filtering, in which one was user-based and one was item-based. Now we will talk about content-based filtering. And hybrid is mixture of collaborative plus content. Hybrid is mixture of that. Okay. It was user-centric approach means based on users it is giving, right? Okay. Now let us come to another type, which is content-based. Content-based filtering. Content-based is very, very similar to item-based. So it's a type of recommendation system. So it recommends items to users based on the attributes or characteristics of the items and user preferences. Here we are actually not recommending based on any other user. We are just recommending based on the past idea, the past data, or the past movies or the items or something what we have bought or what we have seen. So according to that, our past data, it will try to recommend us the things. So basically, movies could be movies could be recommended based on several features like genre, actors, even directors, release year. Like we use now what are the latest movies which are released. So if I like a movie which is just released, so most probably I will like if a person who loves to see the latest movies every time. So according to that. Okay. Item based was basically a type of collaborative, right? So there could be interactions of user as well. That is possible. But when it comes to content based, there will not be interaction of users at all. There will be only interactions based on my previous data. Clear? So here, what is the key features? Personalization. Because on my interest only, the movies will be recommended to me. So this was the basic idea of the theory of recommendation system. So for content based, I'll give you a diagram as well, which will help you to understand it. So you are a person here. So there is a book basically, which is read by this person. So there is basically a book which is read by this user. Okay. Now, whatever the similar articles we would be having, what would be similar articles we would be having, that will be recommended to the user. Clear? Okay. I think now it is clear for everyone. Now let us come to SVD part. Singular value decomposition. So before even this SVD, let me talk about one package we are having, which is known as surprise package. Deepak, item cold start issue is basically when your recommendation system is not able to recommend things. So that could be due to several reasons, like maybe there is a sparse data, the data is not completely, filled, or there could be any other reason also. So that is the item cold start issue, that your recommendation system is not able to recommend anything to any user. So let us talk about this. What is surprise library, or you can say package? Like, library would be the more appropriate word. So this is a good question actually, which could be asked you in your interviews also. So it's better to understand this. So we will use this surprise library, like we have other sklearn libraries. Like in sklearn package, we use the library, different libraries. Similarly, we have a surprise library which is specifically used for recommendation system. And in our project also, we will use this. It stands for simple Python. So don't ask me how, ma'am, this full form came. Okay, so it's something which is already there. Simple Python recommendation system engine. That's what the full form is. So surprise, we will also use this, is a Python scikit building, scikit-learn, and analyzing recommender system that deals with explicit rating data. So it is basically a library which is used for recommendation systems, and it is very good to analyze the ratings the particular user or the particular movie got. Clear, everyone? So we will use that for our work as well, for our project. So we'll do. Now comes to SVD. SVD, you can think it is as a dimensionality reduction technique. Like you were having a PCA, you were having LDA, when we were having some kind of data in a data frame or anything else. So we do dimensionality reduction there. Similarly, SVD is also a dimensionality reduction technique for recommending things. Now, how? So what it basically do is, like, we use here SVD decomposition. Now don't get confused with this. SVD itself is a technique. Inside that, we will use an algorithm which also names as SVD. So don't get confused with that. That is known as SVD decomposition. So everybody knows the meaning of decomposition, right? It's a basic English meaning that we are dividing something. So what it basically do is, it will divide your complete matrix A into 3 sub-matrix: U, sigma, and V transpose. Now what is this? I'll talk about just a second. Right now, just understand, this will try to divide your this complete matrix into this 3 kind of matrix, and with this 3 kind of matrix, actually it is going to recommend you, it is trying to remove the unnecessary content and keep some content which is relevant and will recommend you that content here. Now, before understanding what U, sigma, and V transposes, you should know about what latent factors means. What does latent factors means? Okay, latent factors basically are known as hidden patterns in your data. Whatever the data you are having, so what are the hidden patterns inside that? So they may be, if we are talking about a movie data, so they may be the genre column, they may be the actor name, they may be release date, any kind of pattern. Only the thing is, we don't explicitly define this, that in my this data, this will be the latent factor. We will not do this. Our SVD model itself will find that hidden patterns from the data, and according to that, it will work. Only you need to understand is latent factors are the hidden patterns. This is just an example. We will not define it that genre will be our latent or actor will be. No, we are nothing to define it. We are just thinking that that could be genre column, that could be the actors column, or that could be the release date, or that could be any other pattern which is available. That work is of SVD to find that hidden pattern. Okay, now let us come to this, what exactly U and all that stuff is. U basically means is a matrix which tells you the relationship between users and latent factors. Means if I am taking the genre column as a latent factor, so my user will like horror movies more, or my user will like the comedy movies more, or any action movie. So U is a matrix which will find the relationship between user and latent factors, right? Sigma is basically a matrix, diagonal matrix of latent factors. A matrix where diagonal elements are 1 and other all elements are 0. That's what a diagonal matrix is. Either you can say 1 or either you can say any other value. So in our case, that is basically sigma 1, sigma 2, sigma, like suppose 3 by 3, other will be your 0. That's what diagonal matrix is. Clear now? Ho? Then V transpose. V transpose is basically the relationship between items and latent factors. Items means the things which we want to recommend. Like suppose I want to recommend some new movie to you. Now that new movie relationship with the latent factors. So using this decomposition, it will try like what is the behind mathematics going on. So this was the part where I was saying that there is a big advanced mathematics behind this. How this matrix is actually divided, how the latent factors are found by the hidden and all that stuff. That's what advanced mathematics comes into play. And you should not be aware about that as of now. Not as of now. If you like very experienced, it needs a very good experience if you want to understand the behind advanced mathematics. Okay, so as of now, just understand that decomposition, we are dividing our complete matrix into further 3 matrix that SVD will itself do. We don't know how it is going to find the latent factors. We don't know. Only we know that it will try to make 3 different matrix. One will be of users versus latent factor. One will be a diagonal matrix and other will be items versus latent factors. Using these 3 matrices, sub matrices, it is trying to recommend you something. Clear everyone? Now, after this, one more thing you need to understand is what is estimation score in SVD. Estimation score, you can say it as a prediction score which every movie will get after performing SVD. Like suppose I have movie A, I have movie B, C, D, E, F. So if you're talking about Netflix, there are many movies, right? We have lakhs, crores of movies. So every movie will get a score based on SVD. A number of score, we will get a score. That is known as estimation score. Highest estimation score basically means highest chances that that movie will be recommended to you. So suppose that I'm taking a range that estimation score highest means 10. So maybe this movie got 9.8 estimation score based on your data. So estimation score for different data will be different. Okay, it is not same for every data. Maybe B will get 7.6, maybe this will get 6.1, this will get 9.7. So estimation score. So if I want to find the top 5 movies I want to recommend you, so it will sort, okay, not it will, we will sort this estimation score values and we will take the first 5 values. So the highest estimation score means the highest chances that that movie will be recommended to you. Clear everyone? So it is known as the prediction score. also known as predicted score, or you can say it as predictions also, like your model, how much score, predicted score it has given to that. So high prediction score means high chances that the movie will be predicted or the movie will be recommended to you. Refers to a value obtained by predicting how a user might rate or interact with the item. Clear, everyone? So this was all the theory which is necessary, not necessary, but yes, it is okay to start with your project. Okay, so guys, this is basically the data file. So it's not in a DF format, like it's not a CSV file, it's a text format file. That's why we have opened it into a notebook. Now see how this data is all about. Here we have a movie number, which we call it as movie ID also. And this is the particular movie customer ID, the ratings the customer has given, and on what date the ratings is given. It's a real data, Akhil. It's not a toy data. Clear? So it's basically the first movie, the movie ID, then we have the customer ID, then we have the ratings the particular customer has given, and the date on which the customer has given. So if we find, like, so it's the first, like, try to understand, it's the first movie, then we have the second movie, then we have the third movie, then we have the fourth movie. Similarly, I think 1499 movies we are having. 1499. If I try to find it, let's see it will find it or not. That's why I recommend you, even I recommend you to not to try with this project with me. But guys, do you got the data, what exactly it is? Basically a movie ID, then we have a customer ID, then we have the ratings, what that customer has given, and then at the end, the date on which the ratings has been given. Okay, now come to the project. Mount a drive basically means that we are not explicitly loading our data. We are taking it from a drive. We are already having a drive in our system, right? Google Drive. So we are taking data from there. We are just mounting that drive here, and indirectly we are accessing that data. That's what mounting a drive means. Now, why we are doing it? Because sometimes the data, like this data, is very, very huge. Very, very in the sense, like maybe, yeah, you can see the shape of the data. It's approx in crores data. So if I try to explicitly load it from here, it is going to take even, I think, more than half an hour to just load this data. So instead, we will just mount a drive here and we will try to load the data indirectly from the drive. Clear the meaning of mounting a drive? And even guys, when you are trying this project, please don't try it over Jupyter, because in Jupyter you don't have the option to mount a drive. You need to explicitly load the data using read CSV, which will take a huge amount of time, and you need a very good RAM to your system. So also try this in Google. How we actually mount it? Either we can run this code. What does, if I run this code? Run anyway, it will take me to the, we can choose files, it will take me to the options which are present here, and according to that I can choose the file. This is one of the option how you can load the data. There is another option which is of this mount. How you don't need to write this code. Okay, you'll just go here, you will see the third option which is mount drive. Click on this mount drive. This code will automatically be there. So for example, if I'm deleting this code from here and then I'll try to click here, see, automatically the code appears. I don't have to write this code. Dismiss, and they are saying run this code. You are running this, connect to Google Drive, allow, let it run. Now once this mounted at all the stuff, wait for few seconds. You will get a drive option here. Get it. Now see, mounted, you will see a drive option here. Have you seen, guys, how this drive option came? Now I have already uploaded a file in the drive. You also need to upload this file into your drive. Now how to access it? You will scroll here, my drive. You will open the folder where your particular file is. So my file is there in the Netflix folder, and this is the data. So you will take copy path from here. That's it. Running this code, and in pd.read csv, you will just paste this path which you got from here. Clear, everyone? How to mount a drive and how to load the file? It's simple command pd.read_csv. Only the difference is you will paste this path over there. Now how we have actually loaded it? So remember, in the notepad we were not having the names of the column, we were just having numbers. So here what I have done is I have given headers, means we don't want any headers, and names of the customer ID. The first was customer ID and then was ratings, right? Use column 0 and 1. So if you remember, we were having a third column which is date column. So I don't want to use that because I'm not concerned the date when the person has seen the movie or something like that. So I have removed that column and I'm using only 0 and first. These are the index values. 0 means the first column, 1 means the second column, and I'm not using the third column, so I've only written 0 and 1 here. And then simply head command, using head command we have loaded it. Okay, now seen the data type. So customer ID is an object and ratings is in float. Okay, now we want, in case the ratings is not in float, in case, so we can use this command as type. Everybody knows about as type, right? So we will use this command to convert into float. So if it is not in float, as of now it is in float only, this many rows, this is the data set. Now see what we are, first of all, before doing recommending or before applying SVD, we need to analyze this data. We should understand this data. So we have performed several steps to understand about this data. Let us talk about them one by one. So here, this one basically means it's a movie ID here, right? It's a movie ID. So don't you think so? In ratings, wherever I would be having a nan value, that means that is a movie ID. In the whole data set, wherever I would be having a nan value for the ratings column, don't you think so? That value is basically reference that that's not a customer ID, but that's a movie ID. Getting this point? So number of nan values means number of movies we are having in this data. When I shown you on notepad how the data was, it was one column. Here was some customer ID, here was some ratings, and here was a date value. Remember? So customer IDs, and like that. Then we were having second movie and then several customers for it. Then we were having third, fourth, and like that. Yes or no? Now here I have done headers equals to none. When we loaded the data, headers equals to none is something we have done. That means these headers we do not want. These headers are included in the rows now, right? Headers are included in the rows. So movie itself do not have any ratings here, right? But customers have their ratings column. So basically this ratings column got nan value for that. So that means number of nan values will tell me the number of movies I am having. Now change the data type. We have checked the shape of the data. Now if I want to see that how many people has rated movies 1, 2, 3, 4 and 5, means how many movies got 5 stars, how many movies got 4 stars, how many movies got 3 stars. So that is the thing which we can do with the help of value counts also. See, if I do ratings of value counts, it will tell me na, these many movies have 1 ratings, these many movies has 2 ratings, these many movies has 3 ratings. Clear everyone? So this is one using value counts we can do. We can do it with the help of group by function as well. So if you're comfortable with group by, you can use group by, in which we have passed ratings and then the ratings column, and dot count function. So it will basically count the values. You can use group by. You can use group by with aggregate function also. Dot count or dot aggregate also. So this is the second method, and value counts will be your third method of finding this. Clear? Then if we want to calculate how many movies, so I already told that we will count the number of null values. So I have checked for the null values here, and you can see you have 4499. Okay, it's not 1499, it's 4499. We are having movies with the nan values. That means 4499 will be our movie count. Clear? Okay, then this code is basically, if I talk about this particular code, it's basically if we want to change any ratings column into float, but when I check the data types, it was already in float, so no need to change. In case we need to change, you can use this command of as type. Now, what I have done is, I have stored this number 4499 into variable movie count. Clear? So you can see movie count is equals to 4499. You can even manually do it like this. That is also okay. No issues, because you have already found it from above. But if you want to do in this manner as well, that's totally fine with you. So movie count. Clear everyone? What is the use of any unique command in any of the column? Not here, but in any. What is the use of any unique command? Yeah, n unique will give you the count of unique values. How many unique values you are having. So I was having one column customer ID, in which if I calculate n unique, will it tell me the number of customers I'm having? Unique customers who are giving the rating? Because the possibility is we have 4499 movies in total, right? So maybe there are multiple customers, like customer A has certain customer ID which is given. This customer A has given ratings to 100 movies. So 100 times this A will be repeated in my data set, right? Similarly, there would be another customer B who has given 1000 times, 1000 movies he gave the rating. So that customer will be repeated 1000 times. So if I use n unique command here, will it give me the count of customer IDs also? The unique customers I'm having? Okay. Customer ID, clear, like how many unique customers we are having. But have you noticed one problem, that in my customer ID, I also have movie IDs now. If I'm counting the unique values, it will count the movie IDs as well. So don't you think so we need to subtract the number of movies we are having to get the actual customers count? I'll just subtract the customer count from the movie count, because movie count is something we have already calculated. Now from this customer count, what I got, which also include movie unique movie IDs, right? Then if I subtract movie count from this customer count, I will get the actual customer count I am having. Clear everyone? N unique will give you only the unique count, whereas dot count function will give you the total number of not null values. So in our case, if 1 is repeated 5 times, count function will give it 1 is repeated 5 times, whereas n unique will give you the value 1 only, because 1 in the sense that only one unique value you are having here, no other unique values. Getting the point? So if I find the count of customer ID, it will give me the count of not null values. All the not null, even the customer is repeated, it will count it multiple times. So what exactly this is telling me? The number of times the ratings are given. So if a customer is given 5 ratings, means 5 number of times it has given the rating, so it will count it 5 only. If a customer has given ratings to the 10 movies, it will count it as 10 only. So 5 plus 10, 15, then so on. So number of times the ratings has been given. Clear? But again, the same problem here we are having. What? In customer ID, we again have the movie ID also. It will count the movie IDs also. But movie ID is not the ratings column, it's the NaN value there. So again, we have subtracted the movie count to get the actual number of times the particular ratings has been provided. So this is actual number of times the ratings has been provided. Okay, now come back to find how many people has rated 1, 2, 3, 4, 5 stars. Means how many movies got 1 star, how many movies got 2 star, how many movies got 3 star, and so on. So one method is, first method, like which everyone can understand, is value counts, because we have used this value counts a lot. Value counts means it will give you the unique values with the frequency of number of time it occurred. So 1 rating occurred these many times, 2 ratings occurred these many times, 5 ratings occurred these many times. You can easily sort the values by if you want, but I want to keep it as it is, right? The second method is using group by. In group by, you can use the dot count function, which will again give you the count of not null values. Then the third method is, in group by, you can use the aggregate function also. The difference between like this method and this method is, here it will give you only count, but here if I'll write dot sum also. So guys, I will not run this code because I have already run the code in sequence. It will break the sequence because after like a few codes, this Netflix datasets values I have changed a bit. So I'm not running this code, but yes, if I want to find the sum also, it will give you the sum values as well. So aggregate function means at one go you can find multiple things. But if I'm using just dot count, it will work with dot count only. For sum, I need to use another function. So aggregate means we are aggregating multiple functions together. That's a possibility. Clear? So I have used aggregate function in future code also, so do not worry. We will talk about that once again. So these are the 3 methods how we have found that how many or got what ratings. Again, we can plot it. So this is a stars. Please note that stars variable means it is this kind of data frame count. Now, if I want to plot a bar plot for this, we can do. So everybody knows SNS dot bar, everybody knows PLT dot bar, right? But we can also plot a bar plot like this. So I've used a different code to make you understand that there is another method of plotting a bar plot. What? AX equals to stars means the variable which we have created before, dot plot. The kind is horizontal bar, H stands for horizontal. The figure size is provided, some title is provided, and grid equals to true means to give the values of grid like this, the gray color grid. So this is, you can see the bar graph proper, and highest ratings is 4, means the highest number of movies got 4 ratings. Okay, now everyone focus. Now the codes are something which is little tricky, so you need to focus on the screen. Okay, proceed. Now in my data, it was like this: 1 customer ID, further number of customer IDs, number of ratings, then 2 movie, then number of customer IDs, then number of ratings, then 3 movie, number of customer IDs, and number of rating. This was the data set till it is 4499, it is repeated. Now what I want to try is that I'll create a one more column which will be the movie ID, and one which is present here, instead it should be present here. This row is for one movie, this row is for one movie, this row is for one movie. Similarly for second, this movie is for 2 movie, this is 2, this is 2, this is 2, then 3, 3, 3, 3, 3. So every row itself will have the movie ID instead of only one time the movie ID was present. Every row will have that movie ID. Getting the point? What actually we are going to try? We just want that every movie ID should be present in another column. So every row, if I'm talking about this particular row, it should have the movie ID here only. Instead of I need to scroll up and see what is the movie ID, every row itself should display one movie ID. Okay, now how we are actually gonna try it? How? Let's see. So first of all, what I have done is I have taken a Boolean format. So wherever I am having a true value, that basically means it's a NaN value, and NaN values were the movies. Wherever we were having the NaN values, that was movies, right? So pd.isNull command, pd.isNull helps you to find the null values, remember? Now I want to find the null values in the ratings column, and I have converted that into a data frame. That the null values what I got, I've converted back into a data frame. So wherever I am having a true value, that basically means it's a movie ID, and wherever I'm having a false value, that means it's a customer ID. So basically, why I have done it? Because I want to know the index values where I am having the. If I know the index value, I can easily fetch that. So to find the index value, we have done this. Let's see. Now see, I have filtered the data. Filtered means wherever my value of ratings is true in the complete data frame, in this complete rows, wherever the value of the data frame is true, please give me that particular indexes. So it filtered out my data and provides me only the true values from that column. Clear? Okay. Now if we check the shape also, yes, 4499 shape. We have checked the head, we have checked the tail, like normal. Then I have done the reset index. Everybody knows what is the meaning of reset index. Here our index values are like this 0, 5, 4, 8, 9, 6, 9, 4. But I want the index value to be original 0, 1, 2, 3. So what reset index will do? It will make a new column and fill this values, and index will be your 0, 1, 2. You can see like that. So index here, these values got one another new column, and index are resetted to 0, 1, 2, 3, 4, and so on. Clear? Okay. Now the working of a code is started. Now think that the first index is this. Second movie start at this index. That what it basically means is, okay, the first index is here, the second is 5, 4, 8 index where a movie 2 is present. Here movie 1 is present. That means in between this means 0 to 547, I need to fill all the rows with 1. Similarly, how many movies I need to fill to is 694 minus 548, but 548 itself is a second movie. So basically from 548, but here it is not 694. 694 means the third movie. It is 693 here. Till 693 we need to fill it with 2. Similarly, for third movie, we need to fill it from 694 till 2706. Yes or no? So what I got is that if I subtract a value from its previous value, I will get the number of times that movie is to be filled. How many rows I need to fill it with 2. So that is 694 minus 548 minus 1. These many times I need to fill it with 2. Right? So this is for the second movie. Similarly, for the third movie, it will be 2707 minus 694 minus 1. Clear, everyone? So this was the concept. This is the concept we thought that we can do. So I will get that these many times 1, then I can easily run a for loop. that these many times 1, these many times 2, these many times 3, and so on. But how we can actually achieve it using Python? Concept is okay, but in Python we need to do. So what I've done is, if in case, like, let me explain you with a small number first. Like, forget about this. Suppose we have index values like this: 1, 2, 3, 4, 5. We have index values like this. Now see, if I want to subtract 2 minus 1, 3 minus 2, 4 minus 3, 5 minus 4, how I can do it? I can create this into two different methods. One, it will store the value from the first index. So this is a 0 index now. It is stored from first index 2, 3, 4, 5. And here it will take the first 4 values, means accepting the or excluding the last one. 1, 2, 3, 4. Now can you subtract both of these values? 2 minus 1, 3 minus 2, 4 minus 3, and 5 minus 4. We can do this easily, right? If I try to split that into two different categories, not two different categories, basically two different values, and then subtract these two values, then I will be achieving the goal of 2 minus 1, 3 minus 2, 4 minus 3, and 5 minus 4. Now, okay, one more thing you need to understand, that it's fine that 2 minus 1 will give me 1, so there will be a 1 value. Again, there will be a 1 value. 4 minus 3 will give you 1 value. 5 minus 4 will give you 1. But what about this last? Are we getting any value for this last index? So note this, okay? We will not do anything of it as of now, but note this point, that we are not getting any value for the last. That means the method of solving the above values versus the last value will be different from each other. So how it is, I'll tell you. So let us now talk. Okay, we got it, that what we need to do. The thing is, again, how? I have a value 1, 2, 3, 4, 5. How can I change it into 2, 3, 4, 5? How can I change, guys? And even how can I change it to 1, 2, 3, 4, 5? No, 1, 2, 3, 4 only, because 5 will not be included. How we can do this? Log function means slicing. Can we achieve this task with the help of slicing? Okay, let's see how. So first of all, if I take minus 1, so if I want to exclude, so you can see it will extract all the records from the index column except for the last index. So that is the second part what we were finding. So it started with 0 but ended till 4497. So in our reality, the last index value was 4498, the last index value. But when we sliced it, we got 4497. So last value is excluded. Then to achieve the first one, we can start it, the index value will start with 1 only, just excluding the first value till 4498. Now I can store this in one variable, I can store this in another variable and subtract both of them. So it will give me the subtraction of 548 minus 0, 694 minus 548, and so on. Yes or no? Okay, so zip function will basically work same as your compression as you do in your system, that you combine multiple files together. So in Python, zip command is used to combine multiple outputs together. So we got one output from here. You can see two different outputs we were having. So either we can use a variable to subtract them, or either we can zip that value, and if you want to display the value, 666. So you can see here now in this x variable only. Now don't you think so you can run a for loop into this x to subtract 548 minus 0, 694 minus 548, 2707 minus 694. How easy it is now to run a for loop over this? Yes or no? Okay. Now everyone, do you remember the working of the full function? So in full, we need to pass the shape and then the value we need to fill it with. Okay. Now the main code. This was the partition of the code. Now what the thing is, remember that in the starting we were having 548 minus 0 minus 1. That we need to do. So 548 minus 0 minus 1 means 547 times I need to fill it with 1. So basically, if I make a variable temp np dot full, I'll give the shape that started from the 1 and fill it till 547. How many times? The first one. Okay, now we will run a for loop. How? Let's see. So we will create a numpy array that will contain 1 from value 0 to 547, means the first movie, then 2 from value 549 to 693, because the second movie, and so on. So first we have created an empty list, which is movie underscore np variable, and movie id is starting from 1, so I have taken the value movie id equals to. Now for I and j into zip command, because in zip I have two different values, so I will run through this value and j will run through this value. So for I and j in this, temp is equals to np dot full starting with 1, I minus j minus 1. Remember that we were having like this 548 0, then 694 548, like this. So we need to subtract. So I minus j minus 1. Clear? Now we need to fill it with, like using full command I've shown you. We have given this value 1. We have figured out 547 using I minus j minus 1, and we need to fill it with, this is movie ID. So this is movie ID. Then whatever the temp value I got, means temp will give you a value like this. So if we are talking about movie ID 1, it will give you these many times 1, means I minus j minus 1 times 1. Similarly, it will give you number of times 2, 3, 4. We are appending this temp variable into movie np, that means into a list what we have created. And when we are appending it, so this list will be created something like this, movie np. At the end it will be number of times you will be having 1, the number of times you will be having 2, then 3, then 4. So this list will be created. Then I can easily convert this list into a data frame. I can add this list as a new column into the data frame, right? Now after, once I got the number of times I need to find a particular value, it will increase the movie number. So one time it will fill all the ones, then movie ID is increased, so it will fill it with 2, then 3, then 4, till the number of movies we are having. So this was how we have achieved it. Now if we scroll down to see the output, you can see here, guys. So the first movies are filled it with 1. You can have a movie ID here, filled it with 1. Then last it is filled with 499. You can see the tail. Similarly, you can see the other index values using ilog function to see a particular data is created. Clear, everyone? Now, if you're confused, ma'am, how we have changed into data frame. So we have not changed into data frame here. We have just created a list using the next command. You can see this movie underscore np first change into integer, and that values are appended in one new column of movie id, then converted customer id also into integer, and then printed. So that was the next step we have created into a data frame. When we are finding the number of customer IDs, so in your customer IDs, we also have the movie IDs here now in the starting. So this is not a customer ID, so you need to subtract these values. So this is a movie ID, so you need to subtract the number of movies to get the actual count of customer ID there. Clear? Okay, guys. Now listen carefully. Now comes to data cleaning part. So we remove null values in your previous data, what you have worked. We remove null values, we remove duplicates, we remove outliers, and all that stuff was the steps of data cleaning. Yes or no? But here we don't have such things. We don't have like we cannot even remove the duplicate values because it will remove all the customers who has given the ratings multiple times. And even the ratings columns cannot, we can remove duplicates because maybe three movies got two ratings and all that. So duplicate values is not the option here. Null values is again not the option, and outliers are not considered here. So how we do data cleaning here, right? So there are two methods of data, like not two exact method, but this is something you need to think yourself how many more you can take. Like I have taken two categories in the sense I have thought that if I talk about customers first of all, so the customers who has given less number of ratings, they can be fake accounts. Like suppose I am a director of some movie and I want to increase the ratings of that movie. So basically, I will open 4 or 5 accounts or even 1,000 accounts I will open, and from that accounts I will give 5 ratings to my movie so that ratings will be increased for my movie. But the thing is that 1,000 accounts what I have created, I will not use it more oftenly, right? Because that is something I've just created for that movie. So the customers who has given less number of ratings, can you can we consider them as a fake accounts? If you are not satisfied with this fake accounts also, just think in a manner like you have a person like me. I am seeing very less movies. Very less movies I'm seeing. Suppose I have seen like one movie only I will see throughout the 1 year. So if I'll rate that movie, so most probably I will like that movie because only one movie I'm seeing in a year. So genuinely, I will give 5 ratings to that only. So will you trust that person who is not much experienced with movies and will randomly give any kind of ratings to any movies? Will you trust that recommendation of that person? No, right? So that means again that customer has given less ratings to the movies. He is not seeing much movies, but still he gave rating. We will not rely on that recommendation. If that person has given that the movie is okay, means it's very good, we cannot rely that actually the movie is good or not, because the person itself don't have that much experience. He watched less movies. So we can remove, I can set a benchmark below which I can remove all those customers. Maybe the customers who has given less than 100 ratings, or maybe the customers given less than 50 ratings. So that is something I will decide the benchmark. Below that, all the customers I will remove. This is the first scenario. Everyone getting it? Your way of thinking could be totally different, guys. This is something I'm giving as my way of thinking, what I am thinking. Okay, so I'm not saying this will be exactly same for you also. Maybe you don't want to remove. Okay, so first, as of now, just try to understand what I am saying. Just go with my perspective as of now, and after that, when you will try this project yourself, you can try your own perceptives. Clear, everyone? What I am telling you about customers. So the customers given less number of ratings, I will try to remove those. And the second is obviously about movies. The movies who got less ratings. If a movie got less ratings, you will not recommend that to any person, right? Because the movie itself got less ratings now. So I will remove all those movies also who got less number of ratings. So these are the two benchmarks I will create. One for the customers, another for the movies. Clear? Now what I have taken here is in movie IDs, like we have now one new column, if you remember, that is a movie ID column. Now, if I count the values of the ratings, so one movie got 547 times ratings, second movie got 145 times ratings, three got 2012 times ratings, and so on. So now I have checked the benchmark. Means the movie who got 0.7 quantile, less than 0.7 quantile, means this is the value. So who got movies less than this value, 798. Please remove that movie. You can see wherever the count is less than this benchmark, we are storing all those indexes into the drop movie index variable. And after that, we are, I think, okay. As of now, just understand that we are dropping it into, not dropping it, we are just storing those indexes into this variable drop movie list. And the length of this is 3,149 movies I got, which does not meet my benchmark. Clear, everyone? The first means all the movies who got less number of ratings. Now we will remove all the users that are unactive. So we will remove all the users who are inactive, or you can say given less number of ratings. So we have done, initially we have done the count for movie IDs. Now we will do the count for customer IDs also. So this customer ID whose number is 6 has given 553 times ratings. The customer ID 7 has given 195 times rating, and so on. Similarly, this customer ID 25 has given only 4 times rating. Then you need to check a benchmark here also. So I've again taken a 0.7. So that's 52. Then stored all the indexes of the customers, which is less than this benchmark, into drop underscore customer underscore list way. Clear? Now the original data frame shape was this. This was the very, very original shape. Now what we are doing is, these is in function will give you wherever you will get this value. So wherever we are having the indexes. Now, so everybody knows about this function, this operator. This operator means, guys, no, no, no. So wherever this value becomes false, only that values it will give. Means indirectly you are dropping the value. So the data set where these values are not included, because these values we have stored into drop movie list, contains the values, remember, which are the indexes we need to drop. Drop movie list and drop customer list are the two variables which stores the indexes we need to drop. This is right. So now I have printed all those indexes of drop movie list. Now using this command, it says that wherever you are having the values which is stored into drop movie list, this drop movie list here, please don't include that values, and other than that all the values should be stored into Netflix underscore data variable. Means leaving the values which are stored into the variables drop movie list and drop customer list, all other values should be stored into this. Means indirectly you are dropping it only. If you know any other method to drop the values, you can use that also. We are just dropping the values which are stored into drop underscore movie list and drop underscore customer, right? After that, printing the new shape of the data, which is this. Now you can see initial shape was this, and now the new shape is this. Clear? Then you can see now head commands. Head initially it was giving you 1, but the one movie was getting less rating, so it got removed. So your movie ID starting with 3 here. Not from 1, not from 2. It is starting from 3 because the data is trimmed now. Okay. Now guys, we have loaded another data set similarly, like here only. You can see we have another data set, movie titles. So what is this data? This will have a movie ID, the year of release, and the name of the. So in our previous data set, we were not having the name of the movie. It was just a movie ID. But in this data set, we have the name. So we have loaded the data set. Okay. So these are the, you can see, 4499 movies you are having and the specific name of the movie. That means every movie ID got a name. Okay, now this surprise. Remember what was the surprise we discussed? Surprise is a library which consists of the algorithms we need to use for the recommendation system. So you need to install surprise package like that. pip install scikit. So after that, model building. Now it's time to build our model. We have cleaned our data. Now it's time to build. So import certain libraries, reader, dataset, SVD, and cross-validate if we want to validate our model. Now, what does reader helps? What does reader helps? Reader will try to convert your dataset into a format which SVD algorithm wants. That's it. The work of reader is to convert the data frame into a variable, into a format which your SVD algorithm wants. Right? Now I have taken only the first 1 lakh rows because like to increase the speed of the code. When you're running this code without any Zoom meeting or something, you can run the complete code also. Means don't slice the values, take the complete, because my RAM is consumed with Zoom meeting also. So I have taken only first 1 lakh rows so that no runtime error I will get. Now model equals to SVD. We have created the model over here. Cross validate the data using RMSE and ME. Like we have accuracy score in logistic regression, we have R2 score in linear regression. RMSE also similarly we can cross validate the SVD model also using RMSE and MAE. Okay, then we have, okay, this is we have created our model here. We have properly created our model. Now if we want to recommend movies, how? So what we have taken is, so we will take the user. So this is little bit wrong. 133,115. Now guys, if we want to recommend the movies, now see, if we want, we'll take any random user and we try to recommend some movies based on the past data. So he rated so many movies with 5 star, right? So what I've done is I have filtered out the data wherever the customer ID is this and the ratings given by that customer is 5. I want to see what are that values. So what we were doing is, for this customer, like suppose I will give name to this customer instead of speaking any number. So what name we should give? Ram. Suppose we are giving this customer name as Ram. So I want to see how many movies Ram has given 5 ratings. So from this Netflix underscore dataset, which was our data, I have filtered out the data wherever the customer IDs of Ram and Netflix dataset means the ratings he has given is 5. All those values I have stored in, that is data underscore the customer ID of Ram. Clear? Now this data set, I want to see, it's the past data we are collecting, that how many movies the particular RAM has given 5 ratings. Now this data set, df underscore title is the new data frame we loaded. We are making the copy of this data into this variable. I don't want to do any changes in the original, so I have made a copy into a new variable. Reset the index of the new variable. Okay. Now we need to again see. I want to see the movies, or I want to get the movies which movie ID is not present. Means all the movies we have done in drop underscore movie underscore. Remember, we created a variable and storing all the indexes value which the movies we need to drop. Now I want to check from the movies, like the person who the RAM has given 5 ratings, is there any movie which is belonging to that particular set? So if it is belonging in that particular variable, we will not include that movie and we will include the rest of the part. So maybe RAM has given 5 ratings to 3 movies which was in my drop underscore movie underscore list. So I have removed those 3 movies from the list of Ram's recommendations. Once we figured out, now estimation score. What was estimation score? So estimation score was the prediction score of each and every movie, that how much prediction value it is getting for the person. So this is the code model.predict dot est. Est is the function for estimations. Now see, we have created a new variable which is estimation score, not variable, new column in the data frame in which I am storing these all estimation score. So you can see movie 3 got this estimation score for the user for RAM, movie 8 got this much estimation score, movie 16 got this much estimation score. Now what we will do, highest estimation score is something we should recommend. So I have done the sorting part, estimation score in descending order, so that I could get the highest. So these are the movies. So if you want to recommend the top 10 movies, you can take the first 10 values. If you want to recommend the top 5 movies, you can take the first 5 values. The first 5 movies is the what is recommended to that person to run. Clear? So this was your Netflix project. It was little tricky, I know, different from your all other projects, little bit typical, but yes, that's it, guys. So this was all about your project.
So moving on with our first question. Explain the types of data science problems along with the data sets used for each problem. Data science problems can be grouped based on what we are trying to solve. For example, one common type is classification problems like fraud detection. Here the goal is to categorize data into classes such as fraudulent or non-fraudulent. The datasets here are usually highly imbalanced, meaning there are far more non-fraud cases than frauds. Sometimes these datasets can even have a time series structure. Another type is regression. This is where we predict a continuous value. For example, predicting house prices. Datasets here might have features like the number of bedrooms, location, and property size, and the target variable would be the price feature. Then there is time series forecasting. This is used to predict future values based on historical data. A common example is stock price prediction or sales forecasting. Another type is recommendation systems. This is where we suggest items like movies, products, or songs. The data sets often include user preferences, item characteristics, and sometimes behavior logs like clicks or purchase history. Lastly, we have clustering problems like customer segmentation. Here we group similar entities based on features like age, income, or spending habits. These datasets don't have labels, so we look for patterns. Each type of problem has its unique dataset structure and challenges, but it's all about understanding the data and the problem we're solving. Moving on to the second question. What are the common issues in raw datasets that require cleaning? One common issue in raw datasets is missing values. Some rows or columns might be incomplete. For example, in a dataset of customer records, you might not have some records in the contact number feature column. This can be solved by the following methods. For numerical columns, we can fill them with the mean where there are no outliers, whereas median in case of outliers. And for categorical data, we can fill with the mode. Another issue is duplicates. This is where the same data point appears multiple times. This often leads to skewed analysis. The duplicate function can be used to identify the duplicates. There could also be outliers in the data, like a few incomes could be way too high or way too low compared to the rest. This would again lead to inaccurate prediction. You can use scaling methods like standardization or normalization to deal with outliers. I have a separate video on standardization versus normalization. You can check it out in the description. Inconsistent formatting is another big one, like dates in different formats or text fields with varying capitalization. And then there's incorrect data where entries are just wrong. So say for example, a negative value in a column for age. All the above issues can be taken care of at the data cleaning stage itself. The data needs to be accurate, consistent, and reliable for analysis. Moving on to the third question. What are the different learning mechanisms in data science? So there are 4 main types: supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. In supervised learning, the model is trained on labeled data, meaning we already know the outcome. It's like teaching a child with examples. So say in email spam detection, we know which emails are spam, so the model learns from those examples. Next is unsupervised learning. This is where we have data but no labels. The model tries to find patterns or groupings by itself. A good example is customer segmentation, where the algorithm groups customers based on their purchasing behavior without knowing what each group represents. And then there is something known as semi-supervised. This is a mix of both. There will be a small amount of labeled data and a large amount of unlabeled data. The model uses the labeled data to learn and then generalizes to the unlabeled data. It's useful when labeling data is costly. Finally, we have reinforcement learning. Here the model makes decisions and gets feedback in the form of rewards or penalties. It's commonly used in gaming or robotics where the model has to learn to improve its actions through trial and error. Moving on to the fourth question. Why is standard deviation often preferred over variance when analyzing data? Both variance and standard deviation measure how spread out the data is. But the key difference is that variance is in squared units, while standard deviation is in the same units as the original data. Let's say we're looking at the test scores of a class of students measured on a scale from 0 to 100. If we calculate the variance, it would give us the number in the units of squared points, say something like 25,000. Now, this is not easy to relate to the actual scores. However, when we calculate standard deviation, it's in the same units as the original data. In this case, just points. So, if the standard deviation is 50, it's much clearer because we can directly understand it as the spread of scores around the average score. Standard deviation just makes it easier to relate to real world values. Moving on to the fifth question. What is overfitting and underfitting, and explain how you can detect if your model is overfitting or underfitting. So, overfitting happens when the model learns the training data too well, even the noise and the random fluctuations. It performs great on the training set, but struggles with new unseen data because it's too specific to the training data. It's like memorizing answers to a practice test without truly understanding the material. On the other hand, underfitting happens when the model is too simple to capture the patterns in the data. It fails to perform well on both the training set and the test set. It's like studying just the basics and missing out on the important details. In order to detect underfitting or overfitting in your model, you need to look at performance metrics like accuracy or error rates and compare them between the training and the test sets. To deal with overfitting, you can either reduce the number of features or use techniques like regularization or cross-validation. Whereas for underfitting, you would want to make the model more complex. This might involve adding more features and increasing the model's capacity. Moving on to the sixth question. Explain the concept of regularization in machine learning and why is it important for improving model performance. Regularization is used to prevent overfitting by adding a penalty to the model for being too complex. Essentially, it discourages the model from relying too much on specific features or learning noise in the data. There are two types of regularization techniques. First is L1 regularization or lasso regularization. It adds a penalty based on the size of the model's coefficients, making some of them shrink to 0. This way, it automatically selects only the most important features and ignores the rest. For example, in house price prediction, if the number of garage doors has little impact, L1 regularization might set its weight to 0 and exclude it from the model. The next one is L2 regularization or ridge regularization. It adds a penalty based on the square of the coefficients. This reduces their size but doesn't make them 0, so all features are kept but none dominate too much. For example, in predicting house prices, if the area feature has a large impact but the number of rooms has a smaller impact, L2 regularization will ensure that both are considered while preventing the area feature from overpowering the model. Regularization is important because it helps the model generalize better to unseen data by controlling complexity and preventing overfitting. Moving on to the seventh question. If a model performs well on training data but poorly on unseen data, what technique could you use to understand its generalization ability? This is a classic case of overfitting. To understand the model's generalization ability, we can use cross-validation. With cross-validation, we will split the data into multiple smaller sets or folds. The model is trained on some folds and tested on the others. This process is repeated multiple times and we average the results to see how the model performs across different subsets of data. It's a great way to check if the model is consistently good across various splits or if it's just memorizing the training data. Moving on to the next question. What is the role of activation functions in machine learning models like linear regression and logistic regression? Activation functions are used to introduce non-linearity into a model, which allows the model to learn complex patterns in the data. In linear regression, there's actually no activation function because the output is simply a linear combination of input features. It's used for predicting continuous values. In logistic regression, however, We use the sigmoid activation function, which squashes the output between 0 and 1, making it suitable for binary classification problems like predicting the yes or no outcomes. So the main role of activation function is to help the model make more accurate predictions by capturing complex relationships in the data. Moving on to the next question, what is the confusion matrix, and describe a situation where false positive is more important than false negative and vice versa. A confusion matrix is a tool that is used to evaluate the performance of a classification model. It shows how well the model's predictions match the actual outcomes by displaying the number of correct and incorrect predictions. It's basically a table with 4 values. One is true positive. These are the correctly predicted positive cases. Then there are true negatives. These are the correctly predicted negative cases. Third is the false positives. These are the incorrectly predicted values as positive, also known as type 1 error. Lastly, we have false negatives. They are incorrectly predicted values as negative, also known as type 2 error. From these values, we can calculate other performance metrics like accuracy, precision, recall, and F1 score, which give a clearer idea of how well our model is performing. False positives are more important than false negatives in cases like a medical test for a rare disease. A false positive that is incorrectly saying someone has a disease might lead to unnecessary tests, but it's safer because it ensures we do not miss any actual cases. Whereas for a spam filter, a false negative, which is a spam email getting through, is less risky because you can always delete it. But a false positive, where important emails are marked as spam, could cause you to miss important messages. Moving on to the 10th question, why do we prefer a decision tree over a random forest? A decision tree is a simple model that splits data into branches based on features, making decisions based on these splits. It's easy to understand and visualize and works well for smaller, less complex problems where interpretability is key. A random forest, on the other hand, is a collection of multiple decision trees where each tree is trained on a random subset of the data. It combines the results from all these trees, which usually gives better accuracy and reduces overfitting. You'd prefer a decision tree over a random forest when you need a simple, interpretable model or when computational resources are limited. But if you need better accuracy and robustness, especially for complex datasets, random forests are the better choice.
Moving on to the 11th question, what is naive in naive Bayes theorem? Basically, what we're trying to understand here is what does the term naive stand for in this naive Bayes theorem? So, the word naive in naive Bayes basically refers to the assumption that all the features in a dataset are independent of each other. But if you consider real life scenarios or real life data sets, this assumption does not really apply. Why? Because say for example, you have a house price prediction data set. You will have feature columns like number of bedrooms, number of bathrooms, balcony, the area of the house and so on. Now in real life, if you consider the area and number of bedrooms, number of bathrooms, so are supposed to have some sort of correlation between each other. But what naive Bayes theorem does is, it is going to consider that these features are independent of each other, that is, they have zero correlation between each other. Now, this assumption will not apply in real life, but surprisingly, it works really well in many situations, especially for classification problems, right? So, naive Bayes has a major application in classification problems. Alright. So, naive Bayes basically calculates the class probabilities based on feature likelihoods, assuming no dependence between them. Clear? So, this is the formula for naive Bayes theorem. This is the posterior probability of the hypothesis. This is what the naive Bayes is trying to calculate. This is the likelihood probability, which basically is the estimated value for each feature, assuming that all the features are independent. Alright, so this is the assumed value, and then we have our hypothesis probability and our evidence probability. Alright, before we move to the next question, let me take you guys to my notebook and show you guys the implementation of naive Bayes. Alright, so the implementation in Python is very easy for any naive Bayes. So basically we have 4 types of naive Bayes theorems. First one is Gaussian naive Bayes. So this works well for continuous data. So the Gaussian naive Bayes basically calculates the mean and the variance, and then it goes for the probability.
Then we have multinomial naive Bayes. So this works for the discrete data set. Like it is going to count the data and then it is going to go and calculate the probability. Then we have Bernoulli naive Bayes. This works for binary or Boolean features like yes, no, true, false. Then lastly, we have categorical naive Bayes. So the name itself suggests that it works for categorical data sets. So you can easily import your naive Bayes theorem, whichever one you want to apply from sklearn.naive Bayes, and then you have to call your function and simply train it using the fit method. Alright, so once that is done, you can go ahead and predict it, and this is what your output is going to look like. Alright, so basically this is how it has classified it as 0 and 1. So that is all about the naive Bayes theorem. Moving on with our 12th question. What is imbalanced data and how do we handle them? So I have already made a video on this particular topic and I have explained each and every concept in a lot of detail. So you guys can go ahead and check it out. But right now I'll just cover this concept in brief so that you guys get a basic idea. Alright, so imbalanced data basically happens when one class in a data set has a lot more samples than the other. Now what does that mean? So consider this example over here. So this is a balanced data set. Now why is this a balanced data set? So we have two classes over here, female and male. Let's call them A and B. Alright. Now class A, that is female, has 51% of samples in a data set, whereas class B, which is male, has 49% of samples in the data set. Now this is a pretty you can say balanced situation. Why? Because we have almost equal number of samples, right? 51% and 49% are not that far away. But if you consider this particular scenario, we have 98% of samples in class A, which is our normal. Okay, so this imbalanced data is basically for the fraud detection data set. Okay, so we have a fraud detection data set where we have two classes, which is normal transactions and fraudulent transactions. Now, our normal transactions are obviously going to be in a higher ratio compared to a fraudulent transaction. So we only have 2% of transactions which were fraud, which is our class B. Alright, so the number of samples of class B is comparatively very less as class A, right? So this is going to lead in poor performance in the minority class. Basically, our model is going to be biased towards the majority class, right? So say for example, my model predicts not fraud or say normal each time. My model is going to be 98% accurate. Isn't that right? So now with a 98% accuracy, I can say my model is working pretty well. But the cases I am most interested in. Now the entire purpose of training a model on fraud detection dataset is to detect the fraudulent transactions, right? But if my model is failing to do the one goal it was trained for and it is giving me 98% accuracy, I can say my model is practically useless, right? So this is why we need to handle the imbalanced datasets using techniques like undersampling, oversampling, and lastly we have SMOT, right? So in undersampling, basically we take random samples from our majority class till they are equal in size with our minority class, right? So basically we are making our data smaller. So say we had 1000 samples over here in our majority class and 100 samples over here. Our final data set is going to contain 200 samples, right? We are randomly going to pick 100 samples from our majority class. Whereas in oversampling, if we have 1000 in our majority class and 100 in our minority class, we are going to keep duplicating these samples in our minority class until and unless they are equivalent to the size of our majority class. That is, initially we had 1100 samples, now we are going to have 2000 samples in our entire data set, right? So this is how undersampling and oversampling works. Now over here in oversampling, we are simply duplicating the data randomly in our minority class, right? We are not exactly performing some sort of calculation. Now in our next technique, which is known as SMOT or synthetic minority oversampling technique, over here instead of randomly duplicating the data, we are going to perform some sort of calculation using this particular formula, and we are going to create synthetic data points, and these data points have one rule, that is they are always going to lie between the axis of two existing data points. Alright, so this is basically what SMART does. So these are some of the techniques that you can use to handle your imbalanced data. Moving on to the 13th question, state the scenarios when the different tests can be used and also explain the p-test. So now the different tests that we have are z-test, t-test, f-test, chi-square test. Like these are some of the tests that we'll be covering in this particular question. So the first one is z-test. Now this is used for the large samples, generally greater than 30. So whenever we have more than 30 samples, we will be using z-test. Now keep this condition in mind. I'm sure some of you guys must be having a doubt regarding 30 samples. We'll be talking about this in a few minutes, but first let's cover all the tests, right? And your population standard deviation should be known. So say for example, you want to compare the average heights of two cities. So this is a scenario where you would preferably be using z-test. So this is the formula for finding the value of z-test. So you subtract your population mean from your sample mean and you divide it by your standard deviation divided by the total number of observations. Alright. Then the next one that we have is a t-test. This is used for small samples, preferably less than 30, and you don't know your population standard deviation. So say for example, you want to test a new teaching method, whether it improves your test scores in a class or it doesn't. Right? So this is the formula for your t-test. So the next one that we have is an f-test. This basically compares the variances of two data sets. So say for example, you want to check the variability in scores from two teaching methods. This is when you'll be using an f-test. So this is the formula. You divide your larger sample variance by your smaller sample variance, and then you can look up the f-test table to find the value. Then we have a chi-square test. This is used for categorical data to test relationships between your features. So say for example, you want to analyze whether genders impact the product preference, right? So for cases like that, you would be using a chi-square test. This is the formula for your chi-square test. C is your degree of freedom, O is your observed value, and E is your expected value. Alright. Then lastly, we have our p-value. Now the p-value is not particularly a test, rather it is used to determine whether the result of a statistical test is significant or not, right? So basically a p-value is a decision rule that compares with alpha. Now alpha is generally 0.05, right? This is the standard value of alpha. It could vary based on the problem, but in general we keep it 0.05. Now, if our p-value is less than or equal to 0.05, we reject the null hypothesis. But if it is greater than 0.05, we fail to reject the null hypothesis, that is, we accept our null hypothesis. Alright, so say for example, we want to test a new drug, right, and its effects. So we'd be using a p-value in this case. Now, before we go ahead, let me quickly take you to my Google Notebook. Alright, so we know the general rule of using a t-test and a z-test is whether a sample size is greater than 30 or less than 30. But if you take practical scenarios or real life scenarios, our data set usually has around 1000 samples, right? Whenever we go to train a model and we pick a data set, it is going to have at least 1000 samples. Now, out of those 1000 data points, if we try to take out only 30 samples, it does not make sense, right? Our data set is going to have at least 500 or 600 data points to be able to learn and have an accurate output, right? So in a problem statement, whenever there is mean or average mentioned, we use a t-test, and whenever there is a percentage or proportion mentioned, we use a z-test. Clear? So theoretically, we take the 30 sample rule, but when it comes to practical scenarios, this is the condition that we follow. Alright, so let me quickly show you how it is implemented. So I am going to implement t-test. So this is my data set and I have taken a sample size of 1000. I have decided my new sample data, and what I'm going to do is I'm simply going to perform a one sample t-test. So I'm going to import my t-test from scipy.stats. I've declared my variables t-stat and p-value, and I've passed my column purchase, and I've given the sample size over here. And after performing that, I have got my p-value as 2.8, right? Now this 2.8 is clearly greater than 0.05. This means we have to reject our null hypothesis. And over here we have given a conclusion, that is whatever was our alternate hypothesis has become our conclusion now. Alright, so this is basically how we perform any test in Python using the libraries. So moving on to the 14th question, what are eigenvalues and eigenvectors and why are they important? So let me quickly explain a scenario where we have a data set which is in a 3D form. Alright, now if I want to make my model simple and understand the data better, my goal would be to transform this 3D data into a 2D data, while also being able to retain the maximum information out of this particular data. Now, in order to do that, I can compress my data from any one of these dimensions, either from my height, my width, or my breadth. But if my goal is to retain the maximum information, I'm definitely going to compress it from an angle that has the largest area. And if I feel this particular side is going to give me the maximum information out of my data, I'm going to compress my data set from this particular angle. So now what eigenvalues and eigenvectors are? Eigenvalues are basically going to tell me how much my data set has shrinked or stretched during my transformation, whereas my eigenvectors are going to define the direction from which my data sets have been shrinked or stretched, right? And the direction is always going to remain unchanged during that transformation. So I hope this is clear, and this is the basic formula that is used to calculate the eigenvector, which is represented with the x vector, and we have eigenvalue represented by lambda. Alright, so let's quickly look at the example. So we have a matrix denoted by A, which is 2, 0 and 0, 3. Now in order to calculate the eigenvalue, this is the formula that we'll be using. Alright, we need to calculate our matrix A minus lambda into I. Now I is the identity matrix and it is represented using this particular matrix. Alright, so now we know the determinant of this particular matrix is going to result to 0. Alright, now this is going to help us give the final values of the lambda. Alright, so now to calculate A minus lambda I, this is the kind of calculation we'll be performing. We've already multiplied lambda with our identity matrix and this is going to be the resultant matrix after multiplication, right? So after subtraction, this is going to be our final matrix, 2 minus lambda and 3 minus lambda. Once we equate it with 0, we get the values of lambda, which is 2 and 3. Alright, so we get two eigenvalues, which is 2 and 3. Now in order to calculate the eigenvectors, we are simply going to multiply x with A minus lambda I. Alright, now we know the values of lambda, which is 2 and 3. So we are going to substitute these values in lambda, and once we do that, we're going to get a matrix like this, and after we multiply this matrix with x, our x value is going to be somewhat like this. Alright, so basically these are the steps that we follow in order to calculate the eigenvalues and eigenvectors. Alright, now why are they important in data science? So eigenvalues and eigenvectors are used for principal component analysis. Basically, they reduce the dimensions of large data and they're used to identify the important features using eigenvectors. Then they're used for graph analysis and stability analysis also. Alright. Moving on to the 15th question. How do you ensure that the sample chosen for a study truly represents the entire population? Now, in order to answer this particular question, first we need to understand what is sampling. So whenever we're conducting a study, it is not always going to be possible to include everyone in the population, right? So we're going to use sampling to study a smaller, more manageable group. So the first step is to define who or what you are studying. That is, we need to define the target population. So say for example, we want to know the opinions of college students for a particular study, right? So our target population is going to be only the college students, not their parents, not their siblings, right? So that is how we define the target population. The next step would be to choose the right sampling method. Now we have over here 4 different types of sampling methods. So the first one is simple random sampling. Over here, everyone in the population is going to have an equal chance of being selected, right? There is not going to be any particular bias towards any person. The next one is systematic sampling. So over here, every nth person or nth member from a list or sequence is going to be selected. So basically over here, we're going to apply some sort of algorithm or some sort of system that every third person that we meet or every third person that we interview is going to be part of our data set. Alright? Then what we have is a stratified sampling. Over here, we divide the population into groups, that is our strata, and take a random sample from each group. Alright? So say for example, I am interviewing college students. I'm going to divide the college students into groups, say depending on their streams, right? So maybe I make groups of computer science and MBA and other fields like that, right? So once I have divided the college students into groups, I'm randomly going to pick a student from each group. Alright, so this is what is known as stratified sampling. Then lastly, we have cluster sampling. Over here, we divide the population into clusters, randomly select the clusters and include all the members from those clusters. Alright, so over here, I'm not going to select an individual from a group, rather I'm going to select the entire group randomly. Alright, so this is known as cluster sampling. So depending on our problem statement, we need to choose the right sampling method. Then third is to ensure sample size is adequate. What this means is larger samples are better because they reduce the likelihood of errors. So say for example, if we are polling 10 people to understand a city's preference, we are going to miss the diversity of opinions, right? A sample of 1000 is going to be much more reliable and much more adequate. So this is what ensuring the right sample size means. Then lastly, we need to avoid bias. Bias occurs when certain groups are favored over the others. So say for example, we only survey people from urban areas and we ignore the rural areas. So our result is going to be completely skewed, right? Obviously, the opinions of urban people are not going to match with the ones of the rural people. So this is basically how bias enters the sample. So we need to avoid bias in order to have a sample that truly represents the entire population. Alright, moving on to the 16th question. What is a gradient and gradient descent? So gradient basically measures the slope or rate of change of a function. Alright, this is the formula for gradient. Basically, we have a function and we have a gradient with respect to x and with respect to y. Basically, all the independent variables of a function. So we perform differentiation and we get the final value. Alright, so gradient basically points in the direction of the steepest increase. Alright, so if in this case we had our y value as say positive and x value also positive, then this gradient would be signifying that in whatever direction we are moving so far is the direction of the steepest increase. That is, we are going in the increasing direction, right? It is leading us to the maxima. Alright, but say in case one of these value was negative instead of positive, this particular value was negative. Now this would indicate that the direction that we are heading to is the opposite of the direction of our increase. That is, we are leading to towards the minima. Alright, so basically gradient tells us how much the function is increasing or decreasing as we move in different directions. Alright, then we have gradient descent. Now this is a method to find the minimum of a function by moving in the opposite direction of the gradient. Now we already discussed gradient is going to lead us in the direction of maximum value. And now gradient descent is a method to find the minimum of a function. So obviously gradient descent is going to move in the opposite direction of the gradient. Alright, so say for example, this is our function. Alright, now in order to reach the minimum point which lies over here, what we are going to do is at every point we are going to calculate the gradient. Alright, now if the gradient is telling us that this particular direction is going to lead us to the minima and this particular direction is going to lead us towards the maxima, we are obviously going to move in the direction that is leading us towards the minima, right? And we are going to check that at each particular point until and unless we reach a point which is the global minima. Alright, so basically we are trying to reach towards the bottom of a value. Now this optimize the models by minimizing error. Alright, so this is basically what gradient and gradient descent means. Okay, moving on to the next question. Define confounding variables. Now confounding variable is something that influences both the independent and the dependent variables. Alright, so confounding variables are often referred to as hidden variables, and they can make a relationship appear between an independent variable and a dependent variable even if there is none. Alright, so this is basically what confounding variables do.
Now, say for example, you're studying the relationship between exercise and weight loss. You find that people who exercise tend to lose more weight. But if you don't account for people's diet, it could be the diet causing the weight loss as well, right? And not just the exercise. So in this case, diet becomes our confounding variable. Alright, so this is basically how confounding variables work. Moving on to the next question, define bias variance trade-off. Alright, now in order to understand bias variance trade-off, we need to understand these terms separately. So bias is basically an error due to oversimplistic models that don't capture all patterns in the data. Alright, so this is an example of high bias in a data. So these are our data points, and since we have a high bias in our data, we are not really trying to understand all the data points. Rather, due to the simplicity of our model, we are just going to fit a straight line where we assume that most of our data points are being touched. But this is a case of underfitting. Alright. Then the next thing that we have is variance. Now this is an error due to models that are too complex and overfit the training data. Now this is the opposite of high bias. So basically when we have a high variance or low bias, what we do is we try to learn each and every data point in the data set. This leads to overfitting, and this is also a case where the model performs really well on the training data but very poorly on the unseen data. Alright. So a simple example or simple analogy of a high bias would be a person studying for an exam, and the person is not really trying to understand the definition and the examples of each concept. Rather, he just looks at the headings of each concept. Right? This would be a case of underfitting. But if that same person tries to memorize each and every detail of a particular concept, so he even memorizes the numericals, the exact value of each numerical, the person is going to perform extremely well if the exact same questions appear in the data. But if the values of a particular numerical or a particular question are changed even slightly, the person is going to fail in that particular case. So this is an example of overfitting. Alright? And overfitting happens when there is a low bias or a high variance. And underfitting happens when there is a high bias or low variance. Alright? Now, the entire goal of bias variance trade-off is to find the right balance between bias and variance. Now, if we have a low bias and a high variance, our model is going to fit the data well, but it is not going to generalize it. Alright? Which basically means overfitting. But if we have a high bias and low variance, our model is going to be too simple and it is going to miss important patterns or even the general patterns, the basic learnings of the data. Alright? So the goal is to find a spot where the model is complex enough to capture patterns but simple enough to avoid the overfitting. Alright, so this is basically what it means. This is the kind of point that we're looking for, which gives us the optimal solution. Moving on to the 19th question, when do we use deep learning in a project? So in order to answer this question, we need to answer what is deep learning. The deep learning is basically a subset of machine learning which uses neural networks with many layers. Alright, so it can handle complex data which includes images, text and audio. Alright, so here is an image that indicates machine learning and deep learning. So in machine learning we have an input data, then we perform feature extraction and then we perform classification and then we get an output. But in deep learning we have an input data and our feature extraction and classification are performed all together with the help of neural networks and we straight away get the output. Alright. Now when do we use deep learning in a project? So we use deep learning if we have a very complex and large data set. So when our data is large and unstructured, that is our data includes images and videos, right? So this basically makes our data complex and it would be better to use deep learning in such cases. Alright, so say for example, we need to analyze the medical images. Alright, so say it is a cancerous cell data set. Alright, and we need to define whether the cell contains cancer or not. So we can use deep learning and basically neural networks in cases like this. Then comes the need for feature extraction. So whenever we need to automatically learn useful features from raw data. Say for example, we need to identify objects in a photo. Alright, so we can use deep learning again. Then when our model needs high accuracy.
So when a high level of accuracy is crucial for the task, we would go for deep learning. Alright, so say for example, self-driving cars will need precise object detection and in real time, right? So we would go for deep learning. So some projects that use deep learning would be image classification, speech recognition, and natural language processing. Some other would be a chatbot, traffic sign classification, newspaper summarizer, image caption generator, human age detection, and so on. Moving on to the 20th question, what is OOB error and how is it useful? So OOB error basically stands for out of bag error, which is a concept in random forest models. Now, this is a way to estimate the model's accuracy using the leftover data that isn't used during the training. Alright. Now, we have an original training data of size 5. Now, we are going to do sampling with replacement. So, we have multiple decision trees and we are going to use the sample size of 3 for each particular decision tree. Now, OOB error is basically when random forests build multiple decision trees, they train each tree on a random subset of data called a bootstrap sample. During this training, some data points are going to be left out. Now, these are called the out-of-bag data points or OOB error. Alright. So, once the random forest model is trained, the out-of-bag error or the out-of-bag data is going to be used to test the predictions. By aggregating the errors from all the trees, we calculate the OOB error. This is an estimate of how well the model performs on unseen data. Alright. So, OOB error is useful for internal validation, which basically provides an unbiased accuracy estimate without needing to separate validation data. Then it also saves resources. So it is going to eliminate the need completely to split the data set into training and testing sets. Right? Since we are already leaving out some data to be tested on, we do not need to split our data set separately. Then it also provides performance check. So it is going to help identify if the model is overfitting or underfitting. Right? So some examples of OOB error are suppose a random forest model trains on 70% of the data, which is a bootstrap sample, and the remaining 30%, which is our out-of-bag data, is going to be used to test each tree's prediction. Now we aggregate these predictions to compute the OOB error in total. Alright. Moving on to the 21st question, define and differentiate between convex and non-convex functions. Now, as you can see in this image, we have two graphs. Let me tell you, this is a convex function and this is a non-convex function. Alright. Now, in order to understand convex and non-convex, let us recall gradient descent. Right. Now, the purpose of gradient descent was to find the minimum of a function, right? This was used to minimize the error or loss of a model, correct? Now, if we talk about this particular function, if we start from any point, say initially we have a point over here, or you can say we start from this particular point, we know that our minimum point or a minima lies somewhere over here. Is that correct? As you guys can see, this is going to be, or somewhere over here, this is where the minimum of our function is going to be located. Now, if we start from this particular point and we calculate the gradient, we are going to be led into a direction somewhere over here. Correct? Then when we calculate the gradient over here, we are going to be again led in this particular direction. And this process is going to be continued until and unless we reach this particular point. Now, in a convex function, it does not matter what our starting point is, because no matter from wherever we start, we are somehow or the other going to be led to the minimum point of our function, right? So, convex functions are said to have one and only one global minima, right? Now, if we talk about non-convex functions over here, so say my starting point is somewhere over here. Now, if I try and calculate the gradient, I could be directed in this particular direction or this particular direction, right? Or I could be directed towards this particular direction depending on the exact slope of the function at that particular point, right? So say if I'm directed in this particular direction, then I calculate the gradient in this particular point again, I'm going to be led somewhere over here. And once I reach this particular point is going to be considered my global minimum. But is that correct? Is this my global minimum? No, it is not. This point is supposed to be my global minimum. But since I do not have any lower point than this at this particular point, This point is going to be considered my global minima. So basically, convex functions are said to have multiple local minimas. Alright, as you can see over here, this is another minima, this is another minima, this is another minima. So whether or not you reach the global minima depends completely on your starting point. Alright, so say if you start somewhere over here, there is a higher chance you reach the global minima rather than some other local minima. Alright, so these are your local minimas. Alright. So this is a basic differentiation between convex and non-convex functions. So a convex function is where the line segment between any 2 points on the curve lies above or on the curve. There is only one and only one global minima, and it is easier to optimize. Alright. A non-convex function is a function where the line segment between any 2 points on the curve may lie below the curve. Alright. It has multiple local minima and maxima, and it is much harder to optimize. Moving on to the 22nd question, what is collaborative filtering? So collaborative filtering is basically a method that is used to make recommendations based on user behavior. It relies on similarities between the users or the items. So collaborative filtering is again divided into two types. First is user-based and second one is item-based. Alright, so user-based collaborative filtering is basically when items are suggested based on users with similar preferences. Alright, and item-based collaborative filtering is basically when the items are suggested similar to what the user has liked previously. Alright, let's understand this with the help of an example. So there are two users, user 1 and user 2. So both these users have several movies in common. That is, they have both liked these movies or they have highly rated these movies. Now, if user 1 has watched a particular movie that user 2 has not, there is a high chance that this particular movie is recommended to user 2. Alright, so this is basically how user-based collaborative filtering works. Then we have item-based filtering. So basically we have three users who go shopping. So user 1 has shopped for these particular items, whereas user 2 has shopped for these particular items. Now if a third user has shopped for this particular item, this user is going to be recommended items from the similar category. Now if this is not clear, let me give you another example. So say if you buy a book about machine learning. Now what the system is going to do is, the system is going to recommend similar books in the same category to you as well. Maybe you get recommendations of deep learning as well, right? So this is how item-based filtering works. Based on your previous preferences, based on your previous likings, you will be recommended items in the future. Clear? Moving on to the 23rd question, what is a lazy learning algorithm? Now, lazy learning basically refers to algorithms that postpone generalizing from the training data until they receive a query, that is a new data point. Now, they don't process the data during training, but instead they store it for later use. Alright. So basically they delay generalization data until a query is made. Alright. So in the training phase, lazy learning training is almost instant because the algorithm is going to store the data set without building a complex model. Whereas in the prediction phase, when a new query comes in, the algorithm is going to compare it to the stored data to make a prediction. This step is going to take time because this is going to involve looking through all the stored data. Alright. So one example of lazy learning algorithm is the k nearest neighbors algorithm. Alright. Now what k nearest neighbors does is, so say you have 5 data points about fruits. Alright, let's say these are apples, some are apples, some are oranges. Alright, they're already classified. Alright. Now say you have a new data point, which is basically a new fruit. Now in order to classify this new fruit, what KNN is going to do is, it is going to compare it to the stored data, right? These are your stored data points, right? All these are your stored data points. Now KNN is going to compare the stored data point and check the k closest neighbors for the new data point. Alright, so say if most of the neighbors of this new data point are apples, KNN is going to classify it as apples, otherwise it is going to classify it as oranges. Clear? So this is how KNN works, and this is basically what lazy learning algorithm works. Alright. Moving on to the 24th question, Describe the differences between bagging and boosting algorithms. Alright. So bagging basically works by creating multiple subsets of the training data. So bagging and boosting are basically two powerful techniques in machine learning that are used to improve the performance of models. Alright. So both of these models are basically going to combine multiple models, but their approach and goals are completely different. Okay. So first let's see bagging. Now what bagging does is it is going to create multiple subsets of the same training data, and it is going to train independently on each subset. Alright. So basically bagging works in parallel, whereas boosting trains the model sequentially, where each new model is going to focus on correcting the errors made by the previous model. Alright. So the final prediction is going to be a weighted combination of all the models. Clear? The basic difference is clear. So let's look at the approach. So bagging basically follows a parallel model training, whereas boosting follows sequential model training. The goal of bagging is to reduce variance, whereas boosting has the main goal of reducing bias and variance. Alright. The basic method of error handling in bagging is to have equal weights for all the models, whereas boosting corrects errors of the previous models. Alright. So bagging has a lower risk of overfitting, whereas boosting has a higher risk of overfitting if not controlled. Alright. So basic example of bagging would be random forest, where we have multiple decision trees working parallelly on each subset of the training data, whereas boosting algorithms would be AdaBoost, gradient boosting, and XGBoost. Alright. Moving on to the 25th question. Explain the central limit theorem and its importance in data science. CLT or central limit theorem basically states that the sampling distribution of the sample mean approaches a normal distribution as the sample size increases. Alright. So as you can see over here, as we increase the sample size, the distribution of our data approaches a more normal curve. Alright. So this basically enables the use of statistical methods that rely only on normal distribution. It's going to help make inferences about the population using sample data, and it is used in hypothesis testing, confidence intervals, and many more such inferences. Alright. So a basic example would be, say you want to measure the average height of students in a school. Now the individual heights might vary a lot and may not follow a normal pattern, right? But if you repeatedly take random samples of students, calculate the average height for each sample, and then plot these averages, the graph will eventually form a normal distribution as the sample grows. Alright. So the importance of CLT in data science is mainly the foundation for statistical analysis. So stats plays a major role in data science, and CLT is a basic foundation of stats, right? Many statistical methods assume normality, and CLT is going to ensure that we can apply these methods even when the original data isn't normal. Alright. Then comes sampling and efficiency. Alright. So instead of analyzing the entire population, we can work with smaller and more manageable samples and still get reliable results. Finally, we have hypothesis testing. Alright. So CLT is used to calculate confidence intervals and perform hypothesis tests, which are essential for making data-driven decisions. Alright. So this is the importance of CLT in data science. Moving on to the 26th question. How do you decide which learning algorithm to use for a given problem? Now, choosing the right learning algorithm depends on multiple factors, such as the problem type, okay, the size of the data set, then finally the outcome, that is the outcome you desire. Now here is how you can make a decision step by step. Alright. So you need to start by understanding whether you're solving a regression problem, that is you're predicting continuous values, or is it a classification problem where you have categorical data, or it could be a clustering problem where you have to group similar data. Alright. Then comes the data set size. So if you have a small data set, you can use algorithms like logistic regression or SVM that go better with the smaller data.
But if you have larger data sets, you need to use algorithms like random forest or neural networks that can handle the complexity and the big scale, right? Then comes your computational power. So if you have limited resources, you can use simpler models like linear regression or decision trees, right? You should not go for something complex like random forest. But if you have computational intensive tasks like image recognition, you have to go for neural networks, right? Then if you need high accuracy, that is your outcome. If you need a higher accuracy, especially if you have a complex problem, then you need to choose an algorithm like gradient boosting or deep learning, right? If your data is very noisy, you need ensemble methods like random forest that can reduce the overfitting. And if you have imbalanced data, you need to go for algorithms like SMART, that is synthetic minority oversampling technique, or you can combine it with SPM. Alright? So this is basically how you choose your learning algorithm. Moving on to the 27th question. Now this is a sort of scenario based question which have a very high chance of being asked in an interview. So the question goes, your features have values ranging from 1 to 10,000. How would you prepare the data for machine learning? Alright. Now in order to prepare the data with features ranging from 1 to 10,000, you'll need to scale it. Alright, so machine learning models work much better when features are on a similar scale, especially when ranges vary widely. Now a typical example of a dataset containing values from 1 to 10,000. Basically, a dataset containing outliers would be, say, we are analyzing the salaries of various groups of people. Alright. Now, there would be people who would be earning in thousands, somebody would be earning in lakhs, and there would be a very few people who would be earning in crores as well. Alright. So now the people who would be earning in crores would barely be either 4 or 5. Right? These people are basically the outliers in our data set. Now, before we go ahead and train our model, we need to take care of these outliers or these values that range widely, right? So, some of the techniques that can be used in scenarios like this would be normalization or standardization. Right. So again, I have a separate video covering these topics of normalization and standardization, their implementation, the theoretical aspects, when to use which particular concept in complete detail. So you can go ahead and check it out. All right. So normalization basically use methods like min-max scaling, which helps to bring the values between 0 and 1. All right. Whereas standardization uses mean of 0 and standard deviation of 1. Alright. So this basically helps models perform more efficiently. Right. So again, you need to choose your right scaling technique. So if your data has outliers, normalization is going to work better. But if your data does not have outliers, you need to perform standardization. Alright. Let's quickly look at one small implementation. So I have a cricket data set, and when I plot the various aspects of my data set, like my innings, my not outs, my runs, and the high score and so on, I can see a lot of outliers in my data set, right? Now to tackle this situation, what I'm going to do is I'm going to perform standard scaler, alright? So I've imported standard scaler from sklearn.preprocessing. I've called my function, and then I've simply fit and transformed it on my data, right? So once my data set is scaled, that is the values are arranged between the mean of 0 and standard deviation of 1. This is what my data set is going to look like. And after my data set is scaled, I can go ahead and train my model for a better accuracy. All right. Moving on to the 28th question, which is also a scenario based question. So the question goes, your data set has missing values. Now, what are the steps that you're going to take to handle them? Now, in order to deal with the missing values in a data set, you first need to understand the nature of your missing values, right? They could either be missing completely at random, or they could be missing at random, or they could be missing not at random. Now, what do these terms mean? So, missing completely at random basically means that there is no identifiable pattern. Alright. Missing at random means that the missing values are somehow correlated with other variables. Alright. And missing not at random means that they're related to the missing value itself. All right, so say for example, customers are not reporting low satisfaction scores. All right, so if a column consistently has missing values, that is, if a column has more than 50% of missing values, then the best option would be dropping the entire column itself. All right. But if that is not the case, that is, our missing values do not exceed 50%, the other possible techniques would be ignoring the missing values. That is, we drop the particular rows or the particular columns. Now, when do we drop the rows or drop the column? Whenever we have minimal missing data, that is, our missing data is less than 30%. Alright, so if a small percentage of rows or columns have missing data, we can consider dropping them without losing the significant information. Alright, so in order to perform this step, all we have to do is, let's say our data is stored in df variable, all we have to do is call drop na function. So this function is basically going to drop all the rows that contain the missing values. Now the next technique is imputing missing values. That is, we can replace the missing values with mean, median or mode. Alright. So whenever we have a data set that contains outliers, that is, say if we are dealing with a feature like salary, where our salary could range from 0 to even crores or even billions, millions. Alright. There is no end limit to this number, right? We could be considering the richest person in India, right? We could be considering his or her salary as well. So for features like this, we would have outliers, right? And if we were to take the mean or the average of this particular feature, our average would not be justified to the lowest and the highest value in this particular feature. So in cases like this, we would impute our missing values with something known as median. This would give us a more accurate representation or the more accurate imputation of our missing values. But if this is not the case, we are dealing with a regular feature, then we can go ahead and impute our missing values with our mean itself. Alright. And if we're dealing with categorical data, say we're dealing with a feature called fruits, right? We have apple, we have orange, and then we have some missing values. This is when we will use something known as mode. That is the most repeated value in that particular feature. Alright. So if we have minimal data missing, less than 30%, we just drop the rows or columns. If we have substantial data missing, then we impute the data. If we have categorical data, we use the mode or unknown for imputation. If we have predictive missingness, we create an indicator variable for missingness. And if we have mostly the entire column missing, that is more than 50%, we drop the entire column if it is non-critical. Alright. Moving on with the 29th question. An e-commerce website runs two designs for its homepage. How would you determine which one performs better? Now, this is a classic scenario of A/B testing. Alright. A/B testing is basically a method that compares two versions, A and B, it could be of a website or any other scenario, to determine which one performs better. Alright. Now, how does it work? So, A/B testing is basically going to split the website visitors randomly into two groups. So, group A is going to see design 1 and group B is only going to see design 2. Alright. So after the groups have seen the two designs, we are then going to measure the performance of both designs using a key metric like conversion rate. That is the percentage of users making a purchase. Alright. So we are going to separately calculate the conversion rate for group 1 and group 2. So whichever conversion rate is higher, we are then going to classify as that particular website page as more efficient than the other. Alright. So you need to define the goal. You need to identify the key performance metrics such as the click-through rate, purchases, and so on, right? It could be n number of factors depending on what kind of website you are building. Then you need to split the traffic. So you need to randomly divide the users into equal groups, right? Then you run the experiment, that is, you show each group their respective design for a set duration. Alright. Then lastly, you analyze the results, that is, you compare the metrics, that is the conversion rates, the click-through rate, or whatever other performance metric you have decided to determine the better design. Alright. So this is how you determine which one of the two versions you have made performs better. Alright. Moving on to the last question for this particular video. Your data set has 50 columns, but not all are useful. How would you choose the important ones? Alright. So this is a classic example of feature selection. So feature selection basically involves removing the irrelevant or redundant data, which is the main objective of our question over here, right? Out of the 50 columns, we need to keep only the relevant ones and remove the rest. Feature selection basically helps improve the model accuracy and performance, and it also reduces the computation time, right? So say for example, out of 50 columns, only 10 are useful. This is going to reduce the data size significantly, right? So the basic methods for feature selection are correlation analysis, right? You need to identify the highly correlated columns and remove the redundant ones, right? So basically, if two columns are highly correlated, one of them may be redundant or basically useless. So say for example, if age and years of experience are strongly correlated, you can keep either one of these, right? You can also use correlation heat maps in Python using the Seaborn library and the heat map function. Then comes feature importance using models. So you can use models like random forest or gradient boosting rank features by importance, right? So say for example, in predicting the house prices, your location feature might rank higher than paint color, alright? So there's a high probability that removing the paint color is just going to make your model better, right? Then comes statistical methods. So you can apply methods like ANOVA or chi-square to assess the feature significance. Then finally comes dimensionality reduction. So you can use techniques like PCA, principal component analysis, which as we discussed use eigenvalues and eigenvectors to reduce the features while retaining the key information. Alright.
It's been just a few years since we all started hearing about AI era is near, and some call it revolutionary while others thought it was just a hype. But guess what? AI era isn't just near now, it's here. And it's not just smart, it's getting hella lot of serious. AI powered automation is already knocking at our doors with the AI world evolving faster than ever. Why am I suddenly saying this? Well, the things in the fiction are no longer just fiction. It's a reality encoded in terms of artificial intelligence. Think about it. From transforming AI workflows to agents, writing code and managing systems, it has simplified everything smoothly and faster than ever. Not only this, but even the CEO of Cursor AI says now is the best time to build. I mean, just listen to this.
I actually think this is a really, really exciting time to be building software. Yeah. Like, we remember what programming was like in, 2013, 2012, whatever it was. And there was just so much more cruft and boilerplate and, looking up something really gnarly. And, that stuff still exists. It's definitely not at zero. But programming today is way more fun than back then. It's like we're really getting down to the delight, concentration, and all the things that really draw people to programming. Like, for instance, this element of being able to build things really fast and speed, and also individual control. Like, all those are just being turned up a ton. And so I think it's going to be a really, really fun time for people who build software. I think that the skills will probably change too.
And for all the tech dreamers out there, the ones who grew up imagining having a buddy just like Jarvis or Friday from Iron Man movies, someone we can talk to who can automate the tasks as well and execute them just through the commands. Even that is becoming possible. Yeah, that's no longer just a dream or a science fiction. It's the reality. What? Too stern to believe? It's all thanks to MCP servers. MCP servers, what are they? Think of MCP servers like a USB-C for AI. Instead of creating custom connections for each tool like GitHub, Gmail or database, MCP offers a universal plug-in and play system for AI to connect to any tool quickly, making integration simple, scalable and more efficient. Alright, MCP servers don't just make AI smarter, they transform it into a connected AI system. Like, imagine all your favorite tools, APIs, intelligent agents, from IDEs to large language models, all talking to each other and connected seamlessly. It's like turning your isolated AI models into an interactive, hyper-efficient ecosystem. So, to understand this in a better way, let me give you an example. We all developers use GitHub, right? For updating code, merging requests, managing repositories. It's a must-have, but also a time eater, because normally it takes hours or even days to streamline everything. But what if I told you You could automate those tasks in minutes with just one command in your code editor. Or another scenario, how many of you use Notion for better productivity, task organization and management? Almost everyone, right? Notion has already surpassed 100 million users worldwide, making it one of the most used tools. So how about if you could automate creating pages, updating the tasks, managing content with a single command, that too directly from your code editor? That's the power of MCP servers, and especially if you're into AI or development, this isn't anything you should miss at all. In this video, I'm not here to just tell you about them. I'm going to show you how to build your own MCP setup, turning your code editor into a mini Jarvis like assistant. So let's see it in action. Alright, now that we have discussed some stuff about MCP servers, how they work and why are they gaining so much popularity nowadays, now let's get straight into building our own MCP server. But before we start, here are the prerequisites that you will need to know. First is, what you will need is an AI code editor like Cursor, Windsurf or Cloud Desktop, then a GitHub and a Notion account. So first we will move up with setting up our GitHub server for automating our Git operations like creating a repo, adding files or even updating them. And yes, you can control the permissions you grant to this server. How? I'll show you in the video. So to start with, initially, I'll go with the GitHub MCP server. For that, I will go to MCP Server. So basically here, you will find a lot of tools from which you can build your MCP server for different tools. From that, what we need is this GitHub. So here, you can see all the things related to the GitHub MCP that is listed down, like how to use the key features, use cases, etc. So what we require is this server config file to create our own GitHub server. So copy it. Now go to the Cursor IDE. From here, go to settings, click on MCPs, add new global MCP, and it will automatically create a mcp.json file. So now paste the copied server config file here. Once this is done, we need to generate our GitHub personal access token to connect to your GitHub account safely. Because this is our GitHub MCP server config file, and this token, we have to generate it. For that, we will go to our GitHub account. From here, go to the top right corner, profile icon, then scroll down to the settings. This is it. Click on it. And lastly, you can find the developer settings here. Select on the personal access token, then click on the fine grained tokens. So this is one I created previously, but we will generate a new one. So here, now it will ask for a password. Now let me tell you why this will ask for password. Because you are giving the access to your GitHub account. You understand that, because it also gives the access for CRUD operations like create, update, read, delete, etc., which can be dangerous if in the wrong hands. For that, it asks for a confirm access. So provide the password you have for your account. Alright. So after providing the password, it will give you the access to generate personal access token. Now for the GitHub token name, I will name it as GitHub MCP. The description will be like to connect. Okay, this is not available. GitHub MCP server. This is available. So description will be to connect my GitHub account to the Cursor IDE through MCP server. Alright, so for the resource owner is basically your account name, like GitHub account name. Then for the expiration date, select 7 days as we are just experimenting with it. But if you need more, you can choose more days as well. But remember, if it is on the 7 days, your access token, which connects your GitHub repository to the cursor, will be expired after 7 days. After that, you have to generate a new one. So select on that basis. I will keep it as 7. After that, repository access, I will click on all repositories. After that, click on the permissions, repository permissions specifically. Then for the actions, I will give the read and write. Administration, read and write. Then for the commit statuses, this is it.
read and write, contents, read and write, issues, read and write. So whatever permissions you are going to give here, only that tasks can be performed by the MCP server. If you have given like for the deployments no access and you are trying to deploy something, it will not happen. For that you have to generate a new access token with this permission, read and write, and then you can do the operations based on that. So from now it is enough. So I will click on generate token. It will ask for a confirmation, click on it. Then here are your GitHub tokens. So copy it, then paste it on your cursor ID. So it should be here. So it is done. Now let's check our cursor settings. So let our GitHub MCP server, the dot here is green as you can see. Our GitHub MCP server is ready to perform our GitOps. So first what we will tell it as. So now I will ask it to create a new repository on my GitHub with the name how to build an AI agent from scratch. Okay, now let's see whether it executes or not. So yes, it is happening. So you have to accept this for the confirmation. Well, there's also a setting in here in the cursor settings where you can go and you can already turn on the auto enable so that it will not ask you for the permission or confirmation again and again, so that you don't have to confirm things again and again. You can go for that mode. So it has already built and it is saying the path is here. And let's see. So yeah, this is my account and this is the new repository we just created. Let's see it in details. The repo. See, updated now. It has been created just now. So since it is empty now, let's add a readme file. So now I will ask it to. So it is generating now. It means it is reading the files and accessing some resources from the web, and then it will generate it. So again I said you have to accept it. Boom, here is it. Now let's go and check it. Perfect. See, it has created a step-by-step guide in a readme file with resources, like whatever will be required. Now I'll ask it to create. So that was it for the GitHub MCP servers. And not only this, besides adding the files and creating the files, you can also execute other commands. Just for that, make sure to give those specific repo permissions while generating the GitHub personal access tokens. So that's it. And that's how we created our GitHub MCP server. And that's how we have covered the GitHub MCP servers, where you can directly give commands to the AI agents and they will execute all your GitHub operations smoothly and effortlessly without any manual work. Now that we have already created our GitHub MCP server, now let's move forward with the other MCP, that is Notion MCP server, which helps AI models to create and manage pages, databases, search for the content, add content blocks and comments, query the databases, retrieve and update the information on Notion, and much more. So to set up our Notion MCP, first we need to go to Make Notion MCP server GitHub repo. It is an official MCP server repo by Notion itself. Here you will find a proper setup guide for the MCP servers. So first we need a Notion integration to get an API key. As you can see, it is written even here. Yep, so here it is. Setting up the integration in Notion. For that we have to go to this profile. That is Notion.so profile. Now from here, we'll create a new integration. We'll give it as something like my MCP server. Okay. So let's say this. And this is our MCP server's internal integration secret API. which we will be needing further. Now, let's set the capabilities. We need the read content, update content, insert content, read comments, insert comments, and that's it. And we should save this. Okay, read user information without email address. And save this. Integration is successfully updated. Let's refresh this since we have updated the integration. Yeah. So we have this. Moving next, we need our server config file. For that, I will again go to the Notion MCP server of Neat Notion. Here we'll find the official server config file. We'll copy this, go to the cursor, add a new one, copy here, save. We have to replace this part with our secret internal integration key. So for that, we'll go to our integrations, copy this, go to cursor, paste it here, save it. Now go to cursor settings, refresh this. Now it is stable. Now we'll go to our integrations. Now online Notion profile. Now this is completely empty page, so I'll go to this 3 dots, scroll down for the connections. Then here I will search for my MCP server. Since that is our integration, we'll confirm it. Then it will be, yeah, you can see that my MCP server is connected here, active in the active connections, right? So since we have connected perfectly, now let's move forward and ask it, hey, list me all the pages in my Notion workspace. Let's see what it does. So here it is. It is running the API post search tool. Now we'll accept this. Wow, it gave me everything about it, like created, edited the last log also. So perfect. And it also analyzed that this appears to be only page in your workspace currently. The page is not archived, not in trash located. The main workspace has no cover page or echo set because we haven't created any kind of details in that page just yet, right? So then it asks us, would you like to see more details about this specific page, or would you like to perform any other operations with your Notion workspace? So I will ask it to write me a blog on the same topic as this page has in a impressive and impactful manner. So see, it is even writing the blog for it with a new page, that too. Alright, it's taking time. Yeah, so it finally found everything. Now it will create. Perfect. So now let's see what it has done. For that, let's check our Notion. Refresh. And this is the page it has generated. So you can see this, right? This is generated completely by the Notion MCP server. Now for the other tasks, I will ask it to add the images as well as per the context of the blog to make it more appealing and attractive. See, it can even add the images as well. It's searching for the images and it finally found it. So I'll accept this. So again, accept. You can see these tools, right? So these are the tools that come bundled into the MCP Server APIs, or like whatever API you use for, like the GitHub one, Notion one, even the Firecrawl or Google Workspace. There are certain tools like API Patch Block Children, API Patch Page, and what we created above, API Post Page. These are the tools that is using to fetch, create, and analyze the information. Okay, it says it has already done it. Hiding the images. Let's check out. Refresh. Creative enough. That was cool, isn't it? So this is what MCP servers are. With just one command, it can perform marvelously. This is really impressive, I mean. So that was it, guys. This was the tutorial for the Notion MCP server. Now, since we have already set up the GitHub MCP server as well as the Notion MCP servers, tell me which server would you like to create, like which is your favorite tool and which is your favorite created MCP servers. Let me know that, okay? Alright. Just a quick info, guys. Intellipaat offers a data science course in collaboration with iHub IIT Roorkee, which will help you master concepts like Python, SQL, machine learning, AI, Power BI, and more. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth with the data science course.